Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it.
We are beginning a new topic today, statistics. Here are the objectives that we look forward to achieving at the end of this topic. At the end of this topic, you should be able to construct a grouped or an ungrouped frequency distribution table for a given data. You should be able to present a statistical data graphically. You should be able to find the measures of central tendencies for a given data. And you should be able to find the measures of dispersion for a given data. So here are our objectives for this topic. Don't worry if you don't understand some of the terms here. You are going to get it as the lesson progresses. Now let's learn more about statistics. Statistics is the branch of mathematics which deals with the collection, presentation, and analysis of data and drawing conclusions on the basics of the data. So basically in statistics, we collect data about a particular subject. Then we present the data in an organized manner using tables and graphs. Then after that, we analyze the data, and finally, based on our analysis, we draw conclusions. In JHS, we learned some basic things about statistics. We are going to go over those things in this lesson, then we will build on that to learn some new things. In our lesson on statistics, we are going to concentrate on presentation of data and analyzing the data. So in our lesson on statistics, we are going to learn how to present data obtained from a statistical survey and how to analyze the data. We will begin with presentation of data. Presentation of statistical data. As I've already said, data collected from a statistical survey is usually presented using tables and graphs. An example of a table used to present statistical data is a frequency distribution table. So a frequency distribution table is a table that is used to present a statistical data. Some examples of graphs used to present statistical data are bar charts, pie charts, histogram, cumulative frequency curve, and others. In our lesson on statistics, we are going to learn how to use a frequency distribution table and these graphs that we have mentioned here to present statistical data. We will begin with a frequency distribution table. So in the next video, we are going to learn how to use a frequency distribution table to present data obtained from a statistical survey. Thank you for watching this video. Subscribe to this channel for more videos. As I've already said, in the next video, we are going to learn how to use a frequency distribution table to present data obtained from a statistical survey. Bye-bye. Welcome back. We are on the topic statistics. In the previous video, we learned some basic things about statistics. In this video, we are going to learn about a frequency distribution table and how to use it to present statistical data. Frequency distribution table. As we learned from the previous video, a frequency distribution table is used to present statistical data. A simple frequency distribution table contains a column for max, tally, and frequency. So this is how a simple frequency distribution table looks like. We have one column for max, another column for tally, and another one for frequency. In order for us to understand how to present statistical data in a table like this, let's consider this simple example. Let's assume that these are the ages of 10 children found in the hospital's children's ward. So the first child is 3 years old, The second, third, and fourth are all 5 years old. The fifth, sixth, and seventh are 8 years old. The 8th, 9th, and 10th are 5 years old. So this is the data that we have. We can present this data in the frequency distribution table we have here. Let's consider how we will do it. So the first column is marks. In a frequency distribution table, the marks refers to the item under consideration. From our example here, the item under consideration is the ages of children in a children's hospital. So the marks refers to the ages. If we are talking about the wages of employees in a certain company, then the marks will be the wages of the employees. Or if we are talking about the height of students in a particular class, then the marks will refer to the height of the students in the class. So the marks refers to the item under consideration. The marks is usually listed in ascending order. So we list it from the smallest to the highest. So you check the data given to you and you list the marks from the smallest to the highest. From our example here, we can see that the ages of the children are either 3, 5, or 8. So that will be the marks. 3, 5, and 8. And remember, we have to list them in ascending order. So the first one will be 3, the second one will be 5, and the last one will be 8. Now let's move on to the next column, which is tally. The tally is a count of the marks. Each mark is shown using a stroke. So for the tally, we will count the marks that we have. So if we take the first mark, which is 3, we will count the number of 3s that we have in the data that has been given to us. From our data, we can see that we have only 1 3. So the tally for 3 is 1. As we have seen from the point here, it says that each mark is shown using a stroke. We have 1 for 3, so you show it using a single stroke. Then you move on to the next mark. The next mark is 5. So you come to your data and you count the number of 5s that we have. From our data here, the number of 5s are 1, 2, 3, 4, 5, and 6. So we have 6 of the 5s. Each mark is shown using a stroke. So you are going to have 6 strokes. So we have 1, 2, 3, 4. Now, when you are doing the tally, when you get to the 5th stroke, you use it to cross the 4 that you have already done. So the 5th stroke will be used to cross the 4 to show that we have 5 strokes here. Then the next one will be a single stroke again. So this shows that we have a tally of 6. Then we move on to the next mark. The next mark is 8. You come to the data and you count the number of 8s that we have. We have 1, 2, and 3. So we have 3 of them. Each one is shown using a single stroke. So you have 1, 2, 3. So this is how to get the tally. The tally is a count of the marks, and each mark is shown using a stroke. Let's move on to the last column, which is frequency. Frequency is the tally obtained for each mark. So under frequency, we will write the tally that we got for each mark. From our table, we can see that for 3, we had a tally of 1. So our frequency will be 1. For 5, we had a tally of 6. So our frequency will be 6. And for 8, we had a tally of 3. So our frequency will be 3. So we have been able to present the data that was given to us in a simple frequency distribution table. A frequency distribution table may contain more than 3 columns. It depends on the analysis that we are going to perform on the data. So depending on the analysis that we want to perform on the data, more columns may be added to the frequency distribution table. We are going to learn about that as the lesson progresses. A frequency distribution table may be grouped or ungrouped. We will learn how to construct each of them. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to construct an ungrouped frequency distribution table. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned some basic things about a frequency distribution table. In this video, we are going to learn how to construct an ungrouped frequency distribution table for a given data. Let's consider this question. The ages of 20 students in a class are given below. So we have the ages of 20 students here. We have been asked to construct a frequency distribution table for the data above. The frequency distribution table we are going to construct for this data will be an ungrouped frequency distribution table. So let's see how to go about it. We have the data here. These are the ages of the 20 students. In the previous video, we learned that a simple frequency distribution table has 3 columns. The first column will contain the max, the second one will contain the tally, and the third one will contain the frequency. And we also learned that the max is the item under consideration. For this particular data, what we are considering is the ages of students in a class. So the max will be the ages. So the first column of the table will contain the ages, the second column will contain the tally, and the third column will contain the frequency. So you have a table of 3 columns. The number of rows will depend on the different ages that we have in the data. From our data, we can see that if we pick a student from the class, the student will either be 10 years old, 11 years old, 12 years old, 13, 14, 15, or 17. These are the different ages that we have in the data. They are 1, 2, 3, 4, 5, 6, 7 in number. So we have 7 different ages. When we construct the table, the first row will contain the heading and the remaining rows will contain the different ages that we have. We have 7 different ages and the first row will contain the heading. So when we add that first row to the 7 that we already have, we are going to have 8 rows. So it means that we are going to construct a table that has 3 columns and 8 rows, and that is exactly what we have here. The first row will contain the heading. So you have the age here, you have the tally here, and you have the frequency. Then after that, we will list the different ages that we have in the first column. Remember that when we are listing the ages, we will do that in ascending order. That is from the smallest to the highest. So the first one will be 10, the second one will be 11, the third one will be 12, the fourth one will be 13, the fifth one will be 14, the sixth one will be 15, and the seventh one will be 17. We have now completed the first column. Let's move on to the second column, which is the tally. From the previous video, we learned that the tally is a count of the marks, and each mark is represented with a stroke. Here, the marks are the ages of the students. So we will go through the data one after the other, and we will count the number of students that corresponds to each age. Remember that we use a stroke to represent each count. So let's begin. The first one is 10. So the age 10 will have 1 stroke. I'm going to cancel it out so that you can see that we have counted it. The next one is 12. so the age 12 will have 1 stroke. The next one is 11, so the age 11 will have 1 stroke. The next one is 13, so the age 13 will have 1 stroke. The next one is 14, so 14 will have 1 stroke. The next one is 11, so the age 11 will have another stroke. The next one is 10, so the age 10 will have another stroke. The next one is 15, so 15 will have 1 stroke here. The next one is 10, so 10 will have 1 stroke here. The next one is 12, so 12 you have 1 stroke here. The next one is 14, so 14 you have 1 stroke. The next one is 12, so 12 will have another stroke. The next one is 10, so 10 will have another stroke. The next one is 13, so 13 will have another stroke here. The next one is 15, so 15 will have another stroke. The next one is 17, so 17 will have 1 stroke. The next one after that is 11, so 11 will have another stroke. The next one is 12, so 12 will have another stroke here. The next one is 14, so 14 will have another stroke. And the last one is 10. When we look at the tally for 10, we already have 4 strokes, so the fifth one will be used to cross the 4 that we already have. So we have gone through the data and we have counted the number of students that corresponds to each of these ages. We are now done with the tally. Let's move on to the third column, which is the frequency. From the previous video, we learned that the frequency is the tally that we have for each mark. So here, the frequency will be the tally that we have for each age. For age 10, the tally is 5. For age 11, the tally is 3. For age 12, the tally is 4. For age 13, the tally is 2. For age 14, the tally is 3. For age 15, the tally is 2. And for age 17, the tally is 1. I'm going to clean the ink that we have on the page so that you can see the table clearly. So this is a simple frequency distribution table for the data that was given to us. This is an example of an ungrouped frequency distribution table because we used the individual marks that was given to us in the data to construct the table. We did not group the marks into intervals before constructing the table. So when you use the individual marks in the data to construct a frequency distribution table, the table you have constructed is known as an ungrouped frequency distribution table. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on constructing an ungrouped frequency distribution table for a given data. Bye-bye. Welcome back, guys. We are still on the topic statistics. In the previous video, we solved a question on constructing an ungrouped frequency distribution table for a given data. In this video, we are going to solve another question. Here is the question. The following data shows the marks obtained by students in a test. So the data has been given to us here. The question tells us to construct a frequency distribution table for the data. In this particular frequency distribution table, we are going to use the individual marks that was given to us in the data. We are not going to group them into intervals. So the frequency distribution table we are going to construct will be an ungrouped frequency distribution table. Let's look at how we will do that. So we have the data here. In the introductory video, we learned that a simple frequency distribution table contains 3 columns. The first column will be for the marks, the second column will be for the tally, and the third column will be for the frequency. The marks refers to the item under consideration. For this particular data, the item we are considering is the marks of students in an exam. So the first column will contain the marks that the students scored in the exam. We know that our table will have 3 columns, but what will be the number of rows? The first row of the table will contain the heading, and the remaining rows will contain the different marks that we have in the data. So we have to count the different marks that we have in the data. From the data that we have here, the different marks are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. When we count them, they are 11 in number. So in our table, the first row will contain the heading, so that will be the first row. Then we will need to have 11 rows for each of these marks. So 11 plus 1 will give us 12. So it means that we are going to have 12 rows in our table. So we are going to construct a table with 3 columns, and 12 rows. I'm going to clean the ink from the page so that we can construct the table. So this is our table. We have 3 columns and 12 rows. The first row will contain the heading. So the first one will be the marks scored by the students in the test. The next one will be the tally, and the third one will be the frequency. We are going to list the marks in ascending order. That is from the smallest to the highest. The first one will be 0, followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are now done with the first column. Let's move on to the tally, which is the second column. The tally is a count of the marks, and each mark is represented with a stroke. So we will go through the data and we will count the number of each of these marks we have in it. Let's begin with the first one. The first one is 6. So for 6, we will have 1 stroke. I'm going to cancel that out so that you can see that we have counted it. The next one is 9. So for 9, we will have 1 stroke. The next one is 5. So for 5, you have 1 stroke. The next one is 9. So for 9, you have another stroke. The one after that is 5. So for 5, you have another stroke here. The next one is 2. So for 2, you have 1 stroke. The next one is 7. So for 7, you have 1 stroke here. The next one is 10. So for 10, you have 1 stroke. The next one is 2. So for 2, you have another stroke here. The next one is 9. So for 9, you have another stroke. The next one is 6. So you have another stroke for 6. The one after that is also 6. So you have another stroke for 6. The next one is 5. So you have another stroke for 5. The next one is 6. So we have 1 stroke for 6. The next one is 9. We have 1 stroke for 9 here. The next one is 3. So we have the first stroke for 3. The next one is 7. We have another stroke for 7. The one after that is 5. So we have another stroke for 5. Then the one after 5 is also 5. But we already have 4 strokes for 5. So the 5th one will be used to cross it. So we have 5 here. The next one is 6. 6 is also having 4 strokes already. So you use the 5th one to cross it. The one after that is 8. So this will be the first stroke for 8. The one after that is 0. So we have the first stroke for 0. Then we have 6 again. So that will be the 6th stroke. The next one is 2. So we have another stroke for 2. The one after that is 6. So we have another stroke for 6. The one after that will be 7. So we have another stroke for 7. After 7, we'll have another 7 again. So we have another stroke for 7. Then the one after that is 4. So we have the first stroke for 4. The next one is 1. So we have the first stroke for 1. And the last one is 8. So we have a second stroke for 8. We are now done with the tally. Let's look at the frequency. The frequency is the tally that we have for each mark. So for 0, we have a tally of 1. For 1, we have a tally of 1. For 2, we have 3. For 3, we have 1. For 4, we have 1. For 5, we have 5. For 6, we have 7. For 7, we have 4. For 8, we have 2. For 9, we have 4. And for 10, we have 1. So we have been able to construct a simple frequency distribution table for the data that was given to us. And this is an example of an ungrouped frequency distribution table. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to construct a grouped frequency distribution table for a given data. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to construct an ungrouped frequency distribution table for a given data. In this video, we are going to learn how to construct a grouped frequency distribution table for a given data. Let's consider this question. The number of goals scored by 36 football teams in a competition are as follows. So we have the number of goals here. The question says that construct a frequency distribution table using the intervals 0 to 9, 10 to 19, 20 to 29, etc. When you compare this question to the ones that we have solved in the previous videos, you will see that there's a slight difference. For this question, we have been asked to draw the frequency distribution table using these intervals. So what we are going to do is that we are going to group the number of goals scored by the football teams under these intervals. And because we are going to group the data we have here under these intervals, the frequency distribution table we are going to construct will be a grouped frequency distribution table. Let's see how to go about that. So we have the data here. The question says that we should use the intervals 0 to 9, 10 to 19, 20 to 29, etc. to construct the frequency distribution table. We have learnt from the introductory videos that a simple frequency distribution table has 3 columns. The first column will be for the marks, the second column will be for the tally, and the third column will be for the frequency. So our table will also have 3 columns. The first column will be for the marks, which is the number of goals scored. The second column will be for the tally, and the third column will be for the frequency. Now let's determine the number of rows that the table will have. The number of rows that the table will have will depend on the largest value that we have in the data. So to get the number of rows, we first have to find the largest value that we have in the data. So you go through the data carefully and you pick the largest value. From this data, our largest value is 49. After you have identified the largest value, you continue the intervals given to you in the question until you get to the interval that will contain the largest value. Looking at the intervals given to us in the question, the next one will be 30 to 39. But the largest value we have is 49. 49 does not fall within this interval, so it means that we have to move on to the next interval. The next interval will be 40 to 49. 49 falls within 40 to 49, so it means that 40 to 49 will be the last interval. We have 5 intervals in total. Each interval will occupy one row in the table. The heading will also occupy one row. So in total, we are going to have 6 rows. So the table we are going to construct will have 6 rows and 3 columns. I'm going to clean the ink that we have from the page so that we can draw the table. So this is our table. It has 6 rows and 3 columns. The first column will contain the heading. So we have the goals scored here, we have the tally, and we have the frequency. After that, we will list the intervals that we have under the goals scored. So the first interval is 0 to 9. The second interval is 10 to 19. The third interval is 20 to 29. The fourth interval is 30 to 39. And the last one is 40 to 49. We are now done with the first column. Let's move on to the second column, which is the tally. From the previous videos, we have learned that the tally is a count of the marks, and each mark is represented with a stroke. Here, we are using intervals. So we will go through the data and we will count the marks that falls under each of these intervals. Let's begin with the first one. The first one is 31. So we will look at the interval that 31 falls under. 31 will fall under the interval 30 to 39. So 30 to 39 will have one stroke. So 31 has been counted. I'm going to cross that out so that you see that we have counted it. The next one is 40. 40 will fall under 40 to 49. The next one is 20. 20 will fall under 20 to 29. The next one is 35. 35 will fall under 30 to 39. The next one is 21. 21 will fall under 20 to 29. The next one is 12. 12 will fall under 10 to 19. The next one is 11. 11 will also fall under 10 to 19. The next one is 39. 39 will fall under 30 to 39. The next one is 16. 16 will fall under 10 to 19. The next one is 0. 0 will fall under 0 to 9. The next one is 28. 28 will fall under 20 to 29. The next one is 49. 49 will fall under 40 to 49. The next one is 29. 29 will fall under 20 to 29. The next one is 32. 32 will fall under 30 to 39. The next one is 17. 17 will fall under 10 to 19. The next one is 2. 2 will fall under 0 to 9. The next one is 12. 12 will fall under 10 to 19. But we already have 4 strokes here, so we will use the 5th stroke to cross it. The next one is 24. 24 will fall under 20 to 29. We already have 4 strokes here, so we will use the 5th one to cross it. The next one is 14. 14 will fall under 10 to 19. So we have that here. The next one is 1. 1 will fall under 0 to 9. The next one is 10. 10 will fall under 10 to 19. The next one is 23. 23 will fall under 20 to 29. The next one is 19. 19 will fall under 10 to 19. The next one is 13. 13 will fall under 10 to 19. The next one is 26. 26 will fall under 20 to 29. The next one is 30. 30 will fall under 30 to 39, but we already have 4 strokes here, so you use the fifth one to cross it. The next one is 10. 10 will fall under 10 to 19. We have 4 strokes here, so you use the fifth one to cross it. The next one is 21. 21 will fall under 20 to 29. The next one is 18. 18 will fall under 10 to 19. The next one is 0. 0 will fall under 0 to 9. The next one is 15. 15 will fall under 10 to 19. The next one is 11. 11 will fall under 10 to 19. The next one is 29. 29 will fall under 20 to 29. The next one is 8. 8 will fall under 0 to 9. We have 4 strokes here, so you use the fifth one to cross it. The next one is 12. 12 will fall under 10 to 19. And the last one is 1. 1 will fall under 0 to 9. So 0 to 9 will have another stroke here. We are now done with the tally. Let's move on to the last column, which is the frequency. The frequency is the tally that we have for each interval. So for the interval 0 to 9, we have a tally of 6. For the interval 10 to 19, we have a tally of 14. For the interval 20 to 29, we have a tally of 9. For the interval 30 to 39, we have a tally of 5. And for the interval 40 to 49, we have a tally of 2. So we have been able to construct a grouped frequency distribution table for the data that was given to us. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on constructing a grouped frequency distribution table for a given data. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to construct a grouped frequency distribution table for a given data. In this video, we are going to solve another question on constructing a grouped frequency distribution table for a given data. Let's consider the question. The number of students in 50 schools are as follows. So we have the number of students here. The question says that we should construct a frequency distribution table using the intervals 25 to 35, 35 to 45, etc. Because we are going to use these intervals to construct the table, the frequency distribution table we are going to construct will be a grouped frequency distribution table. Let's see how to go about that. So we have the data here. As usual, our table will have 3 columns. The first column will contain the max. The max is the item under consideration. For this particular data, we are talking about the number of students in a school. So the max will be the number of students. The second column will be the tally, and the third column will be the frequency. The number of rows will depend on the highest value that we have in the data. So you go through the data and you pick the highest value. In our data, the highest value is 69. The question said we should use the intervals 25 to 34, 35 to 44, and so on to construct the table. The highest value we have in the data is 69. So we are going to continue these intervals until we get to the interval that will contain 69. Looking at this pattern, the next interval will be 45 to 54. 69 does not fall between 45 to 54, so it means that we have to move on to the next interval. The next interval will be 55 to 64. Again, 69 does not fall between 55 to 64, so we move on to the next interval. The next one after this will be 65 to 74. 69 falls between 65 to 74, so it means that 65 to 74 will be our last interval. Each of these intervals will occupy one row in the table. So under the number of students, the first row will be 25 to 34, the second row will be 35 to 44, the third row will be 45 to 54, the fourth row will be 55 to 64, and the last row will be 65 to 74. I'm going to clean the ink from the page so that we can continue with the next column, which is the tally. The tally is a count of the marks. So we are going to go through the data one after the other, and we will count the marks that falls under each of these intervals. Let's begin with the first one. The first one is 42. So we will look at the interval that 42 falls under. 42 falls under the interval 35 to 44. So 35 to 44 will have one stroke. I'm going to cross that out so that you will see that we have counted it. The next one is 28. 28 will fall under 25 to 34. The next one is 48. 48 will fall under 45 to 54. The next one is 31. 31 will fall under 25 to 34. The next one is 37. 37 will fall under 35 to 44. The next one is 38. 38 will also fall under 35 to 44. The next one is 35. 35 will fall under 35 to 44. The next one is 40. 40 will also fall under 35 to 44. But we already have 4 strokes here, so we are going to use the fifth one to cross it. The next one is 32. 32 will fall under 25 to 34. The next one is 45. 45 will fall under 45 to 54. The next one is 44. 44 will fall under 35 to 44. The next one is 61. 61 will fall under 55 to 64. The next one is 47. 47 will fall under 45 to 54. The next one is 35. 35 will fall under 35 to 44. The next one is 42. 42 will fall under 35 to 44. The next one is 45. 45 will fall under 45 to 54. The next one is 29. 29 will fall under 25 to 34. The next one is 40. 40 will fall under 35 to 44. The next one is 38. 38 will fall under 35 to 44. But we already have 4 strokes here, so the fifth one will be used to cross it. The next one is 45. 45 will fall under 45 to 54. We already have 4 strokes here, so we use the fifth one to cross it. The next one is 36. 36 will fall under 35 to 44. The next one is 41. 41 will fall under 35 to 44. The next one is 38. 38 also falls under 35 to 44. The next one is 61. 61 will fall under 55 to 64. The next one is 47. 47 will fall under 45 to 54. The next one is 48. 48 also falls under 45 to 54. The next one is 37. 37 will fall under 35 to 44. The one after 37 is also 37, so it also falls under 35 to 44. But we already have 4 strokes here, so the fifth one will be used to cross it. The next one is 59. 59 falls under 55 to 64. The next one is 38. 38 will fall under 35 to 44. The next one is 57. 57 will fall under 55 to 64. The next one is 51. 51 will fall under 45 to 54. The next one is 60. 60 will fall under 55 to 64. But we already have 4 strokes here, so we will use the fifth one to cross it. The one after 60 is 58. 58 will fall between 55 to 64. The next one is 44. 44 falls under 35 to 44. The next one is 67. 67 falls under 65 to 74. The next one is 62. 62 will fall under 55 to 64. The next one is 51. 51 will fall under 45 to 54. The next one is 44. 44 falls under 35 to 44. The next one is 47. 47 falls under 45 to 54. But we already have 4 strokes here, so we use the fifth one to cross it. The next one is 69. 69 falls under 65 to 74. The next one is 63. 63 will fall under 55 to 64. The next one is 54. 54 will fall under 45 to 54. The next one is 39. 39 will fall under 35 to 44. The next one is 47. 47 will fall under 45 to 54. The next one is 50. 50 will fall under 45 to 54. The next one is 33. 33 will fall under 25 to 34. But we already have 4 strokes here, so use the fifth stroke to cross it. The next one is 56. 56 falls under 55 to 64. The next one is 35. 35 will fall under 35 to 44. We have 4 strokes here already, so you use the fifth one to cross it. And the last one is 64. 64 falls under 55 to 64. We already have 4 strokes here, so you use the fifth one to cross it. So we are now done with the tally. Let's move on to the frequency. The frequency is the tally that we have for each interval. For the interval 25 to 34, we have a tally of 5. For the interval 35 to 44, we have a tally of 20. For the interval 45 to 54, we have a tally of 13. For the interval 55 to 64, we have a tally of 10. And for the interval 65 to 74, we have a tally of 2. We have been able to construct a grouped frequency distribution table for the data that was given to us. In the introductory videos, we learned that statistical data can be presented using tables and graphs. So far, we have learned how to use a grouped and an ungrouped frequency distribution table to present statistical data. In the next video and the subsequent ones, we are going to learn how to use graphs to present statistical data. We will begin with a pie chart. So in the next video, we are going to learn how to use a pie chart to present statistical data. Bye-bye. Welcome back. We are still on the topic statistics. In the previous videos, we have learned how to use a frequency distribution table to present statistical data. In this video, we are going to learn how to use a pie chart to present statistical data. Let's start. A pie chart is used to present a given data pictorially using the sectors of a circle. So for example, if we consider this data, the data we have here, the number of different fruits on display in a shop are as follows. So we have mangoes, we have bananas, we have apples, and we have oranges. There are 10 mangoes, 12 bananas, 15 apples, and 8 oranges. We can present this data in a circle such that each fruit will occupy a sector of the circle, like the chart we have here. On our chart, we can see that each fruit occupies a sector in the circle. This is an example of a pie chart. So a pie chart is used to present a given data in a circle such that each item in the data occupies a sector of the circle. In a pie chart, the sector for each item will have an angle. So for example, on our pie chart here, the sector for mango will have its own angle. Let's call that A. The sector for banana will have an angle. Let's call that B. The sector for apple will have an angle. Let's call that C. And the sector for orange will also have an angle. Let's call that D. In the videos on mensuration, we learned that the sum of the angles around a point, or the sum of the angles in a circle, is 360 degrees. What this means is that if we sum A, B, C, and D, we are going to get 360 degrees. Before we can draw this pie chart for the data that has been given to us, we will have to find the values of each of these angles. So we have to find the value of A, B, C, and D. We are going to learn how to do that. We have the data here. The number of mangoes are 10. The number of bananas are 12. The number of apples are 15. And the number of oranges are 8. Before we can calculate the angle of sector for each fruit, the first thing we have to do is to find the sum of the values assigned to the items. The value assigned to mango is 10. The value assigned to banana is 12. The value assigned to apple is 15. And the value assigned to orange is 8. We are going to find the sum of these values. I'll create another row, then I'll sum the values we have here. 10 plus 12 plus 15 plus 8 is 45. Then after that, I'll introduce another column in the table, and that column will be for the angle of sector. So we are going to find the angle of sector for each item here. How do we find that? The angle of sector for an item is equal to the value of the item divided by the sum of the values for all the items times 360 degrees, which is the sum of the angles in a circle or the sum of the angles around a point. So to find the angle of sector for an item, we will first pick the value of that item. Then we will divide it by the sum of the values for all the items. Then after that, we will multiply it by 360 degrees. So the angle of sector for mango will be equal to the value of mango, which is 10, divided by the total, which is 45, times 360 degrees. And this gives us 80 degrees. The angle of sector for banana will be equal to 12 divided by 45 times 360 degrees, and that will give us 96 degrees. The angle of sector for apple will be equal to 15 divided by 45 times 360 degrees, and this gives us 120 degrees. The angle of sector for orange will be equal to 8 divided by 45 times 360 degrees, and this gives us 64 degrees. If we add 80 degrees to 96 degrees to 120 degrees to 64 degrees, we are going to get 360 degrees, which is the sum of the angles in a circle or the sum of the angles around a point. So this is how to find the angle of sector for an item when you are asked to draw a pie chart for a given data. After finding the angle of sector for each item, you can now draw the pie chart. So you use a protractor to draw the angles for each of the sectors in a circle. So you begin by drawing a circle, then you draw a radius in the circle, that is a line from the center of the circle to a point on the circumference. Then after that, you draw these sectors using the angles that you have calculated. The first one is 80 degrees, so you use the protractor to measure 80 degrees, and that will be the sector for mango. The next one is 96 degrees, so you use the protractor to measure 96 degrees, and that will be the sector for banana. The next one is apple, and that is 120 degrees, so you use the protractor to measure 120 degrees, and that will be the sector for apple. And the last one will be 64 degrees, and that is the sector for orange. This is how to draw a pie chart for a given data. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply what we have learned in this video to solve a question. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to use a pie chart to present statistical data. In this video, we are going to apply what we studied in the previous video to solve a question. Let's consider the question. It says that the table below shows the number of students who offer certain languages in a school. So in the table, we have 6 different languages, and the number of students who offer these languages have been given to us. The question is asking us to draw a pie chart to illustrate the data. We learned how to do something like this in the previous video, so we are going to apply it in this video to solve the question. So we have the table here. The number of students who offer English are 50. The number of students who offer GA are 15. The number of students who offer Chi are 25. The number of students who offer Enzima are 35. The number of students who offer Fanti are 20. And the number of students who offer Hausa are 55. From the previous video, we learned that we will introduce another row where we will find the total of these numbers. From the previous video, we learned that in order to calculate the angle of sector for each of these languages, we first have to find the total number of students. So we are going to add 50, 15, 25, 35, 20, and 55. When we add them together, we will get 200. So it means that the total number of students is 200. We can now calculate the angle of sector for each of these languages. From the previous video, we learned that the angle of sector for an item is equal to the value assigned to that item divided by the sum of all the values times 360. So here, the angle of sector for English will be equal to the number of students who offer English, which is 50, divided by the total number of students, which is 200, times 360. And this will give us 90 degrees. The angle of sector for GA will be the number of students who offer GA, which is 15, divided by the total number of students, which is 200, times 360 degrees. And this will give us 27 degrees. The angle of sector for Chi will be equal to the number of students who offer Chi, which is 25, divided by the total number of students, which is 200, times 360 degrees, and this will give us 45 degrees. The angle of sector for Enzima will be equal to the number of students who offer Enzima, which is 35, divided by the total number of students, which is 200, times 360 degrees, and this will give us 63 degrees. The angle of sector for Fanti will be equal to the number of students who offer Fanti, which is 20, divided by the total number of students, which is 200, times 360 degrees, and that will give us 36 degrees. And lastly, the angle of sector for Hausa will be equal to the number of students who offer Hausa, which is 55, divided by the total number of students, which is 200, times 360 degrees, and this will give us 99 degrees. If we add the angle of sector for all these languages together, we are going to get 360 degrees, which is the sum of the angles in a circle or the sum of the angles around a point. We have now calculated the angle of sector for each language, so we can use the angles that we have to draw the pie chart. We will begin by drawing a circle. Then after that, we will draw a radius, that is a line from the center of the circle to any point on the circumference. We are going to measure out the angles we have here one after the other using a protractor. So you take your protractor. I have my protractor here. The center of the protractor is the point where the 90 degrees line meets the 0 degree line. On my protractor, the 90 degrees line meets the 0 degree line at this point. So this point is the center of the protractor. We are going to begin by measuring the 90 degrees angle. We will do that by moving the center of the protractor to the center of the circle. So I'm going to move the protractor such that the center falls on the center of the circle. So the center of the protractor should be on the center of the circle. Then after that, you turn the protractor such that the radius that you drew falls on the 0 degree line, just as I have here. So you have to make sure of two things. The center of the protractor should be on the center of the circle. Then the 0 degree line should fall on the radius that you have drawn. We can now measure out the 90 degrees angle. So we have 10 degrees here, we have 20, 30, 40, 50, 60, 70, 80, and 90. When you get to the 90 degrees angle, you make a mark there. Then after that, you take the protractor off. Then you join the center of the circle to the mark that you have made using a ruler. After doing that, you draw a line from the center of the circle to a point on the circumference. This angle that you have drawn will be 90 degrees, and this will be the sector for English. We will then move on to the next angle, which is 27 degrees, which will be the sector for Ghana. So you bring the protractor back and you measure 27 degrees. You make sure that the center of the protractor is on the center of the circle. Then the 0 degree line falls on the radius that you have drawn. So the new radius that you drew, you make sure that the 0 degree line falls on that. Then you measure 27 degrees. So on the protractor, we have 20 degrees here. This will be 25 degrees. So the next one will be 26, and the next one will be 27. You make a mark there. After that, you take the protractor off. Then you join the mark that you have made to the center of the circle with a ruler. Then you draw a line from the center of the circle to the circumference. The angle is 27 degrees, and that is the sector for Ghana. We will move on to the next angle, which is 45 degrees, and that will be the sector for Chi. So you bring the protractor back and you measure 45 degrees. Once again, remember that the center of the protractor should be on the center of the circle, and the 0-degree line should fall on the new radius that you have drawn. After making sure of these two things, you measure out the 45 degrees angle. We have 40 degrees here, so this will be 45 degrees. Then you make a mark there. After that, you take the protractor off. You then join the center of the circle to the mark that you have made using a ruler. After that, you draw a line from the center of the circle to the circumference. The angle there will be 45 degrees, and that will be the sector for P. We move on to the next one, which is the sector for eczema, and the angle is 63 degrees. So once again, you bring the protractor. You make sure that the center of the protractor is on the center of the circle, and the 0-degree line falls on the new radius that you have drawn. We will then measure 63 degrees. We have 60 degrees here, so the next one will be 61, the next one will be 62, and the next one is 63. Then you make a mark there. After that, you take the protractor off. Then you join the mark you have made to the center of the circle using a ruler. Then after that, you draw a line to join the center of the circle to the circumference. The angle there will be 63 degrees, and this will be the sector for eczema. We move on to the next language, which is Fanti. The angle is 36 degrees. So you bring the protractor and you measure 36 degrees. You make sure that the center of the protractor is on the center of the circle. Then the 0-degree line also falls on the new radius that you have drawn. We can now measure out our 36 degrees. We have 30 degrees here. This will be 35. So the next one is 36. You make a mark there. Then after that, you take the protractor off. You join the mark that you have made to the center of the circle using a ruler. Then you draw a line from the center of the circle to the circumference. The angle there will be 36 degrees, and that will be the sector for Fanti. Because you have already measured out these angles, there will be no need to measure out the last angle. The value of the angle will be 99 degrees, and that will be the sector for Hausa. We have been able to draw a pie chart for the data that was given to us. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on presenting statistical data on a pie chart. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we solved a question on presenting statistical data on a pie chart. In this video, we are going to solve another question. The question for this video is, in a football season, the number of goals scored by some teams are as follows. So we have 5 different teams here, and the number of goals they scored have been given to us. The question says that we should draw a pie chart to illustrate the data, and then we should find the percentage of the total number of goals scored by Chelsea. We will begin by drawing the pie chart. We have learnt that before we can calculate the angle of sector for each of these teams, we first have to find the total number of goals. So you add the number of goals scored by each team together. 140 plus 120 plus 190 plus 150 plus 200, and that will give us 800. So the total number of goals scored by the teams is 800. We will now have to calculate the angle of sector for each of the teams. We have learnt that the angle of sector for an item is equal to the value assigned to that item divided by the sum of all the values assigned to the items times 360 degrees. So the angle of sector for Chelsea will be equal to the number of goals scored by Chelsea, which is 140, divided by the total number of goals, which is 800, times 360 degrees. And this will give us 63 degrees. The angle of sector for Manchester United will be equal to the number of goals scored by Manchester United, which is 120, divided by the total number of goals, which is 800, times 360 degrees. And this will give us 54 degrees. The angle of sector for Liverpool will be equal to the number of goals scored by Liverpool, which is 190, divided by the total number of goals, which is 800, times 360 degrees, and that will give us 85.5 degrees. The angle of sector for Arsenal will be equal to the number of goals scored by Arsenal, which is 150, divided by the total number of goals, which is 800, times 360, and that will give us 67.5 degrees. And finally, the angle of sector for Manchester City will be equal to the number of goals scored by Manchester City, which is 200, divided by the total number of goals, which is 800, times 360 degrees, and that will give us 90 degrees. When we add these angles together, we are going to get a total of 360 degrees. So we now have the angle of sector for each of the teams here. We can go ahead and draw the pie charts. We will begin by drawing a circle. Then we will draw a radius, that is a line from the center of the circle to a point on the circumference. Now we will measure the angles we have here one after the other using a protractor. So you pick the protractor and you make sure that the center of the protractor falls on the center of the circle, and also the 0 degree line falls on the radius that you have drawn. After making sure of these two things, you can measure out the angle. The angle is 63 degrees. We have 60 degrees here, so the next one will be 61, the one after that will be 62, and the one after that one will be 63. So we have 63 degrees here. You make a mark there. After that, you take the protractor off. Then you join the center of the circle to the mark that you have made using a ruler. Then you draw a line from the center of the circle to the circumference. That will give us our 63 degree angle, and this sector is for Chelsea. The next one is Manchester United. The angle is 54 degrees. So you bring the protractor back, you put the center of the protractor on the center of the circle, and also make sure that the 0 degree line falls on the new radius that you have drawn. We can now measure out the 54 degrees. We have 50 degrees here. So the next one will be 51, we have 52, 53, and then 54. You make a mark there. Then you take the protractor off. You join the center of the circle to the new mark that you have made using a ruler. Then you draw a line from the center of the circle to the circumference. The angle there will be 54 degrees. And this sector is for Manchester United. We move on to the next one, which is Liverpool. You bring the protractor back. Once again, you make sure that the center of the protractor is on the center of the circle, and the 0 degree line falls on the new radius that you have drawn. We can now measure the 85.5 degrees angle. We have 80 degrees here, so this will give us 85 degrees. The next one will be 86 degrees. So 85.5 will be between 85 degrees and 86 degrees. So you make the mark there. Then you take the protractor off. Then after that, you join the center of the circle to the mark that you have made using a ruler. Then you draw a line from the center of the circle to the circumference. The angle there will be 85.5 degrees, and this will be the sector for Liverpool. The next one is Arsenal. The angle of the sector is 67.5 degrees. So you bring the protractor back. You make sure that the center of the protractor is on the center of the circle. And also the 0-degree line falls on the new radius that you have drawn. We can now measure out the 67.5 degrees angle. We have 60 degrees here, and so this is 65 degrees. From 65, we will go to 66. The next one is 67, and the one after that is 68. 67.5 will be between 67 degrees and 68 degrees. So between them, you make a mark there. Then you take the protractor off. You join the new mark that you have made to the center of the circle using a ruler. Then you draw a line from the center of the circle to the circumference. The angle we have measured here is 67.5 degrees, and the sector is for Arsenal. The last one is Manchester City, and the angle is 90 degrees. Because we have measured out the angles we have here already, there will be no need to measure the last one because it will be 90 degrees. So the last one is 90 degrees, and this sector is for Manchester City. So you have been able to draw a pie chart to present the data that was given to us in the question. The second part of the question says that, what percentage of the total goals was scored by Chelsea? So the question wants us to calculate the number of goals Chelsea scored as a percentage of the total. The number of goals Chelsea scored is 140, and the total is 800. So the number of goals Chelsea scored as a percentage of the total will be equal to 140 divided by 800 times 100. And this will give us 17.5%. So it means that Chelsea scored 17.5% of the total number of goals. We can calculate this percentage by using the angle of sector. So we can also use the angle of sector to calculate this percentage. The angle of sector for Chelsea is 63 degrees. The total angle is 360 degrees. So if we want the number of goals Chelsea scored as a percentage of the total, we can get that by dividing the angle of sector for Chelsea, which is 63 degrees, by the total angle, which is 360 degrees, and then we will multiply our answer by 100. 63 divided by 360 times 100 will also give us 17.5%. So we can use both ways to calculate the percentage. Thank you for watching this video. Subscribe to this channel for more videos. So far, we have solved 2 questions on presenting statistical data on a pie chart. In some cases, the pie chart may be drawn for you, and then you'll be asked to use the pie chart to answer some questions. We are going to consider such an example in the next video. So see you in the next video, and let's continue. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we solved a question on presenting statistical data on a pie chart. In this video, we are going to solve another question. The question for this video is, the pie chart below represents the number of valid votes received by 4 students who contested for school prefect. The total number of valid votes pooled was 720. A. How many votes did each candidate obtain? And B. By how many votes did the winner defeat the nearest contestant? So 4 students contested for school prefects in an election. They are Kwame, Mauli, Kwe, and Samuel. And the number of votes they obtained was used to draw a pie chart. So that is the pie chart that has been given to us. We are going to use this pie chart to calculate the number of votes each candidate received. Then we also find the number of votes by which the winner defeated the nearest contestant. The question says that the total number of valid votes pooled was 720. So let's look at the first part, the number of votes each candidate obtained. We will begin by calculating the number of votes Kwame obtained. We don't know that, so let's represent that with a variable. So let's say that K is equal to Kwame's votes, or the number of votes Kwame obtained. From the previous videos, we have learned that when we draw a pie chart, the angle of sector for a particular item is equal to the number assigned to that item divided by the total number times 360 degrees. So in this particular pie chart, the angle of sector for Kwame will be equal to the number of votes Kwame received, which we have represented by K, divided by the total number of votes pooled, which was 720, times 360 degrees. From our pie chart, the angle of sector for Kwame is 120 degrees. So it means that 120 degrees is equal to K divided by 720 times 360. This is a linear equation. So we will solve this linear equation for the value of K. We have a fraction in it, so we will multiply both the left hand side and the right hand side by the LCM of the denominator. The only fraction we have is K divided by 720. So the denominator of the fraction will be our LCM. So you multiply both sides by 720. So you have 720 times 120 degrees. Then we will multiply this side also by 720. You will see that 720 and 720 will cancel each other out. And this will give us 720 times 120 degrees is equal to K times 360 degrees. Then we will divide both sides by 360 degrees. So you will see that 360 and 360 will cancel each other out. And so K will be equal to 720 times 120 degrees divided by 360 degrees. And K will give us 240. Remember that K is Kwame's votes. So what it means is that in the election, Kwame had 240 votes. Let's look at the number of votes Maoli had. We are going to calculate the number of votes Maoli had. So let's represent that with a variable. Let's say M is equal to Maoli's votes. The angle of sector for Maoli will be equal to the number of votes Maoli had, which is M, divided by the total number of votes, which is 720, times 360 degrees. From the pie chart, the angle of sector for Maoli is 100 degrees. So it means that 100 degrees is equal to M divided by 720 times 360 degrees. We will solve this linear equation for M. We will multiply both sides by 720. And when we do that, we will end up having 720 times 100 degrees is equal to M times 360 degrees. We will divide the left hand side by 360 degrees, and we will divide the right hand side also by 360 degrees. And you will see that 360 degrees and 360 degrees will cancel each other out. And when we do this on our calculator, we will have 200. So it means that Maoli's vote was 200. So in the election, Maoli had 200 votes. Let's look at the number of votes Kwe had. Let's represent that with Q. So Q is equal to Kwe's votes. We have learned that the angle of sector for Kwe will be equal to the number of votes Kwe had, which is Q, divided by the total number of votes pooled, which is 720, times 360 degrees. From the pie chart, the angle of sector for Kwe is 80 degrees. So 80 degrees will be equal to the number of votes Kwe had, which is K, divided by the total number of votes, which is 720, times 360 degrees. Once again, we will solve this linear equation for the value of K. We will multiply the left-hand side by 720. We will multiply the right-hand side by 720. And this will give us 720 times 80 degrees is equal to K times 360 degrees. In order to find K, we will divide the left-hand side by 360 degrees, and we will divide the right-hand side by 360 degrees. So we have 360 degrees and 360 degrees cancelling each other out. 720 times 80 degrees divided by 360 degrees will give us 160. Remember that K is Kwe's votes, or the number of votes Kwe had. So it means that in the election, Kwe had 160 votes. We have now calculated the number of votes that 3 out of the 4 candidates had. Kwame had 240 votes, Mauli had 200 votes, and Kwe had 160 votes. The question tells us that the total number of valid votes pooled was 720. We want to find the number of votes that Samuel had. We know the number of votes that 3 out of the 4 candidates had, and we also know the total number of votes. So to get the number of votes that Samuel had, we are going to subtract the number of votes that these candidates had from the total number of votes. So it means that Samuel's votes, or the number of votes that Samuel had, will be equal to the total number of votes, which is 720, minus Kwame's votes, which is 240, minus Mauli's votes, which is 200, minus Kwe's votes, which is 160. And this will give us 120. So it means that in the election, Samuel had 120 votes. So we now have the number of votes that all the candidates had. Kwame had 240 votes, Mauli had 200 votes, Kwe had 160 votes, and Samuel had 120 votes. The second part of the question said that we should calculate the number of votes by which the winner of the election beats the nearest contestant. From the number of votes we have here, we can see that Kwame won the election and the nearest contestant was Mauli, because Kwame had 240 votes, which is more than all the candidates, and the nearest to him was Mauli, who had 200 votes. And we can see that the difference between Kwame's vote and Mauli's votes is 40. So Kwame won the election and the nearest contestant was Mauli, and Kwame obtained 40 votes more than Mauli. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on presenting statistical data on a pie chart. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we solved a question on presenting statistical data on a pie chart. In this video, we are going to solve another question. The question for this video is: the pie chart below represents the amount of money spent on different sports categories by a school's administration in a year. If the money spent on football is 600 Ghana cedis, what is the total amount of money spent on sports? Find the total amount of money spent on hockey and cricket. So in a particular school, the administration spent a certain amount of money on these sports categories, and the data was presented in a pie chart. That is what we have here. The question says that the amount of money spent on football was 600 Ghana cedis. we are going to use this information to calculate the total amount of money spent on sports. So all these sports in total. And then we also calculate the amount of money spent on hockey and cricket. Let's begin with the first part, finding the total amount of money spent on all these different sports categories. The question says that the total amount of money spent on football is 600 Ghana cedis. We want to find the total amount of money spent on all the sports categories. Let's represent that with a variable. So let's say that X is equal to the total amount of money spent on sports for that particular year. From the previous videos, we have learned that in a pie chart, the angle of sector for a particular item is equal to the value assigned to that item divided by the sum of the values assigned to all the items in the data times 360 degrees. So on our pie chart, the angle of sector for football will be equal to the value assigned to football, which is 600 Ghana cedis, divided by the sum of all the money assigned to the different sports categories, which we have represented with X, times 360 degrees. The angle of sector for football is 45 degrees. So it means that 45 degrees is equal to 600 Ghana cedis divided by X times 360 degrees. So we will solve this equation for X, which will give us the total amount of money spent on sports in that particular year. I'll multiply the left hand side by X and multiply the right hand side by X. That will give us X times 45 degrees is equal to 600 Ghana cedis times 360 degrees. To find the value of X, I will divide the left hand side by 45 and divide the right hand side by 45. So X will be equal to 600 Ghana cedis times 360 degrees divided by 45 degrees. And this will give us 4,800 Ghana cedis. So it means that in that particular year, the school's administration spent 4,800 Ghana cedis on sports. The next part of the question says that we should find the total amount of money spent on hockey and cricket. Let's begin by finding the amount of money spent on hockey. We don't know that, so let's represent that with a variable. So let's say that H is equal to the amount of money spent on hockey. As we already know, in a pie chart, the angle of sector for a particular item is equal to the value of that item divided by the sum of all the values for the items in the data times 360 degrees. So it means that the angle of sector for hockey will be equal to the amount of money spent on hockey, which we have represented with H, divided by the total amount of money spent on all the sports disciplines, which is 4,800 Ghana cedis, times 360 degrees. From the pie chart, the angle of sector for hockey is 100 degrees. So it means that 100 degrees is equal to H divided by 4,800 Ghana cedis times 360 degrees. So we will solve this equation for H. I'll multiply the left hand side by 4,800 Ghana cedis and multiply the right hand side also by 4,800 Ghana cedis. This will give us 4,800 Ghana cedis times 100 degrees is equal to H times 360 degrees. To find the value of H, I'll divide both sides by 360 degrees. And so H will be equal to 4,800 Ghana cedis times 100 degrees divided by 360 degrees. And that will give us 1,333 Ghana cedis, 33 pesos. So it means that in that year, the school's administration spent 1,333 Ghana cedis, 33 pesos on hockey. Let's look at the amount of money spent on cricket. We don't know that, so let's represent it with a variable. So let's say that C is equal to the amount of money spent on cricket. We have learned that the angle of sector for cricket will be equal to the amount of money spent on cricket divided by the total amount of money spent on all the different sports, which is 4,800 Ghana cedis times 360 degrees. From the pie chart, the angle of sector for cricket is 160 degrees. So it means that 160 degrees is equal to C divided by 4,800 Ghana cedis times 360 degrees. So we will solve this equation for the value of C. I'll multiply both sides by 4,800 Ghana cedis. So I'll have 4,800 Ghana cedis times 160 degrees is equal to C times 360 degrees. To find the value of C, I'll divide both sides by 360 degrees. And so C will be equal to 4,800 cedis times 160 degrees divided by 360 degrees. And this will give us 2,133 cedis, 33 pesos. So it means that in that particular academic year, the school's administration spent 2,133 Ghana cedis, 33 pesos on cricket. So if you want to find the total amount of money spent on hockey and cricket, we have to add the amount of money spent on cricket to the amount of money spent on hockey. So you have 1,333 Ghana cedis, 33 pesos, plus 2,133 Ghana cedis, 33 pesos. And this will give us 3,466 Ghana cedis, 66 pesos. So it means that in that particular academic year, the school's administration spent 3,466 Ghana cedis, 66 pesos on hockey and cricket combined. Thank you for watching this video. Subscribe to this channel for more videos. So far, we have learned how to use a pie chart to present statistical data. In the next video and the subsequent ones, we are going to learn how to use a bar chart to present statistical data. So see you in the next video and let's continue. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we solved a question on presenting statistical data on a pie chart. In this video, we are going to learn how to present statistical data on a bar chart. Bar chart. On a bar chart, the items in the data are represented with bars. So just as the name suggests, on a bar chart, the items in the data are represented using bars. Let's consider this example. The table below here shows us the number of fruits on display in a particular shop. So in that shop, we have 10 mangoes, 12 bananas, 15 apples, and 8 oranges. We can draw a bar chart to present this data. How do we do that? Let's find out. In an examination, usually when you are asked to draw a bar chart, you will be required to do so on a graph sheet. So we are going to draw this bar chart on a graph sheet. We have the graph sheet here. Since we are going to use a graph sheet, it means that we will have to choose a scale for the graph sheet. I've made 3 separate videos on how to use a graph sheet. I will leave the link to those videos in the description of this video. So if you want to learn how to use a graph sheet, I would advise that you watch those videos. Let's get back to our bar chart. So we are going to draw the information we have here. We are going to draw a bar chart for it on this graph sheet. When you are drawing a bar chart for a given data on a graph sheet, we usually use the horizontal axis for the items and the vertical axis for the frequencies. So on this graph sheet, I'm going to have my horizontal axis here, that is my main horizontal axis here, and my main vertical axis here. Now, as I said, we will have to choose a scale for our graph. So if the question does not give you a scale to be used, you have to choose an appropriate scale. Once again, I have made 3 separate videos where I explained how to use a graph sheet. I will leave the link to those videos in the description of this video so you can go and check it out. So you will have to choose an appropriate scale for our graph. Looking at the frequencies we have here, I'm going to choose a scale of 2 centimeters to 2 units. So after choosing the scale, you use it to number your vertical axis, that is the frequency axis. So we have now numbered the vertical axis. We have to draw the bars for the items. The height of the bar will be determined by the frequency of the item. The first one is mango and the number is 10. So you draw a rectangular bar and the height of the bar will be at 10. The next one is banana and the number or the frequency is 12. So you draw another rectangular bar and the height will be at 12. The next one is apple and the number or the frequency is 15. So you draw another rectangular bar and the height will be at 15. And the last one is orange and the number is 8. So you draw a rectangular bar and the height will be at 8. This is a bar chart and it represents the data that we have in the table. Let's learn some few things about the bar chart. We can see from the bar chart that the width of all the bars are equal. This is what I mean by the width. When you have a rectangular bar like the one we have here, the distance from here to here is known as the width. On our bar chart, we can see that the width of the bar for mango is the same as the width of the bar for banana, is the same as that of the bar for apple, and the same as that of the bar for orange. So when you are drawing a bar chart, you have to make sure that the width of all the bars are equal. And you can do that by making sure that each of the bars occupies the same number of minor divisions or small boxes. So on the graph sheet, we can see the small boxes. Because we want the width of the bars to be the same, we have to make sure that each of the bars occupies the same number of small boxes or minor divisions. On the graph sheet that we have here, each of the bars occupies 10 minor divisions. So each of them occupies 10 small boxes. What other thing can we say about the bar chart we have here? We can see that there are spaces between the bars, and these spaces should be equal. So there's a space between this major vertical grid line and the bar for mango. There's a space between the bar for mango and that of banana. There's a space between the bar for banana and that of apple. And there's a space between the bar for apple and that of orange. The point is saying that the spaces should be equal. So you have to make sure that the spaces between the bars are also equal. And you can do this by making sure that all the spaces also occupies the same number of minor divisions or small boxes. So on my graph sheet here, I made sure that all the spaces occupies 5 minor divisions. So the space between the frequency axis and the bar for mango occupies 5 boxes. The space between the bar for mango and that of banana occupies 5 boxes. The space between the bar for banana and apple occupies 5 boxes. And the space between the bar for apple and orange occupies 5 boxes. So you have to make sure of these two main things. the width of the bars should be the same, and the spaces between the bars should also be the same. Let's quickly go over what we have learned in this video. We have learned that on a bar chart, the items are represented using bars. So as you can see here, when you are drawing a bar chart, the items in the data are represented using bars. The height of the bar will be determined by the frequency of that particular item. We have also seen that usually in an examination, you will be asked to draw the bar chart on a graph sheet, which means that you have to choose a scale for the graph. So if the question does not give you a scale, you have to choose an appropriate scale for the graph. Another thing we have learned is that on a bar chart, the width of the bars are equal and the spaces between the bars are also equal. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply what we have learned in this video to solve a question. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to draw a bar chart for a given data. In this video, we are going to apply what we learned in the previous video to solve a question. Here is our question. The table below shows how a woman spent 24 hours. So we have a number of activities here. There are 5 of them. And the number of hours the woman spent on each activity. She spent 8 hours on sleep. She spent 7 hours on work. 6 was used as her leisure time. She spent 1 hour on meals. And she spent 2 hours traveling. The question says that we should draw a bar chart for this information. So let's do that. We have the information here, the activities, and the number of hours she spent on each activity. From the previous video, we learned that usually in an examination, when you are asked to draw a bar chart, you'll be required to do it on a graph sheet. So we are going to draw this bar chart on a graph sheet. We have the graph sheet here. When drawing a bar chart on a graph sheet, we usually list the items on the horizontal axis and the frequencies on the vertical axis. So here, the activities will be on the horizontal axis and the number of hours will be on the vertical axis, just as we have here. Now, we will have to choose a scale for the number of hours axis or the frequencies. So looking at the values that we have here, I'm going to choose a scale of 2 centimeters to 1 hour. So for every 2 centimeters, we are going to have 1 hour. Now, using this scale, I will number the vertical axis just as I have here. So we have 0, 1, 2, 3, and it continues up to 12. After numbering the axis, we will now have to draw the bars for the various activities. We have 5 activities, so it means that we are going to have 5 bars in total. From the previous video, we learned that the width of the bars should be the same and there should be spaces between the bars, and those spaces should also be the same. So before you begin drawing the bars, you have to determine the width of the bars and the width of the spaces that you are going to leave between the bars. For this particular bar chart, I will make the bars occupy 10 minor divisions, that is 10 small boxes. And the spaces between the bars will be 5 minor divisions or 5 small boxes. Okay, so let's go ahead and draw them. The first one is sleep, and the frequency or the number of hours is 8. Remember, I said that I'm going to leave 5 minor divisions or 5 small boxes between the bars. So before I draw the first one, I'll count 5 minor divisions or 5 small boxes. Then I draw a vertical line from 0 up to 8 because the number of hours or the frequency is 8. I said each bar will occupy 10 minor divisions or 10 small boxes. So after drawing this first vertical line, I'll count 10 minor divisions or 10 small boxes. Then I draw another vertical line from 0 up to 8. And then I'll close it up with a horizontal line. And this will give us the bar for sleep. We will move on to the next bar, which will be the bar for work. Remember that we are leaving 5 minor divisions or 5 small boxes between the bars. So you count 5 minor divisions or 5 small boxes. Then I'll draw a vertical line from 0 up to 7 because the number of hours for work is 7. Then I'll count 10 minor divisions or 10 small boxes. And then I'll draw another vertical line from 0 up to 7. Then I'll close it up with a horizontal line, and this will be the bar for work. We will move on to the next one, which is leisure. I'll leave 5 minor divisions. Then I'll draw a vertical line from 0 up to 6 because the frequency or the number of hours for leisure is 6. Then I'll count 10 minor divisions and then draw another vertical line from 0 up to 6. Then I'll close it up with a horizontal line, and this will be the bar for leisure. We will leave 5 minor divisions, then draw a vertical line from 0 up to 1 because the number of hours or the frequency for meals is 1. Then we will leave 10 minor divisions. You draw another vertical line here, close it up, and this will be the bar for meals. Then the last one is on travel, and the number of hours for the frequency is 2. We will leave 5 minor divisions, and then you draw a vertical line from 0 up to 2. Then we will leave 10 minor divisions. You draw another vertical line from 0 up to 2, and then close it up with a horizontal line, and this will give us the bar for travel. Now, after doing this, you can add a little design to the bars to make it look nice. So you can shade them like I have done here to make it look nice. It is not compulsory for you to do that, but when you do it on the graph sheet, it makes it look nice, just as we have here. So we have drawn the bar chart for the information that was given to us. Our chart should have a title, and we will get the title from the question. The question said the table shows us how a woman spent 24 hours. So I'm going to choose this title, a bar chart showing how a woman spent 24 hours. So we are done with the bar chart for the information that was given to us in the question. We can see from our bar chart that when you are drawing a bar chart on a graph sheet, you first have to determine the spaces that you are going to leave between the bars, and also determine the width of each bar. And you have to do that such that all the bars you have will fit on the graph sheet. So you don't rush when you're drawing the bars. First determine the width of the bars and the spaces that you are going to leave between them, and make sure that they will all fit on the graph sheet. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on drawing a bar chart for a given statistical data. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we solved a question on constructing a bar chart for a given data. In this video, we are going to solve another question. Here is the question. The marks of 20 pupils in an English text as follows. So we have the max here. The question is saying that we should construct a frequency table for the distribution, and then we should draw a bar chart for the distribution. So we are going to do two things here. We will first construct a frequency table for the distribution. Then after that, we will use the data that we get from the table to draw a bar chart for the distribution. I've already explained how to construct a frequency distribution table for a given data in one of the previous videos. So I will leave the link to that video in the description of this video so that you can check it out if you want a step-by-step explanation of how to construct a frequency distribution table for a given data. Because I've already explained it, I'll go through the construction of the frequency table quickly, and then we will concentrate on drawing the bar chart for the distribution. So let's start. We have the data for the 20 students here. The question did not give us any interval to use, so it means that the table we are going to draw will be an ungrouped frequency distribution table. So you have our table of 3 columns. The first one will contain the max, the second one will contain the tally, and the third one will contain the frequency. Under the column for max, we will list the individual max from the smallest to the highest. So we have 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then we will go through the data and we will count the number of each mark that we have. So when we go through the data and we count the number of 2 that we have, we will get 1. It means that the frequency is 1. When we count for 3, we will get 3. It means that the frequency is 3. When we count for 4, we will get 3. It means that the frequency is 3. When we count for 5, we will get 5. It means the frequency is 5. We count for 6, we will get 2. It means that the frequency is 2. We count for 7, we will get 1. It means that the frequency is 1. We will count for 8, we will get 2. It means that the frequency is 2. When we count for 9, we will get 2. It means that the frequency is 2. And then when we count for 10, we will get 1. It means that the frequency is 1. So this is the frequency distribution table for the data that was given to us. As I've already said, I've explained how to construct a frequency distribution table for a given data in one of the previous videos. I will leave the link to that video in the description of this video so you can check it out if you want a step-by-step explanation of how to construct a frequency distribution table like the one we have done here for a given data. So now that we are done with the frequency distribution table, let's use the data we have in the table to draw the bar chart for the distribution. We will need the max and the frequency. So we have the max and we have its corresponding frequency here. Our bar chart will be on a graph sheet. So I have my graph sheet here. As we saw from the previous video, usually on a bar chart, the max are on the horizontal axis and then the frequencies are on the vertical axis, just as we have here. We will have to choose a scale for our frequency axis. Looking at the numbers that we have here, I'm going to choose a scale of 4 centimeters to 1 unit. So I'll use this scale to number the frequency axis. So we have 0, 1, 2, 3, 4, 5. Now that we have numbered the frequency axis, we can go ahead and draw the bars for the max. Before we draw the bars for the max, we will have to determine the spaces that we are going to leave between the bars and the width of the bars. In order to accommodate all the bars that I'll have, if you look through the data, you can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 different marks. So it means that in total, we are going to have 9 bars. So you have 9 bars, which means that we will have 9 spaces between them. So you have to choose the width of the spaces and the width of the bars such that they will all fit on the graph sheet that you have. For this bar chart, I will leave 3 minor divisions between the bars, and then each bar will occupy 7 minor divisions. So it means that I will leave 3 small boxes between the bars, and each bar will occupy 7 small boxes. So for the first bar, I'll leave 3 minor divisions, and then the bar will occupy 7 boxes here. The first bar is for the mark 2, and the frequency is 1, so the height will be at 1. So I have the bar here and the mark is 2. We move on to the next one. Remember that we are leaving 3 minor divisions between the bars. So you leave 3 minor divisions, and then you draw the next bar, which is for the mark 3. The frequency is at 3, so the height will be at 3. Then we will leave 3 minor divisions, and then we will draw the next bar, which is for 4. And the frequency of 4 is 3. So the height of the bar for 4 will be at 3. Let's move on to the next bar, which will be for 5. We will leave 3 minor divisions, and then we will draw the next bar, which is for 5. The frequency is at 5, so the height will be at 5. The next one is 6. The frequency is at 2. We will leave 3 minor divisions, and then we will draw the bar for 6. The height is at 2. The next one is 7. The height is at 1. So you leave 3 minor divisions, and then the height will be at 1. The next one is 8. The height is at 2. So you leave 3 minor divisions. The bar will occupy 7 minor divisions, and the height is at 2. The next one is 9. We will leave 3 minor divisions. The height of the bar is at 2, and the bar itself will occupy 7 minor divisions, just as we have been doing all along. Then the last one is 10. We will leave 3 minor divisions. The height of the bar is at 1 because the frequency of 10 is 1. And the bar itself occupies 7 minor divisions. So this is the bar for 10. So as you can see here, all the bars fit the graph sheets that we have. So you have to choose the width of the bars and the spaces between them such that all the bars that you have will fit the graph sheet. After drawing the bars, you can add a little design for it to look nice, just as I have done on my graph sheet here. Our bar chart should have a title, and we will get the title from the question. From the question, we were told that the data is the marks of 20 students in an English examination. So my title is going to be a bar chart showing the marks of 20 students in an English examination. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on drawing a bar chart for a given data. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we solved a question on drawing a bar chart for a given statistical data. In this video, we are going to solve another question. The question we have is, the frequency table shows the marks of a class of 45 pupils in a science examination. So we have the marks and the frequency. There are 45 pupils in the class, so it means that if we add all the frequencies, we are going to get 45. The question says that we should use the distribution to draw a bar chart. So we are going to use the data we have here to draw a bar chart. Then the second part says that a pupil is chosen at random from the class. What is the probability that the pupil obtained I, 7 marks, II, 2 marks, III, more than 6 marks, and IV, less than 4 marks? So in this video, we are going to combine what we have learned under statistics with what we have learned under probability to solve the question. As a reminder, I have made a whole playlist on probability. In that playlist, I explained the concept of probability and also solved some questions under probability. I will leave the link to the playlist on probability in the description of this video. So if you want to learn more about probability, you can follow the link and do so. Let's get back to our question. So we will begin by drawing the bar chart for the distribution. We have the data here. We have the marks and their corresponding frequencies. We are going to draw our bar chart on the graph sheet we have here. We will have the marks on the horizontal axis and the frequency on the vertical axis. We will have to choose a scale for our graph. Looking at the values we have for the frequencies, I'm going to choose a scale of 2 centimeters to 1 student. So on the frequency axis or on the number of students axis, 2 centimeters will be for 1 student. So we will use that to number our frequency axis, just as we can see here. We will now have to determine the width of the bars and the spaces that we are going to leave between them. In total, we have 10 bars, which is quite a lot. So you have to make sure that you are choosing the width of the bars and the spaces between them such that all the 10 bars will fit on the graph sheets that you have. For this particular bar chart, I'm going to leave 3 minor divisions between the bars, and each bar will also occupy 7 minor divisions. So I'll leave 3 small boxes between the bars, and each bar will occupy 7 small boxes. So for the first one, I'll leave 3 small boxes, and then the bar will occupy 7 small boxes, just as we can see here. That is for mark 1, and the frequency is 7, so the height of the bar will be at 7. So this bar is for mark 1. We move on to the next one, which is 2. We will leave 3 small boxes. The bar will occupy 7 small boxes, and the height will be at 6. So that is what we have here. This is for mark 2. The next one is 3. We will leave 3 small boxes. The bar will occupy 7 small boxes, and the height will be at 4, like we have here. And this is for mark 3. The next one is 4. The frequency of 4 is 8, so the height of the bar will be at 8. The next one is 5. The frequency is also at 8, so the height of the bar will be at 8, and this is for 5. The next one is 6. The frequency will be at 2, so the height of the bar will be at 2, and this is for 6. The next one is 7. The frequency is 4, so the height of the bar will be at 4, and this is for mark 7. The next one is 8, and the frequency is at 3, so the height of the bar will be at 3, and this is for 8. The next one is 9, and the frequency is at 2, so the height of the bar will be at 2. Then the last one is 10, and the frequency is at 1. So you leave 3 small boxes like we have been doing all along, and the bar will also occupy 7 small boxes, and the height will be at 1. And this is for mark 10. Now, after you are done, you can add a little design to it for it to look nice, just as I have done here. So I'll add a little design to all the bars for it to look nice, like what we have here. Our bar chart should have a title, and we will get the title from the question. We were told from the question that the data given to us is the marks of 45 students in a science examination. So my title will be a bar chart showing the marks of 45 pupils in a science examination. So we are done with the first part of the question, that is drawing a bar chart for the distribution. Let's move on to the second part of the question that involves probability. So we have the data here, the marks and its corresponding frequencies. The first part of the question says that if we select a pupil at random from the class, we should find the probability that the pupil obtained a mark of 7. From the videos on probability, we learned that the probability that an event will occur is equal to the number of members in the event divided by the number of members in the sample space. For this particular question, we are selecting the student or the pupil from the class. So it means that our sample space is the class. The number of members in the sample space will be the number of pupils in the class. The question told us that there are 45 pupils in the class. So what it means is that the number of members in the sample space is equal to 45. Now, we have to find the number of members in this particular event. What is the event? The event is that the pupil obtained a mark of 7. So we will go to the table and we will find the number of students who obtained a mark of 7. And as we can clearly see from the table, the number of students who obtained a mark of 7 is 4. So the probability that a pupil obtained a mark of 7 will be equal to the number of pupils who obtained a mark of 7, which is 4, divided by the number of pupils in the class, which is 45. Let's move on to the next part of the question, which says that if we select a pupil from the class at random, we should find the probability that the pupil obtained a mark of 2. The pupil obtained a mark of 2. As we have seen here, the probability that an event will occur is equal to the number of members in that event divided by the number of members in the sample space. The sample space is the class, so the number of members in the sample space will be the number of pupils in the class, which is 45. The event is that the pupil obtained a mark of 2. So we will go to the table and we will find the number of pupils who obtained a mark of 2. So for a mark of 2, the number of pupils or the frequency is 6. So it means that the probability that a pupil obtained a mark of 2 will be equal to the number of pupils who obtained a mark of 2, which is 6, divided by the total number of pupils in the class, which is 45. And when we simplify this, we will get 2 divided by 15. Let's move on to the next part, which says that we should find the probability that a pupil obtained more than 6 marks. The pupil obtained more than 6 marks. I'm going to clean what we have here so that we can be able to identify this easily. We are going to find the probability that the pupil obtained more than 6 marks. Once again, the probability that this event will occur will be equal to the number of members in this event divided by the number of members in the sample space. For the number of members in the sample space, since we are selecting the pupil from the class, the number of members in the sample space will be equal to the number of pupils in the class, which is 45. Now we need to find the number of members in this event. The event is that the pupil obtained more than 6 marks. So what we have to do is that we will come to the table and we will select those who obtained more than 6 marks. If they obtained more than 6 marks, it means that they got 7, 8, 9, or 10. Because it is only those who got 7, 8, 9, or 10 that had more than 6 marks. So we have to find the number of students who obtained 7, 8, 9, or 10. From the table, 4 students obtained 7, 3 students obtained 8, 2 students obtained 9, and 1 student obtained 10. So what this means is that if we select a pupil at random from the class, the probability that that pupil obtained more than 6 marks will be equal to 4 plus 3 plus 2 plus 1 divided by 45. And this will give us 10 divided by 45. When we simplify this, we are going to get 2 divided by 9. Let's move on to the last part of the question, which says that if we select a pupil at random from the class, we should find the probability that the pupil obtained less than 4 marks. I'm going to clean what we have done here so that you can see that very clearly. So I'll clean this and clean this one too. Okay, so we can now continue. We are going to find the probability that the pupil will obtain less than 4 marks. If the pupil obtain less than 4 marks, what it means is that they got either 1, 2, or 3, because from our table it is 1, 2, or 3 that are less than 4. So if the pupil obtained less than 4 marks, it means that they obtained 1, 2, or 3. From the table, 7 pupils obtained 1, 6 pupils obtained 2, and 4 pupils obtained 3. So it means that if we select a pupil at random from the class, the probability that the pupil obtained less than 4 marks will be equal to 7 plus 6 plus 4 divided by the total number of pupils in the class, which is 45. And this is equal to 17 divided by 45. We are now done with the solution to the question. As you can see, this solution involves application of probability. As I said already, I've already made a playlist where I explain the concept of probability and also solved some questions on it. I will leave the link to that playlist in the description of this video. So if you want to learn more about probability, you can follow the link and do so. Thank you for watching this video. Subscribe to this channel for more videos. So far, we have learned how to present statistical data using a pie chart and a bar chart. In the next video, we are going to learn how to use a histogram to present statistical data. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to draw a bar chart for a given data. In this video, we are going to learn how to draw a histogram for a given data. Let's start. A histogram is similar to a bar chart. So we are going to look at some of the similarities that exist between a histogram and a bar chart. 1. On a histogram, a set of rectangular bars are used to represent the items in the data. So just as we have on a bar chart, on a histogram too, the items in the data are represented using a set of rectangular bars. The height of the bars corresponds to the frequencies of the items. We saw this when we were learning about a bar chart. On a bar chart, we saw that the height of the bar will correspond to the frequency of that particular item. On a histogram too, the height of the bars corresponds to the frequencies of the items. So these are some of the similarities that exist between a histogram and a bar chart. But there are some differences as well. And one of them is that on a histogram, there are no gaps between the bars. When we were learning how to draw a bar chart, we saw that from one bar to another bar, we leave some space between them. On a histogram, there are no gaps or there are no spaces between the bars. When we were learning how to draw a bar chart, we saw that on a bar chart, the frequencies are usually shown on the vertical axis and the marks on the horizontal axis. On a histogram, The horizontal axis may have the max, the class midpoint, which is also known as the class mid value, or the class boundaries. So on the histogram, on the horizontal axis, you may have the max, the class midpoint, which is also known as the class mid value, or the class boundaries. What you have on the horizontal axis depends on the type of data that has been given to you. We are going to learn how to draw a histogram for a grouped and an ungrouped data. We will begin with an ungrouped data in this video. So in this video, we will learn how to draw a histogram for an ungrouped data. Let's start. Ungrouped data. Let's use this as an example. Let's say that this table shows us the marks scored by some students in a test. So those who scored 7 are 5, those who scored 8 are 6, those who scored 9 are 7, and those who scored 10 are 4. Now this is an example of an ungrouped data because the individual marks have been given to us. We were not given intervals or groups, so this is an ungrouped data. How do we draw a histogram for a data like this? Just like a bar chart, in an examination, when you are asked to draw a histogram, you will be usually required to do so on a graph sheet. So we are going to draw our histogram on a graph sheet. I have my graph sheet here. When you are given an ungrouped data, like the one we have here, the marks will be on the horizontal axis. So on our graph sheet here, we will have the marks on the horizontal axis and the frequencies on the vertical axis. We will have to choose a scale for the vertical axis. So looking at the values that I have here, I'm going to choose a scale of 2 centimeters to 1 unit. You use that scale to number the vertical axis, just like we can see here. Now, after that, you have to choose the width of the bar. We are going to draw a bar to represent each mark. So we have to choose the width of the bar. Just as we learned under bar chart, you have to choose the width of the bar such that all the bars will fit onto the graph sheet that you have. Here we have 4 different marks, so it means that we are going to have 4 different bars. Looking at the graph sheet that I have and the number of bars I have to draw, I will let one bar occupy 10 minor divisions, that is 10 small boxes. So each bar will occupy 10 small boxes. So I will begin with the first one, which is the bar for mark 7, and the frequency is 5. So I'll have the bar for mark 7 and the frequency is 5. So the height of the bar will be at 5. Now I have left a space here. I will later on explain to you why I have left that space there. So this is the bar for mark 7 and the frequency is 5. One thing that you have to note about a histogram for an ungrouped data is that when you are drawing a histogram for an ungrouped data, the mark for each bar will be at the center of the bar. So for this bar, the mark is 7. I made the bar occupy 10 minor divisions, that is 10 small boxes. The point here says that the mark for the bar will be at the center of the bar. So the center of this bar will be at the 5th division, and the mark, which is 7, will be at that point. So we will count to the 5th division, and the mark, which is 7, will be at that point. Let's move on to the next mark, which is 8. The frequency is 6. Remember that on a histogram, we don't leave spaces between the bars. So the next bar will be drawn attached to the first one. The height will be at 6 since the frequency is at 6. And the mark for it will be at the center of the bar. This one also occupies 10 minor divisions. So the mark for it will be at the center of it. For an ungrouped data, the width of the bars will be the same. So each of them will occupy 10 minor divisions, just as I have chosen. We move on to the next one, which is the bar for mark 9. The frequency is 7. So we will draw that attached to this one, and the height will be at 7. The mark, which is 9, will be at the center of the bar. It occupies 10 minor divisions, so the center will be at the 5th division, and that is where our mark, which is 9, will be. The last one is 10. The frequency is 4, so we will draw the bar attached to the bar for 9, and the height will be at 4 since the frequency is 4. The mark, which is 10, will be at the center of the bar, and so we will have it here, which is the center of the bar, and that is 10. Now let's come to the reason why I left this space here. If we look at the numbering on the horizontal axis carefully, we have 7, 8, 9, and 10. From one mark to the next, it increases by 1 unit. So from 7 to 8, from 8 to 9, from 9 to 10. So ideally, our numbering should have started from 0, which you already have here, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would have been the ideal situation since the numbering increases by 1 unit. But we can clearly see that on the histogram, we started from 7 because the marks that was given to us in the question started from 7. So it is as if we have ignored 1, 2, 3, 4, 5, 6. We have ignored this part of the scale. So we have broken it off. And because we have broken it off, we have to indicate on the graph sheet that we have broken it off. So how do we do that? On the graph sheet, to indicate that you have broken a part of the scale off, what I'll do is that I'll come to the space that I left here, then I'll clean a portion of it. And then I'll bring this sign to indicate that a part of the scale is broken off. So this sign here shows that the numbering should have started from 0, 1, 2, 3, 4, 5, 6 before we get to 7, 8, 9, and 10. But I did not bring them because in the data that was given to us, that part was not included. So we started from 7, 8, 9, and 10. So you bring this sign here to indicate that you have broken a part of the scale off. In most books, when a histogram is being drawn for a given data, you will see this sign between the frequency axis and the first horizontal bar. Anytime you see this sign, it shows that a part of the scale or the numbering on the horizontal axis has been broken off, just like the one we have here. You can add a little design to it for it to look nice, just as we were doing for the bar charts. This is how to draw a histogram for an ungrouped data. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply what we have learned in this video to solve a question. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to draw a histogram for an ungrouped data. In this video, we are going to apply what we learned in the previous video to solve a question. The question for this video is: the table below shows the marks obtained by students in a test. Draw a histogram to represent the data. So we have the different marks here and their corresponding frequencies. We are going to draw a histogram to represent this data. Let's start. We have the graph sheet here, and this is the table containing the data. From the previous video, we learned that when we are drawing a histogram for an ungrouped data, the marks will be on the horizontal axis, just as we have here, and the frequencies on the vertical axis. The marks starts at 15 and ends at 65, and the difference between them is 10. So we have 15, 25, 35, 45, 55, 65. Because the marks start at 15 in the table, we are going to start the numbering from 15. So I have to bring this sign here to indicate that I have broken the part of the scale before 15 off, just as I explained in the previous video. We will have to choose a scale for our vertical axis. Looking at the values we have in the table, I'll choose a scale of 2 centimeters to 2 units. So we will use that scale to number the vertical axis. So we have 0, 2, 4, 6, 8, and it continues up to 24. From the table, we have 6 different marks. So it means that we are going to have 6 different bars. We will have to choose the width of the bars. Remember that from the previous video, we learned that for an ungrouped data, the width of the bars will be equal. So all the bars will have the same width. Looking at the number of bars we have and the graph sheet I have here, I will make each bar occupy 10 minor divisions or 10 small boxes. So each of them will occupy 10 small boxes or 10 minor divisions. Let's start with the first one, which will be for 15. The frequency is at 6. So the first bar will occupy 10 minor divisions and the height will be at 6. From the previous video, we learned that the mark for a bar will be at the center of the bar. Here, the bar occupies 10 minor divisions. So the center will be at the 5th division. So the mark, which is 15, will be at the 5th division. Let's move on to the next bar, which will be for 25. The frequency is at 12. Remember that on a histogram, there are no spaces between the bars. So the bar for 25 will be drawn attached to the bar for 15. The mark, which is 25, will be at the center. The center will be at the 5th division. So 25 will be at the 5th division. We move on to the next one, which is the bar for 35. The frequency is 18. So this will be the bar for 35. The height is at 18. And the mark will be at the center. So 35 will be at the 5th division. The next one is 45. The frequency is 20. So this is the bar for 45. The frequency is 20, so the height of the bar is at 20. And the mark, which is 45, will be at the center of the bar. So that will be at the 5th division. The next one is 55. The height or the frequency is at 15. The frequency is at 15. So we have the bar for 55. The frequency is at 15. 15 is between 14 and 16 on the frequency axis. So the height of the bar will be at 15. And the mark, which is 55, will be at the center of the bar. So it will be on the 5th division since the bar occupies 10 minor divisions. And the last one is 65. The frequency is 9. So this is the bar for 65. The frequency is 9. 9 is between 8 and 10 on the frequency axis. The mark, which is 65, will be at the center. So 65 will be on the 5th division since the bar occupies 10 minor divisions. After this, you can add a little design to it for it to look nice, just as I have done here. You will have to choose a title for a histogram. You will get the title from the question. From the question, we were told that the data represents the marks scored by some students in a test. So my title will be a histogram showing the marks obtained by some students in a test. So we have been able to draw a histogram for the data that was given to us. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to draw a histogram for an ungrouped data. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to draw a histogram for an ungrouped data. In this video, we are going to learn how to draw a histogram for a grouped data. From the previous video, we learned that when drawing a histogram for an ungrouped data, you have the marks on the horizontal axis and the frequencies on the vertical axis. If the data is grouped, you are going to have the class midpoint or the mid values or the class boundaries on the horizontal axis, and on the vertical axis you will have either the frequencies or the frequency densities. To get the frequency density, you will need the class size or the class width. In this video, I'm going to explain to you how you get the class midpoint or the class mid value, the class boundaries, and the class size or the class width. We need to understand these things before we can draw a histogram for a grouped data. Let's begin with the class midpoint or the class mid value. As I've said, the class midpoint is also known as the class mid value. I'm going to use this example here to explain it to you. So let's say that these are the marks scored by some students in a test. We have the different intervals here. The first one is 5 to 9, the second one is 10 to 14, the third one is 15 to 19, and the fourth one is 20 to 24. And these are the frequencies. When we take an interval, the smaller number is called the lower class limit, and the bigger number is called the upper class limit. So for example, for the interval 5 to 9, 5 is the lower class limit and 9 is the upper class limit. How do we find the class midpoint for each of these intervals? I'm going to bring a column here so that we can have our class midpoint or the class mid values here. You get the class midpoint or the class mid value for a particular interval by adding the lower and upper class limit for that interval and dividing the results by 2. So to get the class midpoint or the class mid value for a particular interval, we will add our class limit to the upper class limit, and then we will divide the results by 2. So to get the class midpoint or the class mid value for 5 to 9, we will add 5 to 9 and then we will divide the results by 2. 5 plus 9 will give us 14. 14 divided by 2 is 7. So the class midpoint or the class mid value for this particular interval is 7. In the same way, 10 plus 14 will give us 24. 24 divided by 2 will give us 12. 15 plus 19 will give us 34. 34 divided by 2 will give us 17. And 20 plus 24 will give us 44. 44 divided by 2 is 22. So this is how to find the class midpoint or the class mid values. You add the lower class limit to the upper class limit, and then you divide the results by 2. Let's learn how to find the class boundaries. I'm going to use the same example. I'll have another column here for the class boundaries. To get the class boundaries, the first thing you need to do is to select 2 consecutive class intervals. So from this table, we can select 5 to 9 and 10 to 14, or you can select 10 to 14 and 15 to 19, or you can select 15 to 19 and 20 to 24. The most important thing is that the 2 intervals should be consecutive. That is, one should follow the other. For this particular example, I'm going to select 5 to 9 and 10 to 14. So the intervals I'm using are 5 to 9 and 10 to 14. After selecting the 2 consecutive intervals, what do? The next thing is that subtract the upper class limit of the first one from the lower class limit of the second one and divide the results by 2. The first one here is 5 to 9 and the second one is 10 to 14. The point says that we should subtract the upper class limit of the first one. The upper class limit of 5 to 9 is 9. It says we should subtract the upper class limit of the first one from the lower class limit of the second one. The lower class limit of 10 to 14 is 10. So the point is saying that we should subtract 9 from 10. That is 10 minus 9. 10 minus 9 will give us 1. Then what should we do next? It says that we should divide the results by 2. So you will divide the result, which is 1 by 2. When you divide 1 by 2, we are going to have 0.5. After doing this, what do you do next? Subtract the result of step 2 from the lower class limits and add it to the upper class limits. So after doing this, it says that we should subtract the result from step 2. The result from step 2 is 0.5. We should subtract the 0.5 from the lower class limits and add it to the upper class limits. So to get the class boundary for each class, we will subtract the result from step 2, which is 0.5, from the lower class limit and add it to the upper class limit. So if we take the first interval, which is 5 to 9, we will subtract 0.5 from 5 and then we will add 0.5 to 9. 5 minus 0.5 will give us 4.5. 5 plus 9 will give us 9.5. So for the first interval, the class boundary will be 4.5 to 9.5. We will do the same thing for the second one. We will subtract 0.5 from 10 and add 0.5 to 14. 10 minus 0.5 will give us 9.5. 14 plus 0.5 will give us 14.5. For the third one too, we will do the same thing. We will subtract 0.5 from 15 and add 0.5 to 19. 15 minus 0.5 will give us 14.5 and 19 plus 0.5 will give us 19.5. And for the last one, we will subtract 0.5 from 20 and add 0.5 to 24. 20 minus 0.5 will give us 19.5 and 24 plus 0.5 will give us 24.5. So this is how to find the class boundaries. You first select 2 consecutive class intervals. Then you subtract the upper class limit of the first one from the lower class limit of the second one and divide the results by 2. Then after that, you subtract the result from step 2 from the lower class limits and add it to the upper class limits. When you get the class boundary for a particular class, the smaller number is called the lower class boundary and the bigger number is called the upper class boundary. So for example, for the class boundary 4.5 to 9.5, 4.5 is known as the lower class boundary and 9.5 is known as the upper class boundary. Let's learn how to find the class size or the class width. We are using the same example. To get the class size or the class width, subtract the lower class boundary from the upper class boundary. So it means that in order to get the class size or the class width, we will need the class boundaries. We have learned how to find them. So I'll bring it here. So these are the class boundaries for the intervals. The point says that to get the class size or the class width for a particular interval, we have to subtract the lower class boundary from the upper class boundary. As I've already explained, when you have a class boundary, the smaller number is the lower class boundary and the bigger number is the upper class boundary. So for example, if we take the class boundary 14.5 to 19.5, 14.5 is the lower class boundary and 19.5 is the upper class boundary. To get the class size or the class width, we will subtract the lower class boundary from the upper class boundary. I'm going to push this here so that we can add another column for the class size. So to get the class size for each particular interval, I'll subtract the lower class boundary from the upper class boundary. So for the first one, it's going to be 9.5 minus 4.5, which is 5. For the second one, it's going to be 14.5 minus 9.5, which is 5. For the third one, it's going to be 19.5 minus 14.5, which is 5. And for the last one, it's going to be 24.5 minus 19.5, which is 5. So as you can see here, the class size of all the intervals are the same. When you are drawing a histogram for a grouped data, and the class size or the class width of all the different intervals is the same, on the vertical axis, you are going to have the frequencies. That is the frequencies you have in the table. But if the class size or the class width is not the same for all the intervals, you are going to have the frequency densities. So if the class size is the same for all the intervals, you have the frequencies on the vertical axis. If the class size is not the same for all the intervals, you have the frequency densities. As we go on in this lesson, I will explain how to find the frequency densities to you. As you can clearly see here, the class size or the class width is very important. It determines whether you have the frequencies or the frequency densities on the vertical axis. So when you have a data that is grouped and you are going to draw a histogram, you first have to check whether the class size or the class width of all the different intervals are the same. A quick way to do that is by subtracting the lower class limit from the upper class limit. If the difference between the lower class limit and the upper class limit of all the different classes are the same, then it means that they will have the same class size. So as you can see here, when we subtract 5 from 9, we will get 4. When you subtract 10 from 14, you will get 4. When you subtract 15 from 19, you will get 4. And when you subtract 20 from 24, you get 4. The difference between the lower class limit and the upper class limit of all the different classes are the same. So it means that the class sizes will be the same. Remember that the class size is the difference between the lower class boundary and the upper class boundary. It is not the difference between the lower class limit and the upper class limit. But a quick way to check whether the class size or the class width will be the same is by subtracting the lower class limits from the upper class limits. If it's the same for all the different intervals, then it means that the class sizes will also be the same. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply what we have learned in this video to draw a histogram for a grouped data. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to find the class width, class midpoint or the mid value, and the class boundaries for a given data. In this video, we are going to apply what we studied in the previous video to draw a histogram for a grouped data. Let's consider the question we have here. The question says we should draw a histogram to represent the data below. In the table, we have the ages of workers in years and the number of workers or the frequencies. The ages have been given to us in intervals, so this is clearly a grouped data. We are going to draw a histogram to represent this data. From the previous video, we learned that when you are asked to draw a histogram for a group data, you may have the class midpoint or the mid value or the class boundaries on the horizontal axis, and on the vertical axis you may have the frequencies or the frequency densities depending on the class size or the class width of the different classes that you have. So whether you have the frequencies or the frequency densities on the vertical axis depends on the class size or the class width of the different classes that you have. If the class size is the same for all the classes, then you have the frequencies. But if the class sizes are different, then you have the frequency densities. So you first have to determine whether the class size is the same for all the classes. And just as we learned in the previous video, a quick way of doing that is by finding the difference between the upper class limit and the lower class limit for the different classes. The first one is 10 to 14, so the difference will be 14 minus 10, which is 4. The second one, 19 minus 15, that is 4. The third one, 24 minus 20, that will give us 4. The fourth one, 29 minus 25, that will give us 4. The fifth one, 34 minus 30, that will give us 4. And the last one, 39 minus 35, that will give us 4. So we can see that the difference between the upper class limit and the lower class limit for all the classes is the same. What it means is that the class sizes or the class widths will also be the same. And so if the class sizes or the class width are the same, then on the vertical axis, we are going to have the frequencies, which is given to us in the table as the number of workers. So we are going to have the number of workers or the frequencies on the vertical axis. Now let's come to the horizontal axis. On the horizontal axis, just as we learned in the previous video, you may either have the class midpoint or the mid values or the class boundaries. That one you have to choose. For this particular question, I'm going to solve it with both. So in this video, I'll solve the question, that is, I'll draw the histogram with the class midpoint or the mid value. And then in the next video, I'll solve this same question, but I'll use the class boundaries on the horizontal axis. So for this particular video, I'm going to use the class midpoint or the mid value on the horizontal axis. We have the class midpoint or the mid value on the horizontal axis. And then on the vertical axis, we have the frequencies, which is the number of workers. We will need a column for the class midpoint or the mid value in the table. So I'll add another column to it. Now we have to find the class midpoint for each of the intervals given to us. From the previous video, we learned that the class midpoint for a particular interval, you can find it by adding the lower class limit of that interval to the upper class limit of that same interval, and then you divide the results by 2. So for the first one, it will be 10 plus 14, which will give us 24, and then you divide the result by 2, which will give us 12. For the second one, is going to be 15 plus 19, which is 34. 34 divided by 2 give us 17. For the next one is 20 plus 24, which is 44. 44 divided by 2 give us 22. The next one is 25 plus 29, which is 54. 54 divided by 2 give us 27. We have 30 plus 34, which will give us 64. 64 divided by 2 give us 32. And then the last one, we will have 35 plus 39, which is 74. 74 divided by 2 give us 37. So we now have the class midpoints for the different intervals. We are going to have the class midpoints on the horizontal axis, and then the frequencies, which is the number of workers, on the vertical axis. Now let's draw the histogram on the graph sheet. We have the graph sheet here, and in our table we have the class midpoints and then the number of workers or the frequencies. On the horizontal axis, I'm going to have the class midpoints, which are the ages of the workers. And then on the vertical axis, we will have the frequencies, which is the number of workers. The class midpoint starts from 12. On my horizontal axis, I'll begin the numbering from 12. So I'll bring this sign here to show that the part of the scale before 12 has been broken off. We will have to choose a scale for the vertical axis. So you will look at the values here and you will choose a scale such that our graph will cover as much space as possible. Looking at the values here, I'm going to choose a scale of 2 centimeters to 1 unit on the vertical axis. But we know the unit here. The unit is the number of workers. So our scale will be 2 centimeters to 1 worker. And the name of the axis is the number of workers. So the axis will be the number of workers axis. So our scale will be 2 centimeters to 1 worker on the number of workers axis. Using this scale, we can number the vertical axis, just as I've done here. The next thing we have to do is to choose the width of the bars. Remember that you have to choose the width such that all the bars that you have will fit on the graph sheet. Here we have 6 different bars. I'll let each bar occupy 10 minor divisions. So we'll begin with the first one. The first one, the frequency is at 6. So I'll begin the first bar from this major grid line and then it will end on this major grid line. That means that it will cover 10 minor divisions. The height is at 6. That's the frequency is at 6. The class midpoint is 12. When you are using the class midpoints, the midpoint will be at the middle of the bar. Each bar is occupying 10 minor divisions. So the middle will be on the 5th division. So here 12 will be on the 5th division. We will move on to the next bar, which will be the bar for 17. The height or the frequency is at 8. Remember that for a histogram, we don't leave spaces between the bars. So it will be drawn attached to the first one. The height will be at 8. The class midpoint is 17. It will be at the middle of the bar, which will be the 5th division. The next one is 22. The frequency is at 11. The class midpoint, which is 22, will be at the center of the bar, so it will be on the 5th division. The next one is 27. The frequency is at 10, so the height will be at 10. The midpoint is 27, to be at the middle of the bar, which is the 5th division. The next one is 32. The frequency is at 5, so the height of the bar will be at 5. And then 32 will be at the middle, which is the 5th division. And then the last one is 37. The frequency is at 3. So the height of the bar will be at 3, and 37 will be on the 5th division. After that, you can add a little design to it for it to look nice. We will have to choose a title for our histogram, and we will get the title from the question. The question said that the table shows the age distribution of workers in the company. So my title will be a histogram showing the age distribution of workers in a company. We have been able to draw a histogram for the data that was given to us in the table using the class midpoints on the horizontal axis. As I said, in the next video, we are going to solve the same question. So we are going to draw the histogram again, but this time we will use the class boundaries on the horizontal axis. So see you in the next video, and let's do that. Bye-bye. Welcome back. In the previous video, we drew a histogram for the data we have here by using the class midpoint or the class mid value on the horizontal axis. In this video, we are going to draw the histogram again, but this time we will use the class boundaries on the horizontal axis. We are going to use the class boundaries, and so I'll bring a new column that will contain the class boundaries. We will now have to find the class boundaries for the different classes that we have. We have learned that to find the class boundaries, the first thing you have to do is to select two consecutive class intervals. That is, two class intervals that follow each other. So in this particular example, I'm going to select the second one and the third one. So 15 to 19 and 20 to 24. Now, after selecting two consecutive class intervals, the next thing you have to do is to subtract the upper class limit of the first one from the lower class limit of the second one. The first one is 15 to 19. The upper class limit is 19. The second one is 20 to 24. The lower class limit is 20. So what it means is that I'll subtract 19 from 20. 20 minus 19 will give us 1. Now, after subtracting the upper class limit of the first one from the lower class limit of the second one, you divide the result by 2. When you subtracted 19 from 20, we had 1. So you will divide 1 by 2. 1 divided by 2 gives us 0.5. Now, the next thing you have to do to get the class boundaries is that you subtract that value. So here we will subtract 0.5 from the lower class limits, and then we will add 0.5 to the upper class limits. So all the lower class limits, we will subtract 0.5 from it, and then all the upper class limits, we will add 0.5 to it. So let's begin with the first one. 10 minus 0.5 will give us 9.5. 14 plus 0.5 will give us 14.5. So the first one will be 9.5 to 14.5. The next one will be 14.5 to 19.5. The next one will be 19.5 to 24.5. And then the next one is 24.5 to 29.5. The next one is 29.5 to 34.5. And the last one will be 34.5 to 39.5. So we now have the class boundaries for all the classes. So we can now draw the histogram. We will have the frequencies on the vertical axis because we know that the class width or the class size of all the classes are the same. We will have the frequencies on the vertical axis and then the class boundaries on the horizontal axis. Let's go on to the graph sheet and draw the histogram. We have the graph sheet here, and in our table we have the class boundaries and the frequencies or the number of workers. On the vertical axis, we are going to have the number of workers. Looking at the values that I have here, I'm going to choose a scale of 2 centimeters to 1 worker on the number of workers axis, just as we did in the previous video. So using this scale, we will number the vertical axis just as we have here. And then on the horizontal axis, we are going to have the class boundaries, which is the age of the workers. The class boundaries starts from 9.5. The smallest one is 9.5, and it ends at 39.5. I'm going to start the numbering from 9.5 and continue with the order that we have here. So I'll bring this sign here to show that the part of the scale before 9.5 has been broken off. Okay. Now we will have to determine the width of each bar. Like I did in the previous video, I'll make each bar occupy 10 minor divisions. So when I begin from this major grid line, when the bar starts from this major grid line, it will end on this major grid line, which is the next one. It starts from 9.5, so it means that the first one will be 9.5. and then the next one will be 14.5. The one after that begins from 14.5 and ends at 19.5. The next one begins from 19.5 and ends at 24.5. The next one begins from 24.5 and ends at 29.5. The next one begins from 29.5 and ends at 34.5. And the last one begins at 34.5 and ends at 39.5. So we have the horizontal axis numbered nicely. Now we can easily draw the bars. The frequency for the first one is 6, so it means that the height of the bar will be at 6. It starts from 9.5 and ends at 14.5, as we can see here. The frequency is at 6. The next one starts from 14.5 and ends at 19.5. The frequency is at 8. So we have that here. The next one starts from 19.5 and ends at 24.5. And the frequency is at 11. So we have that here. The next one starts from 24.5 and ends at 29.5, and the frequency is at 10. We have that here. The one after that starts from 29.5 and ends at 34.5, and the frequency is at 5. And the last one starts from 34.5 and ends at 39.5, and the frequency is at 3, just as we have here. Now after that, you can add a little design to it, just as we have been doing all along, so that it will look nice. We have the histogram for the data that was given to us, and this time we used the class boundaries on the horizontal axis. We will have to choose a title for our histogram. The data shows the ages of workers in the company. So my title will be a histogram showing the age distribution of workers in the company, just as we did in the previous video. Comparing the histogram we have here to the one we drew in the previous video, you can clearly see that the main difference is in how we number the horizontal axis. So when you are using the class boundaries and the class midpoint, the main difference is in the numbering of the horizontal axis. Apart from that, every other thing is the same. When you are given a grouped data and you are asked to draw a histogram for the data, you have to choose which one to use, whether you are going to use the class midpoint or the class boundaries on the horizontal axis. And any one of them that you decide to use, you are going to end up having the same histogram. The only difference will be the numbering on the horizontal axis. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on drawing a histogram for a grouped data. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we drew a histogram for a grouped data. In this video, we are going to draw another histogram for a grouped data. Let's consider the question that we have. It says that the following is a record of marks obtained by 50 students in a chemistry test. We have the raw data here. That is the marks scored by the 50 students. The question says that we should draw a frequency distribution table for the data using the intervals 0 to 9, 10 to 19, 20 to 29, etc. And draw a histogram for the distribution. So the question is in two parts. For the first part, we are going to use these intervals to draw a frequency distribution table for the data. And then for the second part, we will use the frequency distribution table to draw a histogram. In the previous videos, that is the introductory videos, I explained how to draw a frequency distribution table. That is a grouped frequency distribution table for a data like this. So I'll assume that by now you know how to draw a grouped frequency distribution table for a data like the one that we have here. And so I'll go straight to the part of the table that we will need to draw the histogram. I'll leave the link to those videos in the description of this video. So if you want to learn how to draw a frequency distribution table for a grouped data, you can watch those videos. So let's move ahead. Now your frequency distribution table should look like this. We have the class interval, we have the tally, the frequencies. For this particular histogram, I'm going to use the class midpoints on the horizontal axis. So I'll bring a new column for the class midpoints. The question gave us the intervals that we are supposed to use. That's 0 to 9, 10 to 19, 20 to 29, etc. So if you continue, you have 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. When you find the differences between the upper class limit and the lower class limits, you realize that all of them will give you 9. You have 9, 9, 9, 9 for all of them. And if the differences is the same for all of them, it means that the class width or the class sizes will also be the same. And because the class width or the class sizes are all the same, then it means that we will have the frequencies on the vertical axis. So for the histogram, we will have the frequencies on the vertical axis. On the horizontal axis, I'm going to use the class midpoints. So you have to find the class midpoints for each of the classes that we have here. We have learned that you get the class midpoint by adding the lower class limit to the upper class limit and then dividing the results by 2. So for the first one, we will have 0 plus 9 and then we will divide the result by 2. 0 plus 9 divided by 2 will give us 4.5. The next one will be 10 to 19. So you have 10 plus 19 divided by 2. That will give us 14.5. 20 plus 29 divided by 2 give us 24.5. 30 plus 39 divided by 2 give us 34.5. 40 plus 49 divided by 2 will give us 44.5. 50 plus 59, then we will divide the result by 2 and that will give us 54.5. 60 plus 69, we will divide the result by 2, that will give us 64.5. 70 plus 79 divided by 2 will give us 74.5. 80 plus 89 divided by 2 will give us 84.5. And finally, 90 plus 99 divided by 2 will give us 94.5. So we have the class midpoints for all the classes. Remember that on the histogram, we are going to draw the frequencies on the vertical axis and then the class midpoints on the horizontal axis. Let's do that on the graph sheet. We have the graph sheet here. On the vertical axis, we will have the frequencies, and then on the horizontal axis, we will have the class midpoints, which is the max. The marks are in percentage, so you have to indicate the unit, which is percentage. We will look at the values we have for the vertical axis and then choose an appropriate scale. Looking at the values here, I'm choosing a scale of 2 centimeters to 1 student. So we will have 2 centimeters to 1 student on the frequency axis. So you use that scale to number the axis, just as you can see here. The class midpoints begin from 4.5. And so I'll bring this sign here to show that the part of the scale before 4.5 has been broken off. The next thing we have to do is to choose the width of the bars. Remember that you have to choose the width such that all the bars you have will fit on the graph sheet. I will let each bar occupy 10 minor divisions. Let's begin with the first one, which is 4.5, and it has a frequency of 4. So we have that here. The frequency or the height will be at 4. Since we are using the class midpoints, the mark will be at the center of the bar. Remember that each bar is occupying 10 minor divisions. So the center will be on the 5th division. So at the 5th division, we will have 4.5. The next one is 14.5. The frequency is also at 4. So we have 14.5. The frequency is at 4. And 14.5 will be on the 5th division. The next one is 24.5. The frequency is at 6. So we have 24.5. The frequency is at 6, and 24.5 will be at the middle, which is the 5th division. The next one is 34.5, and it's also having a frequency of 6. So 34.5, the frequency will be at 6, so the height of the bar is at 6, and 34.5 will be at the middle. The next one is 44.5. The frequency is 8, so the height of the bar will be at 8, and 44.5 will be at the middle. The next one is 54.5. The frequency is at 5, so the bar will be at 5, and the 54.5 will be at the middle. The next one is 64.5. The frequency is 6, so the height will be at 6, and 64.5 will be at the middle. The next one is 74.5. The frequency is at 4, so the height is at 4, and then 74.5 will be at the middle. The next one is 84.5. The frequency is 4, so the height is at 4, and 84.5 is at the middle. And then the last one is 94.5. The frequency is 3, and so the height will be at 3, and 94.5 will be at the middle. After that, we can add a little design to it, just as we have been doing all along. We will have to choose a title for our histogram. We will get the title from the question. The question said that the data shows the marks scored by 50 students in a chemistry test. So my title will be a histogram showing the mark distribution of 50 students in a chemistry test. So we have been able to draw a histogram for the data that was given to us. So far, all the data that we have considered have the same class size or class width. Sometimes you may be given a data where the class sizes or the class width are not the same. In that case, you have to draw the frequency densities on the vertical axis. We will consider such an example in the next video. So in the next video, we will draw a histogram for a grouped data where the class sizes or the class widths are not the same. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we drew a histogram for a grouped data. In this video, we are going to draw another histogram for a grouped data. Let's consider the question for this video. The question says that the table below shows the marks of some students in a biology test. Draw a histogram for the distribution. So in the table, we have the marks that are in groups and their frequencies. We have learned that for a histogram, when we are drawing the histogram for a grouped data, on the horizontal axis, you may have the class midpoint or the class mid value or the class boundaries, and on the vertical axis you may have the frequency or the frequency density. We learned that when you are asked to draw a histogram for a group data, the first thing you have to do is to check whether the class size or the class width is the same for all the intervals that you have. If the class size or the class width is the same for all the intervals, then you are going to have the frequencies on the vertical axis. But if they are not the same, then you have the frequency densities on the vertical axis. A quick way to check whether the class size or the class width will be the same for all the intervals is by finding the difference between the upper class limit and the lower class limit for the classes. If the differences are the same, then it means that the class width or the class size will also be the same. So let's do that here. For the first one, we have 1 to 5. So to get the difference, we will subtract 1 from 5. 5 minus 1 will give us 4. For the second one, 10 minus 6 will give us 4. For the third one, 20 minus 11 will give us 9. For the next one, 30 minus 21 will give us 9. Then 35 minus 31 will give us 4. And 40 minus 36 will also give us 4. So as you can see from here, unlike the previous one where the differences were the same, here some of them are giving us 4, others are giving us 9. And because the differences are not the same, it means that the class width or the class size will also not be the same. So for this particular histogram, we are going to have the frequency densities on the vertical axis, not the frequencies. We are going to use the frequency densities because the class width or the class size is not the same for all the intervals that we have. On the horizontal axis, you may have the class midpoint, which is also known as the class mid value or the class boundaries. For this particular histogram, I'm going to use the class boundaries. So for this histogram, I'll have the class boundaries on the horizontal axis and the frequency densities on the vertical axis. Now we need to find the class boundaries and the frequency densities. We know how to find the class boundaries, so let's begin with that one. I'll add a new column for the class boundaries. We have learned that to find the class boundaries, you first have to select two consecutive intervals. I will select the first one and the second one. So we have 1 to 5 and 6 to 10. After selecting the two intervals, you subtract the upper class limit of the first one from the lower class limit of the second one. So I'll subtract 5 from 6. 6 minus 5 will give us 1. Then after that, you divide the results, which is 1 by 2. 1 divided by 2 gives us 0.5. After getting the 0.5, you subtract the 0.5 from the lower class limits, and then you add the 0.5 to the upper class limits. This will give us the class boundaries. So for the first one, we have 1 minus 0.5 to 5 plus 0.5. 1 minus 0.5 will give us 0.5, and 5 plus 0.5 will give us 5.5. So the first one is 0.5 to 5.5. For the second one, we will have 6 minus 0.5, which is 5.5, then 10 plus 0.5, which is 10.5. The next one will be 10.5 to 20.5, because 11 minus 0.5 will give us 10.5, and 20 plus 0.5 will give us 20.5. The next one will be 20.5 to 30.5. The next one will be 30.5 to 35.5. And the last one will be 35.5 to 40.5. We now have the class boundaries. The next thing we will have to find is the frequency density. Frequency density is given by the formula. Frequency density is equal to frequency divided by class width. So the frequency density for a particular interval is given by the frequency of that interval divided by the class width of that interval. So it means that to get the frequency densities, we first have to get the class width of all the intervals. So I'll bring another column in the table for the class width. We have learned that the class width for a particular interval is equal to the upper class boundary minus the lower class boundary. Remember, it is not the upper class limit minus the lower class limit. Rather, it is the upper class boundary minus the lower class boundary. So for the first one, the class width will be equal to 5.5 minus 0.5, and that gives us 5. For the second one, it will be 10.5 minus 5.5, and that gives us 5. For the third one, it will be 20.5 minus 10.5, that gives us 10. The next one is 30.5 minus 20.5, that gives us 10. The next one is 35.5 minus 30.5, and that gives us 5. And the last one is 40.5 minus 35.5, and that gives us 5. So we have found the class width for all the intervals. We can now find the frequency densities because we have the frequencies and then we have the class width. I'll add another column for the frequency densities. As we have seen here, the frequency density for a particular interval is equal to the frequency of that interval divided by the class width. So for the first one, the frequency density is equal to the frequency, which is 2, divided by the class width, which is 5. 2 divided by 5 will give us 0.4. For the next one, we will have 3 divided by 5, and that will give us 0.6. The next one is the frequency, which is 11, divided by the class width, which is 10, and that will give us 11 divided by 10, which is 1.1. The next one is 8 divided by 10, and that gives us 0.8. The next one is 5 divided by 5, and that gives us 1. And the last one is 1 divided by 5, and that gives us 0.2. So we now have the frequency densities for all the intervals. Remember, we are plotting the frequency densities on the vertical axis and the class boundaries on the horizontal axis. Let's do that on the graph sheet. We have the graph sheet here, and this is the table containing the class boundaries and the frequency densities. We are plotting the frequency densities on the vertical axis and the class boundaries on the horizontal axis. We will have to choose a scale for the frequency density axis. Looking at the values here, I'm going to choose a scale of 2 centimeters to 0.1 unit. So you will use this scale to number the frequency density axis, just as we can see here. Let's consider the horizontal axis. We are going to plot the class boundaries on the horizontal axis. It starts from 0.5. So I'll bring this sign here to show that the part of the scale before 0.5 has been broken off. I'll start the numbering from this major grid line. So this major grid line will be 0.5. The next one will be on this major grid line, and the next one is 5.5. So 0.5 to 5.5. The difference between 0.5 and 5.5 is 5. So I'll add 5 to 5.5. 5 plus 5.5 will give us 10.5. So the next one is 10.5. 10.5 plus 5 will give us 15.5. 15.5 plus 5 will give us 20.5. 20.5 plus 5 will give us 25.5. 25.5 plus 5 will give us 30.5. 30.5 plus 5 will give us 35.5. And 35 plus 5 will give us 40.5. The last one is 40.5. So our numbering starts from 0.5 and then it ends at 40.5. We can now draw the bars. The first bar starts from 0.5 and it ends at 5.5. The frequency density is 0.4. So it starts from 0.5, ends at 5.5, and the frequency density is 0.4, so the height will be at 0.4. The next one starts from 5.5 and ends at 10.5, and the frequency density is 0.6. We start from 5.5, it ends at 10.5, and the frequency density is at 0.6. The next one starts from 10.5 and ends at 20.5. So it starts from 10.5 and it ends at 20.5. Now you can see that because the class width or the class size for this particular interval is 10, the width of the bar is twice the previous ones that we have drawn. For the previous ones, the class width or the class size was 5. For this particular interval, the class width or the class size is 10. So the one having a class width of 10, the width of the bar will be twice the one having the class width of 5, just as we can see here. The frequency density for this particular interval is 1.1, so the height of the bar will be at 1.1. The next one is also having a class width or a class size of 10. It starts from 20.5 and ends at 30.5, and the height is at 0.8 because the frequency density is 0.8. The next one starts from 30.5 and ends at 35.5. The frequency density is 1, so the height of the bar will be at 1 or 1.0, just as we can see here. And the last one starts from 35.5 and ends at 40.5, and the frequency density is 0.2, so the height of the bar will be at 0.2. Now after this, we can add a little design to it for it to look nice, just as we have been doing all along. We have to choose a title for our histogram. We will get the title from the question. In the question, we were told that the data shows the marks scored by some students in a biology test. So my title is going to be a histogram showing the marks scored by some students in a biology test. So this is how to draw a histogram for a grouped data where the class width or the class size of the intervals are not the same. If the class width or the class size for the intervals are not the same, you plot the frequency densities on the vertical axis, and then on the horizontal axis, you may have the class boundaries or the class midpoints. To find the frequency density for a particular class, you divide the frequency by the class width or the class size. Thank you for watching this video. Subscribe to this channel for more videos. So far, we have learned how to present statistical data on a pie chart, a bar chart, and a histogram. In the next video and the subsequent ones, we are going to learn how to draw a cumulative frequency table and then use the table to draw a cumulative frequency curve. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to draw a histogram for a given data. In this video, we are going to learn how to draw a cumulative frequency table and curve for a given data. Let's begin with the cumulative frequency table. Cumulative frequency tables. A simple cumulative frequency table contains 4 columns. Here is an example. In the first column, you have the max. In the second column, you have the frequency. The third column will have the max less than, and the fourth column will have the cumulative frequency. This is how a simple cumulative frequency table looks like. Let's assume that these are the marks scored by some students in a test, and these are their corresponding frequencies. So we can see that the marks are grouped. The first one is 0 to 9, 10 to 19, 20 to 29, and it continues up to 90 to 99. And each mark has its corresponding frequency. In a simple cumulative frequency table, we will have the max, the frequencies, the max less than, and the cumulative frequency. As we can see here, the max and frequencies will usually be given to us. So we will have to fill the max less than and cumulative frequency column ourselves. Let's start with the max less than. How do we find that? The max less than are the upper class boundaries of the class intervals. The max less than are the upper class boundaries of the class intervals. We have different class intervals here. We have 0 to 9, 10 to 19, 20 to 29, and it continues to 90 to 99. The point says that the max less than are the upper class boundaries of these class intervals. From the previous videos, we have learned how to find upper class boundaries. I hope that you understand that by now. I'll go through it quickly in this video. To get the upper class boundary of a particular interval, you first have to select two consecutive intervals. I'm going to select 10 to 19 and 20 to 29. After selecting two consecutive intervals, you subtract the upper class limit of the first interval from the lower class limit of the second interval. Here I selected 10 to 19 and 20 to 29. The upper class limit of the first interval is 19 and the lower class limit of the second interval is 20. So I'll subtract 19 from 20. 20 minus 19 is equal to 1. After that, we will divide the result, which is 1, by 2. When we divide 1 by 2, we are going to get 0.5. To get the upper class boundaries, we will have to add this 0.5 to the upper class limits. The first interval is 0 to 9. The upper class limit is 9. So to get the upper class boundary of this interval, I will add 0.5 to 9. 9 plus 0.5 will give us 9.5. So it means that the upper class boundary of 0 to 9 is 9.5. The point tells us that the max less than are the upper class boundaries of the class intervals. So here we will find the upper class boundaries of these intervals, and that will give us the max less than. The first one is 9.5. The second one will be 19 plus 0.5, which will be 19.5. The next one will be 29 plus 0.5, which is 29.5. So it will continue on and on. So the next one will be 39.5, 49.5, 59.5, 69.5, 79.5, 89.5, and 99.5. We are done with the max less than column. Let's move on to the cumulative frequency column. The cumulative frequency of a class is the accumulation of the frequencies up to that class. So to get the cumulative frequency for a particular class, we will add all the frequencies up to that particular class. The first frequency is 0, so it means that the cumulative frequency will be 0 because there is no frequency before that. The next frequency is 5. As we have learned here, the cumulative frequency is the accumulation of the frequencies up to that class. So it means that the cumulative frequency for this particular class will be 0 plus 5, and 0 plus 5 will give us 5. The next frequency is 8. The cumulative frequency for this class will be the accumulation of the frequencies up to this class. So it will be 0 plus 5 plus 8, and that will give us 13. The next frequency is 14. So the cumulative frequency of this particular class, which is 30 to 39, will be the accumulation of the frequencies up to this class. So that will be 0 plus 5 plus 8, which we already have as 13. So it will be 13 plus 14, and that will give us 27. So the next one will be accumulation of the frequencies up to this class. So that will be 0 plus 5 plus 8 plus 14, which we already have as 27, then plus 24. So 27 plus 24 will give us 51. So the next one will be 51 plus 30, which will be 81. The next one will be 81 plus 8, which will be 89. The next one will be 89 plus 5, which is 94. The next one will be 94 plus 4, which is 98. And the last one will be 98 plus 2, which is 100. So we have now completed the column for the max less than and cumulative frequency. This is how a simple cumulative frequency table looks like. Now, let's learn how to draw a cumulative frequency curve. Cumulative frequency curve. On the cumulative frequency curve, the max less than are plotted on the horizontal axis, which we usually call the x-axis, and the cumulative frequencies are plotted on the vertical axis, which we usually call the y-axis. This is the cumulative frequency table we completed in the previous video. We are going to use the information in this table to draw the cumulative frequency curve for this particular distribution. We have learned that to draw the cumulative frequency curve, the max less than will be on the horizontal axis and the cumulative frequencies will be on the vertical axis. So we have the graph sheet here. The max less than are on the horizontal axis and the cumulative frequencies are on the vertical axis. The scale I'm using is 2 centimeters to 10% on the max less than axis and 2 centimeters to 10 students on the cumulative frequency axis. We have the points here, so we are going to plot them. The first point is 9.50. So when we plot it, we are going to have that here. The next one is 19.55. We have that here. The next one is 29.513. That will be here. The next one is 39.527. That will be here. The next one is 49.551. That will be here. The next one is 59.581. That will be here. The next one is 69.589. That will be here. The next one is 79.594. We have that here. The next one is 89.598. That will be here. And the last one is 99.500. And that is here. After plotting the points, you join them with your free hand to get the cumulative frequency curve. In some questions, they will tell you to draw the cumulative frequency polygon. If it's a cumulative frequency polygon, then in that case, you have to join them with a straight line. So you use your ruler to join them. But if the question asks you to draw the cumulative frequency curve, you join them with your free hand to get the curve, just as we have done here. We will have to choose a title for our graph. The marks given to us were marks scored by some students in an examination. So my title will be Cumulative Frequency Curve showing marks scored by some students in an examination. So this is how to draw a cumulative frequency curve for a given distribution. We started by drawing the cumulative frequency table. We have learned how to find the max less than and the cumulative frequencies. And after getting the max less than and cumulative frequencies, you plot the max less than on the horizontal axis and the cumulative frequencies on the vertical axis. After that, you join the points with your free hand to get the cumulative frequency curve, just as we have done here. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve a question on drawing a cumulative frequency curve for a given distribution. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to draw a cumulative frequency table and curve for a given distribution. In this video, we are going to apply what we studied in the previous video to solve a question. The question for this video is: the table below shows the percentage marks scored by some students in an examination. So in the table, we have the marks which are given to us in intervals and their corresponding frequencies. The first part of the question says that construct a cumulative frequency distribution table and use it to draw a cumulative frequency curve for the data above. The second part says that from your graph, estimate I, the lowest mark for distinction if 5% of the candidates obtained a distinction, and II, the number of candidates who passed if the pass mark was 30%. Let's begin with the first part of the question, constructing the cumulative frequency distribution table and using it to draw the cumulative frequency curve. As we learned from the previous video, a simple cumulative frequency distribution table will have 4 columns: max, frequency, max less than, and cumulative frequency. So we have the max here, we have the frequencies. The max less than are the upper class boundaries of each class. We have learned how to do that. The upper class boundary of 0 to 9 will be 9.5, that of 10 to 19 will be 19.5, that of 20 to 29 will be 29.5, and it continues for the remaining classes. So we have 39.5, 49.5, 59.5, 69.5, 79.5, 89.5, and 99.5. Let's move on to the cumulative frequencies. As we learned in the previous video, to get the cumulative frequency for a particular class, you add all the frequencies up to that class. The first frequency is 7, so it means that the first cumulative frequency will also be 7. For the next class, the frequency is 11, so the cumulative frequency will be 7 plus 11, which will give us 18. The next frequency is 17, so the cumulative frequency will be 7 plus 11, which is 18, plus 17, which is 35. The next frequency is 20, so the cumulative frequency will be 7 plus 11 plus 17, which will give us 35. Then 35 plus 20, and that will give us 55. So to get the next cumulative frequency, we will add the frequency here, which is 29, to the previous cumulative frequency, which is 55. So 29 plus 55 will give us 84. The next one will be 34 plus 84, which will give us 118. The next one is 30 plus 118, which is 148. The next one is 25 plus 148, which is 173. The next one is 21 plus 173, which is 194. And the last one is 6 plus 194, which is 200. So we now have the max less than and the cumulative frequencies. We can plot them on the graph sheet and join the points to get our cumulative frequency curve. Let's do that. We have the graph sheet here. Remember that our max less than will be on the horizontal axis and the cumulative frequencies will be on the vertical axis. Always make sure that you choose a scale such that the graph will cover a large space on the graph sheet. Let's plot the points. The first point is 9.57. When we plot that, we will have it here. The next one is 19.518. We have that here. The next one is 29.535. We have that here. The next one is 39.555. We have that here. The next one is 49.584. We have that here. The next one is 59.5118. We have that here. The next one is 69.5148. We have that here. The next one is 79.5173. We have that here. The next one is 89.5194. We have that here. And the last one is 99.5200. We have that here. The question said we should draw a cumulative frequency curve. So we will join the points with our free hand to get the curve, just as you can see here. We will have to choose a title for our graph. The marks given to us are marks scored by students in an examination. So my title will be a cumulative frequency curve showing the marks scored by some students in an examination. We are going to use the curve to answer the remaining part of the question. The first question we have is, find the lowest mark for distinction if 5% of the candidates obtained a distinction. 5% of the candidates obtained a distinction. We should use the curve to find the lowest mark for distinction. In terms of percentage, the total number of students in the class will be 100%. So if 5% obtained a distinction, what it means is that 95% did not obtain a distinction. Remember that the total number of students in the class is 200, because when we did the cumulative frequency, the last cumulative frequency is 200. It means that when we add all the students in the class, we are going to have 200. So if 95% of the students did not obtain distinction, we can find the number of students who did not obtain distinction, because we know that 95% of them, and the total number is 200. So we will have 95% of 200. From percentages, we know that this is equal to 95 divided by 100 times 200, and this will give us 190. So it means that 190 students did not obtain distinction. To get the lowest mark for distinction, what we will do is that we will locate 190 on the cumulative frequency axis. We have that here, 190. Then we will trace it to the curve. After that, we will trace it from the point where it meets the curve to the horizontal axis, and then read the mark there. When I do that on my graph sheet, I am having 86.5. We have the marks less than on the horizontal axis. So if 190 students did not obtain a distinction, and 190 students corresponds to 86.5%, what it means is that all the students who scored less than 86.5%, which is the 190 students, did not obtain a distinction. It means that the lowest mark for distinction is 86.5%. So if a student scores 86.5% or more, then the student is said to have scored a distinction. All those who scored marks less than 86.5% did not obtain a distinction. So we can say that from the graph, 190 corresponds to 86.5%. Therefore, if 5% of the students obtain distinction, then the lowest mark for distinction is 86.5%. Let's move on to the last part of the question. It says that we should find the number of students who passed if the pass mark was 30%. The pass mark was 30%, so we should find the number of students who passed. To do that, we will first locate 30% on the horizontal axis. So we look for 30% on the horizontal axis, and then we will trace it to meet the curve. Then from the point where it meets the curve, we will trace it to the vertical axis, which is the cumulative frequency axis, and read the value there. When I read the value there, I'm having 36. So from the graph sheet, 30% corresponds to 36 students. What this means is that the students who scored marks less than 30%, those who scored marks less than the pass mark, which is 30%, is 36. And in an examination, if you score marks less than the pass mark, it means you failed. So it means that if the pass mark is 30%, then 36 students failed. But we are not looking for the number of students who failed. We want the number of students who passed. We know that the total number of students in this class is 200. So if the total number of students is 200 and 36 of them failed, then it means that those who passed will be 200 minus 36, which is 164 students. So it means that if the pass mark is 30%, then 164 students passed. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on drawing a frequency distribution table and curve for a given distribution. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we solved a question on drawing a cumulative frequency table and curve for a given data. In this video, we are going to solve another question. The question for this video is: the following is a record of marks obtained by a group of 50 students in a chemistry test that was scored over 100. So we have the raw data from the test here. The test was taken by 50 students, so it means that the total number of students in the class is 50. The first part of the question says, draw a frequency distribution table for the data using the intervals 0 to 9, 10 to 19, 20 to 29, etc. Then the second part says that draw a cumulative frequency curve for the distribution. The third part says, from your curve, I determine the pass mark if 4/5 of the students passed. I find the probability that a student selected at random had distinction if the minimum mark for distinction is 75%. So from the data given to us, we can see that we have the raw data. So in this case, our cumulative frequency distribution table will have a column for tally. I've already explained how to do the tally for a raw data like this in the previous videos, so I will not go through the process again in this video. I'm sure that by this time you can do the tally. Let's move on to the table. We have been given the intervals 0 to 9, 10 to 19, 20 to 29, etc. So I have the table here. We have the class intervals 0 to 9, 10 to 19, 20 to 29, 30 to 39, and it continues up to 90 to 99. And these are the tallies and these are the frequencies. As I said, I've already explained how to do the tally for a raw data like this in the previous videos, so I'm sure that by this time you can do them. These are the frequencies we obtained. To draw the cumulative frequency curve, we will need the max less than and the cumulative frequencies. We know that the max less than are the upper class boundaries of the class intervals. The upper class boundaries are 9.5, 19.5, 29.5, 39.5, and it continues up to 99.5, just as we learned from the previous video. Let's work on the cumulative frequencies. The cumulative frequency for a particular interval will be the sum of the frequencies up to that interval. The first frequency is 4, so the first cumulative frequency will be 4. The next one will be 4 plus 4, which is 8. The next one will be 4 plus 4 plus 6, so we have 8 plus 6, which is 14. The next one will be 4 plus 4 plus 6, which is 14, plus 6. which is 20. So the next one will be 8 plus 20, which is 28. The next one is 28 plus 5, which is 33. The next one is 33 plus 6, which is 39. The next one is 39 plus 4, which is 43. The next one is 43 plus 4, which is 47. And the last one is 47 plus 3, which is 50. So we are now done with the second part of the question, which is drawing the cumulative frequency table. Let's move on to the cumulative frequency curve. We have the graph sheet here. As usual, we have the max less than on the horizontal axis and the cumulative frequencies on the vertical axis. As I said in the previous video, you choose a scale such that the graph or your curve will cover a large portion of the graph sheet. Let's plot the points. The first one is 9.54. We have that here. The next one is 19.58. That will be here. The next one is 29.514. We have that here. The next one is 39.520. We have that here. The next one is 49.528. That is here. The next one is 59.533. That's here. The next one is 69.539. That will be here. The next one is 79.543. That's here. The next one is 89.547. That's here. And the last one is 99.550. That's here. The question said we should draw a cumulative frequency curve. So it means that we will join the points with our free hand to get the cumulative frequency curve. The title I'm using is a cumulative frequency curve showing the marks obtained by 50 students in a chemistry test. We are done with the third part of the question, that is drawing the cumulative frequency curve for the distribution. Let's look at the last part. The first question of the last part says that we should determine the pass mark if 4/5 of the class passed. 4/5 of the class passed. 4/5 is 4 out of 5. So 4 out of 5 of the class passed. We know that the total number of students in the class is 50. So if 4 out of 5 of them passed, then it means that the total number of students who passed will be 4 out of 5 times 50, which will give us 40. So it means 40 students passed. In the class, we have 50 students. So if 40 of them passed, then it means that 10 students scored below the pass mark. So those 10 students, they failed. So we need to find the pass mark if 10 students failed. To get that, we will locate 10 on the horizontal axis. That's the cumulative frequency axis. So we have 10 here. Then we trace it to the curve, and from the point where it meets the curve, we will trace it to the horizontal axis, that is the max less than axis, and then we will read the value there. From my graph, when I read the value there, I'm having 21.5%. So 10 on the cumulative frequency axis corresponds to 21.5% on the max less than axis. This means that those who scored max less than 21.5% failed. If those who scored max less than 21.5% failed, then it means that 21.5% is the pass mark. So if 4/5 of the students passed, then it means that the pass mark was 21.5%. Let's look at the second part. The second part says that we should find the probability that a student selected at random had distinction if the minimum mark for distinction is 75%. To get this probability, we have to find the number of students who had distinction. Then we will divide it by the total number of students in the class, which is 50. So let's begin by finding the number of students who had distinction. Remember, the question says that the minimum mark for distinction or the least mark for distinction is 75%. So we will locate 75% on the max less than axis. That's the horizontal axis. You locate 75%, then you trace it to the curve, and from the point where it meets the curve, you trace it to the cumulative frequency axis and read the value there. When I do that, I'm having 42. So 42 students. 75% is the minimum mark for distinction. And we know that those who scored less than 75% did not have distinction. So what it means is that 42 students did not have distinction. So in the class, 42 students did not have distinction. The total number of students in the class is 50. So if 42 students did not have distinction, then it means that those who had distinction will be 50 minus 42, which is 8. So in the class, 8 students had distinction, and the total number of students in the class is 50. So the probability that a student had distinction will be equal to the number of students who had distinction, which is 8, divided by the total number of students in the class, which is 50. 8 divided by 50 is 4 divided by 25. So if the minimum mark for distinction is 75%, then the probability that a student had distinction is 4 divided by 25. Thank you for watching this video. Subscribe to this channel for more videos. Up to this point, we have learned how to present statistical data on a pie chart, a bar chart, histogram, and cumulative frequency curve. In the next video and the subsequent ones, we are going to learn how to find the measures of central tendencies for a given data. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we drew a cumulative frequency curve for a distribution. In this video, we are going to learn about measures of central tendency. Measures of central tendency. When analyzing data obtained from a survey, we desire to have a term that best describes the whole data. So usually, after collecting data from a survey, we would like to have a term, that is one term, that best describes the whole data. In most cases, you realize that all the data points in the survey is clustered around or centered around a particular term, and that term best describes the whole data. For example, let's consider the table we have here that shows the ages of students in a particular class and their corresponding frequencies. In order to analyze this data, we would like to have an age that best describes the age of a student in this class. The ages of all the students in the class will be centered around or clustered around that particular age. A term around which there is a concentration of terms of the data is called a measure of central tendency. So the term around which all the other terms in the data is clustered around or concentrated around is called a measure of central tendency. So if we consider the distribution we have here, the age around which all the other ages is concentrated, or the age around which all the other ages is clustered around, is known as the measure of central tendency. The measures of central tendency are also known as the averages of the frequency distribution. So the measures of central tendencies are also known as the averages. In our lesson, we are going to consider 3 of these averages. They are the mean, the mode, and the median. These are the three averages that we will consider. Remember, we said these averages are also known as measures of central tendency, and it is a term around which there is a concentration of all the terms in the data. We will begin with the mean in the next video. In the next video, we are going to learn how to find the mean of a set of numbers. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to find the mean of a set of numbers. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned about the measures of central tendency. In this video, we are going to learn how to find the mean of a set of numbers. Mean of a set of numbers. If x1, x2, x3 up to xn are a set of numbers, then the mean of the numbers is given by x with a bar on top. So this is how we represent the mean. X with a bar on top. And to get it, we will have to add the numbers in the set and divide it by the number of terms in the set. So the mean is equal to x1 plus x2 plus x3 plus xn divided by n. And as I've said, it means that we will have to add the numbers and divide it by the number of terms. So the mean of a set of numbers is equal to the sum of all the numbers divided by the number of terms in the set. Let's take some examples. Let's consider this one. Find the mean of 4, 0, 3, 2, 1, 3, 2, 4, 4, 5. Let's count the number of members in this set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number of members, that is our n, is equal to 10. To get the mean, we will add all the numbers and then we will divide it by 10, which is the number of terms in this set. So you have 4 plus 0 plus 3 plus 2 plus 1 plus 3 plus 2 plus 4 plus 4 plus 5 divided by 10. And this will give us 28 divided by 10, which is 2.8. So the mean of this set of numbers is 2.8. Let's consider another example. Find the mean of 2, 14, 13, 11, 11, 10, 11. Once again, let's count the number of terms here. We have 1, 2, 3, 4, 5, 6, 7. So the number of terms, or n, is equal to 7. To get the mean, we will add all the numbers and we will divide it by the number of terms, which is 7. So that will be 2 plus 14 plus 13 plus 11 plus 11 plus 10 plus 11 divided by 7. And this will give us 72 divided by 7, which is 10.3. So it means that the mean of this set of numbers is 10.3. Let's consider the last example. The mean of the numbers 5, 1, 6, 0, 4, 8, x, and 2 is 4. Find x. So here, the mean has been given to us, but we do not know the value of one of the numbers. The question wants us to use this information to find the value of x, that is the missing number. We know that the mean of a set of numbers is equal to the sum of all the numbers divided by the number of terms. We have 1, 2, 3, 4, 5, 6, 7, 8 terms. So the number of terms is 8. So the n value is 8. To get the mean, we will add all the numbers. That will be 5 plus 1 plus 6 plus 0 plus 4 plus 8 plus x plus 2. And then we will divide it by the number of terms, which is 8. But the question says that the mean of this set of numbers is 4. So it means that the mean is equal to 4. So we can replace the mean here with 4. When we do that, we will have 4 is equal to 5 plus 1 plus 6 plus 0 plus 4 plus 8 plus 2 will give us 26. So we have 4 is equal to 26 plus x divided by 8. We have a linear equation here. So we solve this linear equation for the value of x. To do that, we will multiply the left hand side by 8 and we multiply the right hand side by 8. So 8 and 8 will be gone. 8 times 4 will give us 32. And so we will have 32 is equal to 26 plus x. X will be equal to 32 minus 26. And 32 minus 26 is 6. So it means that the value of x in this set is 6. Thank you for watching this video. Subscribe to this channel for more videos. We have learned how to find the mean of a set of numbers in this video. In the next video, we are going to learn how to find the mean from an ungrouped frequency distribution table. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to find the mean of a set of numbers. In this video, we are going to learn how to find the mean from an ungrouped frequency distribution table. Mean from an ungrouped frequency distribution table. From an ungrouped frequency distribution table, the mean, which is represented by x with a bar on top of it, is equal to sigma fx divided by sigma f. Sigma means sum of, so it means that the mean is equal to sum of fx divided by sum of f. The f values are the frequencies and the x values are the max. So to get the mean, we will find the sum of the product of f and x and then divided by the sum of f. Let's apply this to a question. Let's consider this question. The table below shows the score of 15 students in a biology test. So we have the scores and the number of students who scored each one of them. Find the mean score. To do this, we will draw a table with 3 columns. The first column will be for the scores, and that will be the x values. And the second column will be for the frequencies, that will be the f values. We have learned that the mean is equal to the sum of fx divided by the sum of f. Before we can get the sum of fx, we first have to find fx. Fx will be the product of f and x, and that will be in this column. So the third column will be for fx. To get the first one, we will multiply the first f value by the first x value. The first f value is 2 and the first x value is 2. So 2 times 2 will give us 4. We do the same thing here. 4 times 3 will give us 12. Then the next one will be 5 times 4, which is 20. The next one is 3 times 5, which is 15. And the last one is 1 times 6, which is 6. So we now have the fx values. we want sigma fx, that is the sum of fx. To get that, we will add all the fx values. So we have 4 plus 12 plus 20 plus 15 plus 6, and that will give us 57. So sigma fx is 57. We need sigma f, that is the sum of the f values. So we will add all the f values. 2 plus 4 plus 5 plus 3 plus 1, and that will give us 15. So it means that the mean score will be equal to sigma fx, which is 57, divided by sigma f, which is 15, and this will give us 3.8. So it means that the mean score is 3.8. Let's consider another example. The frequency table below shows the ages of pupils in a class. So we have the ages here and their corresponding frequencies. Calculate the mean age. Correct your answer to the nearest whole number. As we did in the previous example, we will draw a table with 3 columns. The first column will be for the age, and that will be the x values. The second column will be for the frequencies. That will give us the f values. And the last column will be the fx values. The mean is sigma fx divided by sigma f. So we first have to find the fx values. That is the product of f and x. So the first one will be 10 times 14, which is 140. The next one will be 35 times 15, which is 525. The next one is 7 times 16, which is 112. The next one is 5 times 17, which is 85. And the last one is 3 times 18, which is 54. To get sigma fx, it means we have to add all the fx values. So we have 140 plus 525 plus 112 plus 85 plus 54. And that will give us 916. We need sigma f, so we add all the f values. That will be 10 plus 35 plus 7 plus 5 plus 3, and that is 60. So the mean will be equal to 916 divided by 60, and this will give us 15.3. But remember, the question said we should correct our answer to the nearest whole number. When we correct 15.3 to the nearest whole number, we are going to have 15. So it means that the mean age is 15 years. Let's consider another question. If the mean of the data below is 3.8, find the value of m. So we have x values and f values. And among the f values, we have a variable m. The question is telling us that the mean of this data is 3.8. We should use this information to find the value of m. As usual, we will draw our table with 3 columns, as you can see here, with the x values in the first one, the f values in the second one, and the fx values will be in the third one. The mean is given by sigma fx divided by sigma f. So let's first find the fx values. 1 times 1 will give us 1. 4 times 2 will give us 8. 3 times 7 will give us 21. M times 4 will give us 4m. 6 times 5 will give us 30. And 3 times 6 will give us 18. As we have been doing all along, after finding the fx values, we have to add all of them to get sigma fx. So you have 1 plus 8 plus 21 plus 4m plus 30 plus 18. From algebra, we know that this will give us 4m plus 78, because 1 plus 8 plus 21 plus 30 plus 18 will give us 78. So sigma fx will be equal to 4m plus 78. We need sigma f, so we add all the f values. 1 plus 4 plus 7 plus m plus 6 plus 3. And this will give us m plus 21, because 1 plus 4 plus 7 plus 6 plus 3 will give us 21. So sigma f is equal to m plus 21. So this means that the mean is equal to sigma fx, which is 4m plus 78, divided by sigma f, which is m plus 21. The question told us that the mean is 3.8. So 3.8 is equal to 4m plus 78 divided by m plus 21. This is a linear equation, so we solve this linear equation for the value of m. To do that, we will multiply the right hand side by m plus 21, and then we will multiply the left hand side also by m plus 21. You see that m plus 21 and m plus 21 will cancel each other out, and so we will be left with 3.8 times m plus 21. But because m plus 21 is a binomial, we will put that in the bracket. So we have 3.8 into bracket m plus 21 is equal to 4m plus 78. We open the bracket here. 3.8 times m will give us 3.8m. 3.8 times 21 will give us 79.8. And this will be equal to 4m plus 78. We group like terms. We will have 3.8m minus 4m is equal to 78 minus 79.8. 3.8m minus 4m is equal to negative 0.2m. 78 minus 79.8 is negative 1.8. So we have negative 0.2m is equal to negative 1.8. To find m, we will divide both sides by negative 0.2. So we will divide the left hand side by negative 0.2, and we divide the right hand side also by negative 0.2. So negative 0.2 and negative 0.2 will cancel. And so m will be equal to negative 1.8 divided by negative 0.2, which is 9. So the value of m in this distribution is 9. Thank you for watching this video. Subscribe to this channel for more videos. In this video, we learned how to find the mean from an ungrouped frequency distribution table. In the next video, we are going to learn how to find the mean from a grouped frequency distribution table. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to find the mean from an ungrouped frequency distribution table. In this video, we are going to learn how to find the mean from a grouped frequency distribution table. Mean from a grouped frequency distribution table. From a grouped frequency distribution table, the mean is equal to sigma fx divided by sigma f. The f values are the frequencies, and the x values are the class midpoints or the class mid values. In the videos on drawing frequency distribution table, we learned how to find the class midpoints and the class mid values. So I'm sure that by now you know how to find them, because we are going to use that in this video. Let's apply this to solve a question. Let's consider this question. The table below shows the weekly wage of a number of workers in a company. So we have the weekly wages in one column and then the number of workers in another column. As we can clearly see, this is a grouped data. So we have 0 to 10, 11 to 20, 21 to 30, 31 to 40, and 41 to 50. The question says that we should find the mean wage and we should correct our answer to 2 decimal places. To do this, we will draw a table with 4 columns. The first one will be for the weekly wage, and the second one will be for the frequencies, and that will be the F values. To get the mean, the formula is sigma fx divided by sigma f. We have the F values here, so we will need the X values. The X values will be the class midpoints. With the X values, we can now find the Fx values, because the Fx values will be the product of the F values and the X values. So now let's find the X values, that are the class midpoints or the class mid values. We have learned that to get the class midpoints or the class mid values, we will add the lower class limit to the upper class limit, and then we will divide the result by 2. So the first one will be 0 plus 10 divided by 2. That will give us 5. The next one is 11 plus 20 divided by 2. That is 15.5. The next one is 21 plus 30 divided by 2. That is 25.5. The next one is 31 plus 40 divided by 2. And that will give us 35.5. And the last one is 41 plus 50 divided by 2. That will give us 45.5. We now have the X values, so we can find the Fx values. We will get that by multiplying the F values by the X values. So you have 4 times 5, which will give us 20. 8 times 15.5, which will give us 124. 12 times 25.5, which will give us 306. 6 times 35.5, which will give us 213. And 1 times 45.5, which is 45.5. We can now find sigma fx. We will have to add the fx values. When we add all of them, we are going to get 708.5. We need sigma f, so we add all the f values, and that will give us 31. So the mean will be equal to 708.5 divided by 31. And this will give us 22.85. Remember, the question said we should correct our answer to 2 decimal places. And so we can say that the mean weekly wage is 22.85 Ghana cedis. Let's consider another question. The following is a record of marks obtained by a group of 50 students in the chemistry test that was scored over 100. So we have the raw data here. The first part of the question says, draw a frequency distribution table for the data using the interval 0 to 9, 10 to 19, etc. and use the table to find the mean mark. So we have the raw data here, which means that we are going to have a tally in our frequency distribution table. I've already explained how to do the tally for a data like this in the previous videos, so I'm very sure that by now you know how to do it. So I will assume that you know how to do the tally and go ahead with the remaining part of the solution. So we have our table here. These will be the class intervals 0 to 9, 10 to 19, 20 to 29. It continues up to 90 to 99. The next column in the table will be for the tally. The next column will be for the frequencies, which will give us the F values. The next one will be for the class midpoint or the class mid values, which will give us the X values. And then the last column will be for the Fx values, because we need sigma Fx to find the mean. When you do the tally for the data, this is what you are going to have. and these will be the frequencies. As I said, I've already explained how to do this in the previous videos, so I'm very sure that by now you know how to do that. So let's go ahead and find the x values, that's the class midpoint or the class mid values. To get that, we will add the lower class limit to the upper class limit and divide the result by 2. So the first one will be 0 plus 9 divided by 2, and that is 4.5. The next one is 10 plus 19 divided by 2, that's 14.5. The next one will be 20 plus 29 divided by 2, that will be 24.5. The next one is 34.5. The next is 44.5. The next is 54.5. The next one is 64.5. The next one is 74.5. The next one is 84.5. And the last one is 94.5. So to get the class midpoint or the class mid values, you add the lower class limit to the upper class limit and divide the results by 2. We now have both the f values and the x values, so we can find the fx values. To do that, we will multiply the f values by the x values. So for the first one, we have 4 times 4.5, and that will give us 18. The next one will be 4 times 14.5, that is 58. The one after that is 6 times 24.5, and that is 147. The next one is 6 times 34.5, that is 207. We have 8 times 44.5, that is 356. 5 times 54.5 is 272.5. 6 times 64.5 is 387. 4 times 74.5 is 298. 4 times 84.5 is 338. And the last one, we have 3 times 94.5, and that is 283.5. We need sigma fx, so it means that we have to add all the fx values. When you add them, you are going to have 2365. And we also need sigma f, so we have to add all the f values. When you do that, you are going to have 50. We now have sigma fx and sigma f, so we can find the mean. The mean will be equal to sigma fx, which is 2365, divided by sigma f, which is 50. 2365 divided by 50 is equal to 47.3. So what it means is that the mean mark is 47.3%. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to find the mean of a distribution by using the assumed mean method. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to find the mean from a grouped frequency distribution table. In this video, we are going to learn how to find the mean of a distribution by using the assumed mean method. Finding the mean using the assumed mean method. We can assume a mean for a given data and then calculate the actual mean from it. This method is usually used for a grouped frequency distribution. So in the assume mean method, we will assume a mean. It is usually given to you in the question. The assumed mean will usually be given to you in the question. And then you use the assumed mean to calculate the actual mean. If a mean A is assumed for a data, then the actual mean is equal to the assumed mean, which is A, plus sigma fd divided by sigma f. D is the deviation, and you obtain it by subtracting the assumed mean from the x values. The x values will be the class midpoints or the class mid values. And as we have seen, A is the assumed mean. The f values will be the frequencies. So when using the assumed mean method, the actual mean is equal to the assumed mean plus sigma fd divided by sigma f, where d is the deviation, and you get that by subtracting the assumed mean from the x values. Let's apply this to solve a question. Let's consider this question. The table below shows the distribution of the masses of parcels in a local post office. Using an assumed mean of 48 kilograms, calculate the mean mass. So here the assumed mean we are going to use is 48 kilograms. We will draw a table with 5 columns. The class intervals will be in the first column, and then the frequencies will be in the second column. Now, these are the values that were given to us in the table. So in the table, we have the masses, that's the intervals, and then we have the frequencies. So that is what we have here. So these are the masses or the class intervals, and then these will be the frequencies. We are using the assumed mean method, and the formula is the mean is equal to the assumed mean plus sigma fd divided by sigma f. The next column here will be for the x values, that is the class midpoints or the class mid values. After getting the x values, we will be able to get the d values, which is the deviation. And the last one will be the FD, because after getting the D values, we have the F values here. So you can find FD, which will be a product of the F values and the D values. Let's begin by finding the class midpoints or the class mid values. We will get them by adding the lower class limit to the upper class limit and dividing the result by 2. So for the first one, we have 20 plus 24 divided by 2. That will give us 22. The next one will be 25 plus 29 divided by 2, which is 27. The next one is 30 plus 34 divided by 2. That will be 32. The next one is 35 plus 39 divided by 2. That is 37. The next one is 40 plus 44 divided by 2. That will be 42. The next one is 45 plus 49 divided by 2. That's 47. The next one is 50 plus 54 divided by 2. That's 52. And the last one is 55 plus 59 divided by 2. That's 57. So we now have the class midpoints or the mid values, which will give us the x values. The next thing we have to do is to find the deviation. Remember, we are using an assumed mean of 42. And we said the deviation will be equal to x minus a. So to get the first deviation, we will subtract the assumed mean a from the first x value. The first x value is 22. The assumed mean is 42. So d will be equal to 22 minus 42. Which will give us negative 20. The next d value will be 27 minus the assumed mean, which is 42, and that will give us negative 15. The next one will be 32 minus 42, which is negative 10. The next one will be 37 minus 42, which is negative 5. The next one is 42 minus 42, which is 0. Then we have 47 minus 42, which is 5. The next one is 52 minus 42, which is 10. And the last one is 57 minus 42, which is 15. We now have the D values here. We have the F values here, so we can find FD. We'll get that by multiplying the F values by the D values. So the first one will be 2 times negative 20. That's negative 40. The next one will be 3 times negative 15. That will be negative 45. The next one is 7 times negative 10, which is negative 70. The next one is 26 times negative 5, which is negative 130. The next one is 29 times 0, which is 0. The next one is 25 times 5, which is 125. The next one is 6 times 10, which is 60. And the last one is 2 times 15, which is 30. So we have been able to find the FD values. From the formula, we need sigma FD. So we will add all the FD values. When we add all of them together, we are going to get negative 70. So sigma FD is giving us negative 70. From the formula, you can see that we need sigma F. So we will add all the F values also. And that is giving us 100. So now we have the assumed mean to be 42. We have sigma FD to be negative 70. And we have sigma F to be 100. So we can find the mean. The mean will be equal to the assumed mean, which is 42, plus sigma FD, which is negative 70, divided by sigma F, which is 100. And this will give us 41.3. So it means that the mean mass is 41.3 kilograms. Let's consider the next question. The following is a record of marks obtained by a group of 50 students in a chemistry test that was scored over 100. Draw a frequency distribution table for the data using the interval 0 to 9, 10 to 19, etc. And using an assumed mean mark of 60%, calculate the mean. So here we are going to use an assumed mean of 60% to calculate the mean. We have raw data here, so it means that in our frequency distribution table, we are going to have a tally. I've already explained how to do that in the previous videos, so I'm sure that by this time you know how to do that already. So let's go ahead with the other part of the solution. We are going to find the mean using the assumed mean method. We know that the formula is the assumed mean plus sigma FD divided by sigma F. So we will have a table with 6 columns. The first one containing the class intervals. The next one will contain the tally. The next one will be the frequency, which will give us the F values. The next one will be the class midpoints or the class mid values. Then the next one will be for the deviation, and the last one will be the FD values. I'm sure that by this time you already know how to do the tally. When you do the tally for the data we have, this is what you are going to get, and this will be the frequencies from the tally. Let's find the class midpoints or the mid values, which will give us the X values. To get that, we will add the lower class limit to the upper class limit and divide the results by 2. So the first one will be 0 plus 9 divided by 2. That will be 4.5. When you do that for the next one, you are going to have 14.5. The one after that will be 24.5. The one after that is 30 to 39. So 30 plus 39 divided by 2. And that will be 34.5. The next one will be 44.5. The next one is 54.5, 64.5, 74.5, 84.5, and 94.5. These will give us the X values. Now we can find the deviation. Remember, we are using an assumed mean of 60. And to get the deviation, we will subtract the assumed mean from the X values. These are the X values, so you subtract 60 from each one of these. So the first one will be 4.5 minus 60. That will give us negative 55.5. The next one is 14.5 minus 60. And that will give us negative 45.5. The next one is 24.5 minus 60. that is negative 35.5. The next one is 34.5 minus 60, that will give us negative 25.5. The next one is 44.5 minus 60, which is negative 15.5. The next one is 54.5 minus 60, which is negative 5.5. The next one is 64.5 minus 60, and that is 4.5. We have 74.5 minus 60, that is 14.5. 84.5 minus 60 is 24.5. And the last one is 94.5 minus 60. That will give us 34.5. So we now have the D values. We already have the F values here. So to get the FD values, we will multiply the F values by the D values. So the first one will be 4 times negative 55.5. That will be negative 222. The next one will be 4 times negative 45.5. That will be negative 182. The next one is 6 times negative 35.5. That is negative 213. We have 6 times negative 25.5. That is negative 153. 8 times negative 15.5. That is negative 124. 5 times negative 5.5. That is negative 27.5. 6 times 4.5 is 27. 4 times 14.5 is 58. 4 times 24.5 is 98. And 3 times 34.5 is 103.5. We have the FD values. So we can now find sigma FD. So we add all of them. When we add all of them, we are going to have negative 635. So sigma FD is negative 635. We need sigma F. So we add all the F values. When you add them, we are going to have 50. The assumed mean is 60. So we can substitute that information here to get the mean. And this will give us 60 plus negative 635 divided by 50. And that will give us 47.3. So it means that the mean mark is 47.3%. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we will move on to another measure of central tendency, which is the mode. We will learn how to find the mode of a distribution. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to use the assumed mean method to find the mean of a given distribution. In this video, we are going to learn how to find the mode of a given distribution. The mode or the modal value of a set of numbers is the number which has the highest frequency. So when you have a distribution, the number with the highest frequency or the number that occurs most is the mode of the distribution. Let's learn some few things about the mode. When all the terms in a set of numbers have a frequency of 1, the mode of the data does not exist. So when you are given a set of numbers and all of them are having a frequency of 1, it means that that particular set of numbers does not have a mode. The mode does not exist. And another thing about the mode is that the mode of a data may be more than 1. There can be a case where the highest frequency occurs at more than one place. In that case, the mode will be more than 1. Let's apply what you have learned here to solve some questions. Let's consider this question. Find the mode of 3, 4, 3, 4, 5, 3, 6. Just as we have learnt, the mode of these set of numbers will be the number that occurs most. So I'm going to have a simple 2-column table here with the numbers in the first column and the frequencies in the second column. The numbers we have here are 3, 4, 5, and 6. When we go through them, we can see that 3 occurs 1, 2, 3 times. So the frequency for 3 is 3. 4 occurs 1, 2. So the frequency for 4 is 2. 5 occurs once, and 6 occurs once. So 3 is having a frequency of 3, 4 is having a frequency of 2, 5 is having a frequency of 1, and 6 is having a frequency of 1. The mode is the number with the highest frequency. As we can see from this table, the number with the highest frequency is 3 because 3 occurs 3 times, which is the highest. So it means that the mode of this set of numbers is 3. Let's consider another question. Find the mode of 4, 2, 2, 5, 2, 6, 5, 2, 5, 3, 4. So here too, I'll draw a simple 2-column table here. The numbers we have are 2, 3, 4, 5, and 6. When you go through the numbers, you can see that 2 occurs 4 times, 3 occurs once, 4 occurs twice, 5 occurs 3 times, and 6 occurs once. And as you can see, the number with the highest frequency is 2 because 2 occurs 4 times, which is the highest. So it means that the mode of this distribution is the number with the highest frequency. Remember, it is not the frequency, which is 4, but the number with the highest frequency. And the number with the highest frequency here is 2. So it means that the mode is 2. Let's consider another question. Find the mode of this set of numbers. Once again, I'll have my simple 2-column table. The numbers are 15, 16, 17, 18, 19, 20. When we go through them, you can see that 15 occurs 5 times, 16 occurs 5 times, 17 occurs once, 18 once, 19 once, and 20 2 times. As you can clearly see, the highest frequency here is 5, and 15 occurs 5 times, and 16 also occurs 5 times. So here, the mode of this distribution will be 15 and 16 because the highest frequency is 5, and 15 occurs 5 times, and 16 also occurs 5 times. So the mode is 15 and 16. Let's consider another one. Find the mode of these set of numbers. I'll have my table here. The numbers are 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. When you go through them, you can see that all of them occurs once. So 2 occur once, 3 once, 4 once, all of them occur just once. So as you can see, every single one of them is having a frequency of 1. We have learned that if this is the case, then the mode does not exist. If you have a distribution where every number occurs just once, it means that the mode does not exist. Let's consider another question. Here we have a frequency table. The frequency table below gives the ages of pupils in a class. Find the modal age. So we have the ages and their corresponding frequencies. Just as we have learnt, the mode is the number with the highest frequency. So here, the modal age will be the age with the highest frequency. When we look through the frequencies, we can see that the highest frequency is 35. and the age with the highest frequency, which is 35, is 15. So it means that the modal age is 15 years. Remember, the mode is not 35, which is the frequency. 35 is the highest frequency, and the age that gives you the highest frequency is 15. So it means that the modal age is 15, which occurs 35 times. Let's consider another question. The table below shows the scores of 15 students in a biology test. Find the modal score. So we have the scores and the number of students. The number of students is the same as the frequencies. The modal score will be the score with the highest frequency. When we look through the frequencies, we can see that the highest frequency is 5. The score that gives us 5 is 4. So it means that the modal score is 4 because it is the score with the highest frequency. Let's consider another question. The table below shows the distribution of the masses of parcels in a local post office. Find the modal class. So in the table, we have the masses given to us in intervals and the frequencies. Now you can see that here, the question is not asking us to find the modal mass, but it says we should find the modal class. This is because in the table, the masses is given to us in class intervals. So from the table, we can only find the modal class. The modal class will be the class with the highest frequency. So you go through the frequencies and consider the highest frequency is 29. And the class that gives us this highest frequency is 40 to 44 kilograms. So it means that the modal class is 40 to 44 kilograms. As you can see from the question we have here, when the distribution is given to you in intervals, just as we have here, you can only find the modal class from the table. But what if we want the modal mark, the actual value, the modal value? How are we going to do that? In that case, we can find the mode using a histogram drawn from the distribution. So we can use a histogram to find the modal mark of a grouped data. Let's learn how to do that. Mode from a histogram. Let's assume that this is the histogram for a particular distribution. We have the frequencies on the vertical axis and the marks on the horizontal axis. To find the mode from a histogram, the first thing you have to do is to locate the highest bar. So you go through the bar that you've drawn and then you locate the highest one. In this particular example, this is the highest bar. After locating the highest bar, you draw a line from this end to the tip of the bar to the left, and then you draw a line from this end to the tip of the bar to the right, just as we have here. So you locate the highest bar, and then you draw a line from this point to the tip of the bar on the left. Then after that, you draw a line from this point to the tip of the bar on the right. Those two lines will intersect. Where they intersect, you trace it to meet the horizontal axis, and then you read the value there. That value will give you the mode or the modal value. This is how to find the mode from a histogram. Let's apply it to some questions and see. Let's consider this question. Draw a histogram to represent the data below. Find the modal age from the histogram. So in the table, we have the ages of some workers given to us in intervals, and then we have the number of workers. From the table, we can only find the modal class. The modal class will be the class with the highest frequency. And as we can see, the class with the highest frequency is 20 to 24 because the highest frequency is 11 and that class is 20 to 24. So it means that the modal age is between 20 to 24. but that gives us the class. The question wants us to find the actual modal age, and we can do that from the histogram. So we are going to use the histogram to find the actual modal age. I've already explained how to draw a histogram for a given distribution in the previous videos, so I'm not going to go through the process in this video. I'm going to assume that by this time you already know how to draw a histogram. So I'll go ahead and consider the second part of the question, which is finding the modal age from the histogram. This is the histogram for the distribution. We have learned that to find the modal value from a histogram, the first thing you have to do is to locate the highest bar on the histogram. Here, as you can clearly see, this is the highest bar. After locating the highest bar, you draw a line from this point to the tip of the bar to the left, and then you draw a line from this point to the tip of the bar to the right. Those two lines will intersect. Here they intersect at this point. Then you trace it to the horizontal axis, and then you read the value there. Here, when I do it and trace it to the horizontal axis, the value I'm having is 23.5. It means that from this histogram, the modal age is 23.5 years. As you can see from the table, the modal class was 20 to 24. So it means the modal age was between 20 to 24. And as you can clearly see, 23.5 is between 20 to 24. So the table gave us the modal class, but from the histogram, we can actually find the modal age, which is 23.5 years. Let's consider another question. The following is a record of marks obtained by 50 students in a chemistry test. So it goes on and on. It says, draw a histogram for the distribution. We have already learned how to do that. What we are going to concentrate on is the last part, which is that find the modal mark from the histogram. So I'm going to go ahead with the drawing of the histogram because I know that by this time you already know how to do it. So this is the histogram for the distribution. We are going to use the histogram to find the modal mark. As we have learned, to find the modal mark, you first have to locate the tallest bar. As you can clearly see, this is the tallest bar. Then you draw a line from this point to this point, just as you can see. And then after that, you draw another one from this point to this point here. Those two lines will intersect. They intersect at this point. Then you trace it to meet the horizontal axis, and then you read the value there. Here, when I trace it to meet the horizontal axis and I read the value there, I'm having 43.5. It means that from the histogram, the modal mark is 43.5%. Thank you for watching this video. Subscribe to this channel for more videos. In this video, we have learned how to find the mode of a given distribution. In the next video, we are going to learn how to find the median of a given distribution. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to find the mode of a given distribution. In this video, we are going to learn how to find the median of a given distribution. Median. We will begin by learning how to find the median of a set of numbers. The median of a set of numbers is the middle value after arranging the numbers in increasing or decreasing order of magnitude. So when you have a set of numbers and you want to find its median, the first thing you have to do is to arrange the numbers in increasing or decreasing order of magnitude. That is from the highest to the lowest or the lowest to the highest. After that, the median will be the number in the middle value. Let's apply this to solve some questions. Let's consider this question. Find the median of 3, 2, 3, 4, 6. We have learned that the median of a set of numbers is the middle number after the numbers have been arranged in ascending or descending order of magnitude. So here, to find the median, the first thing we have to do is to arrange the numbers in ascending or descending order of magnitude. Here, I'm going to arrange it in ascending order, that is from the smallest to the biggest. The smallest number here is 2. The one after that is 3. We have another 3, then 4, and 6. After arranging the numbers in ascending order, the median value will be the number in the middle of the set of numbers. As you can clearly see here, we have 5 numbers in total, 2 to the left and 2 to the right. The middle number here is 3, so it means that the median is 3. Let's consider another question. Find the median of 4, 8, 3, 10, 9, 12, 13. To begin, I'll arrange the numbers in ascending order, that is from the least to the greatest. The least number here is 3. The one after that is 4. We have 8, 9, 10, 12, and 13. They are 1, 2, 3, 4, 5, 6, 7 in total. When we divide them into 2, we can see that we have 3 to the left and 3 to the right. The number in the middle is 9. So it means that the median of this set of numbers is 9. Let's consider another question. Find the median of 3, 7, 4, 1, 2, 3, 6, 9, 8, 5. We will arrange the numbers in ascending order. Remember, you can also do it in descending order. You are going to have the same results. Here, I'm going to do it in ascending order. That is from the smallest to the biggest. The smallest number here is 1. Then 1 after that is 2. The next one is 3. We have another 3, 4, 5, 6, 7, 8, and 9. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers in total. When we divide them into 2 equal parts, we can see that we have 5 on the left and 5 on the right. We don't have a single number in the middle. This is because the middle is occupied by 2 numbers, and they are 4 and 5. So in this case, to find the median, we will add the 2 numbers occupying the middle position, which are 4 and 5, and divide the result by 2. So the median will be equal to 4 plus 5 divided by 2. And this will give us 4.5. So it means that the median is 4.5. Let's consider the next question. Find the median of 10, 24, 16, 25, 8, and 14. I'll arrange the numbers in ascending order. The smallest number here is 8. The one after that is 10. We have 14, 16, 24, and 25. We have 1, 2, 3, 4, 5, 6 numbers in total. When we divide them into 2 equal parts, we will have 3 on the left and 3 on the right. Here too, you can see that when we divide the numbers into 2 equal parts, we don't have a single number in the middle. This is because the middle is occupied by 14 and 16. So these are the 2 numbers in the middle. So to get the mean, just as we did in the previous example, we will add these 2 numbers and divide the results by 2. So the median will be 14 plus 16 divided by 2. And this will give us 15. So it means that the median of this set of numbers is 15. So far, we've considered how to find the median of a set of numbers. Let's learn how to find the median from a frequency distribution table. median from a frequency distribution table. To get the median from a frequency table, find the total frequency, which is n. After that, if n is even, the median will be at the half of n position. If n is odd, the median will be at the half of n plus 1 position. Let's apply this to solve some questions. The table below shows the scores of 15 students in a biology test. Find the median score. The first thing we have to do is to find the number of students. The question has given it to us as 15. 2 plus 4 plus 5 plus 3 plus 1 gives us 15. So here the total number of students is 15. Just as we have learnt, if the number is odd, as we can see here, 15 is an odd number. If the number is odd, the median will occur at the half of n plus 1 position. Here n is 15, so n plus 1 will be 15 plus 1, which is 16. Half of 16 is 8. So what it means is that the median will occur at the 8th position. So you come to the frequencies and you count until you get to 8. The number there will give us the median. The first frequency is 2. It's still not up to 8. The next one is 4. 2 plus 4 is 6. It's still not up to 8. The next one is 5. We need just 2 to get to 8. So if you take 2 from 5 and you add it to the 6 we have, we are going to have 8, which means that the median will occur at this point. And at this point, the score there is 4. So it means that the median score is 4. Let's try another question. The table below shows the ages of pupils in a class. Calculate the median age. The first thing we have to do here is to find the total frequency. The total frequency, which is given as n, is equal to 10 plus 35 plus 7 plus 5 plus 3, and that is 60. So it means that there are 60 pupils in the class. 60 is even. After finding n, if n is even, the median will be at half of n position. N is 60, so half of 60 will give us 30. So it means that the median age is at the 30th position. So you come to the frequencies and you count until you get to the 30th position. The first frequency is 10. It is not up to 30. The next frequency is 35. We need just 20 to get to 30. So if you take 20 out of the 35 and you add it to the 10, you'll get to 30. And you'll even be left with 15. So it means that the median will occur at this particular point. The age here is 15. So it means that the median age is 15 years. Let's consider another question. The table below shows the ages of workers in a company. Find the median age class. As you can see from the table, because the ages have been given to us in intervals, the question is asking us to find the median age class. So we are looking for the class, not the actual median age. The first thing we have to do here is to find the sum of the number of workers. That is the total workers in the company. We will get that by adding the numbers here. 6 plus 8 plus 11 plus 10 plus 5 plus 3. And that gives us 43. So there are a total of 43 workers in the company. 43 is odd. if the sum of the number of workers is odd, that is if n is odd, the median will be at the half of n plus 1 position. N is 43. So n plus 1 will be 43 plus 1, which is 44. So the median will be at the half of 44 position. Half of 44 will give us 22. So it means that the median will be at the 22nd position. So you count the number of workers until you get to the 22nd position. The first one is 6. It is not up to the 22nd position. The next one is 8. 6 plus 8 is 14. It's still not up to the 22nd position. But the next one is 11. When you add 11 to 14, you are going to have 25, which is past the 22nd position. It means that the median occurs at this point. And at this point, the class there is 20 to 24. So it means that the median age class is 20 to 24 years. As you can see from here, when the data in the table given to us is grouped, you can only find the median class from the table. What if we want the actual median, that is the value itself? How are you going to find that? We can do that by using a cumulative frequency curve. So when we draw a cumulative frequency curve for a particular distribution, we can use it to find the median. Let's learn how to do that. Median from a cumulative frequency curve. Let's assume that this is a cumulative frequency curve. So we have the cumulative frequencies on the vertical axis and the max on the horizontal axis. And this is our curve. To get the median, what we have to do is that we will find half of the cumulative frequency and locate it on the cumulative frequency axis. To get that, if the cumulative frequency is even, it will be half of the cumulative frequency. If it is odd, it will be half of the cumulative frequency plus 1. After locating it on the cumulative frequency axis, you trace it to the curve, and then from there you trace it to the horizontal axis to get the actual median. So you find half of the cumulative frequency if it is even. If it is odd, you find half of the cumulative frequency plus 1. Then you plot it on the cumulative frequency axis. After that, you trace it to meet the curve, and from there you trace it to the horizontal axis to get the median. Let's apply this to solve some questions. The table below shows the marks scored by some candidates in an examination. So we have the table here showing the marks and the frequencies. Construct a cumulative frequency table and use it to draw a cumulative frequency curve for the data. Find the median mark from the cumulative frequency curve. I've already explained how to construct a cumulative frequency table and draw a cumulative frequency curve in the previous videos. So I'm going to assume that at this point you already know how to do this. So I'll go ahead to the second part of the question. This is the cumulative frequency curve for the distribution. As you can see, the cumulative frequency is 100. So sigma f is equal to 100. To get the median, the first thing we have to do is to find half of sigma f. Sigma f is even, so you find half of sigma f, which will be half of 100, and half of 100 is 50. After that, we will locate 50 on the cumulative frequency axis, and then we will trace it to the curve, and from where it meets the curve, we will trace it to the horizontal axis and read the value there. When I do that, the value I'm having is 49. So as we can see on the curve, the 50th position corresponds to 49%. It means that the median mark is 49%. Let's consider another question. The marks obtained by 40 students in an examination are as follows. So we have the marks here. Using the intervals 1 to 10, 11 to 20, 21 to 30, etc., construct a cumulative frequency table for the distribution. Draw a cumulative frequency curve for the distribution. We already know how to do this, so you concentrate on the last part, which is find the median mark from the cumulative frequency curve. So let's do that. This is the cumulative frequency curve for the distribution. As we can clearly see, the cumulative frequency is 40. So it means that sigma f is 40. And 40 is even. So to find the median, we will find half of 40. Half of 40 will give us 20. So it means that the median will occur at the 20th position. So you come to the cumulative frequency axis and you locate 20. From there, you trace it to the curve, and then you trace it to the horizontal axis, and then you read the value there. The value I'm having is 44.5. So from the curve, we can see that the 20th position corresponds to 44.5%. It means that the median mark is 44.5%. Thank you for watching this video. Subscribe to this channel for more videos. In this video, we have learned how to find the median of a given distribution. In the next video, we are going to learn how to find the quartiles, deciles, and percentiles of a given distribution. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to find the median of a given distribution. In this video, we are going to learn how to find the quartiles, deciles, and percentiles of a given distribution. Quartiles, deciles, and percentiles. Let's consider the quartiles. Quartiles divide the data into 4 equal parts. We have 3 of them. We have the first or lower quartile, the middle quartile, which is also the same as the median, and the third or upper quartile. Deciles divide the data into 10 equal parts. We have 10 of them. The first decile, second decile, third decile, up to the 10th decile. And the percentiles divide the data into 10 equal parts. We have 100 of them. The first percentile, second percentile, third percentile, up to the 100th percentile. We are going to learn how to find the quartiles, deciles, and percentiles from a cumulative frequency curve. Finding the quartiles, deciles, and percentiles from a cumulative frequency curve. From a cumulative frequency curve, the lower quartile or the first quartile is the mark corresponding to 1 divided by 4 of the cumulative frequency on the cumulative frequency axis. So it means that to find the lower quartile or the first quartile, you find 1 divided by 4 of the cumulative frequency. That is 1 divided by 4 of sigma f. Then after that, you locate it on the cumulative frequency axis, and then you trace it to the curve. Then from the point where it meets the curve, you trace it to the horizontal axis to get the lower quartile or the first quartile. To get the middle quartile or the median, it is the mark that corresponds to half of sigma f on the cumulative frequency axis. In the previous video, we learned how to find the median from the cumulative frequency axis. So I'm sure that by this time, you're already used to it. So to get the middle quartile or the median, you find half of sigma f. Then after that, you locate it on the cumulative frequency axis. You trace it to the curve. Then from the point where it meets the curve, you trace it to the horizontal axis to get the middle quartile or the median. To get the upper quartile or the third quartile, it is the mark corresponding to 3 divided by 4 of sigma f on the cumulative frequency axis. So to get the upper quartile or the third quartile, you find 3 divided by 4 of the cumulative frequency. You locate it on the cumulative frequency axis. You trace it to the curve. Then from the point where it meets the curve, you trace it to the horizontal axis to get the upper quartile or the third quartile. So the lower quartile or the first quartile is the mark corresponding to 1 divided by 4 of sigma f. The middle quartile or the median is the mark corresponding to 1 divided by 2 of sigma f. And the upper quartile or the third quartile is the mark corresponding to 3 divided by 4 of sigma f. The nth percentile is the mark corresponding to n divided by 100 of sigma f on the cumulative frequency axis. So to find the nth percentile, let's say to find the 70th percentile, it will be 70 divided by 100 times sigma f. Then the value that you get, you locate it on the cumulative frequency axis, you trace it to the curve. From the point where it meets the curve, you trace it to the horizontal axis to get the 70th percentile. If it is the 60th percentile, it means n will be 60. If it is the 13th percentile, it means n will be 30. In the same way, the nth decile is the mark corresponding to n divided by 10 of sigma f on the cumulative frequency axis. So for example, the 7th decile will be 7 divided by 100 times sigma f. The value that you get, you locate it on the cumulative frequency axis, you trace it to meet the curve, then from the point where it meets the curve, you trace it to meet the horizontal axis to get the 7th percentile. So this is how to find the quartiles, percentiles, and deciles from a cumulative frequency curve. Let's apply this to solve a question. The table below shows the marks scored by some candidates in an examination. We have the marks and their corresponding frequencies. The question says, construct a cumulative frequency table and use it to draw a cumulative frequency curve. From your curve, estimate I, the lower and upper quartiles, II, the 20th percentile, and III, the 7th decile. I've already explained how to draw a cumulative frequency table and a cumulative frequency curve in the previous videos, so I'm sure that by this time you know how to do that already. And so I'll go straight to the remaining part of the question. This is the cumulative frequency table and this is the cumulative frequency curve. We can see that the cumulative frequency is 200, so sigma f is 200. The first part of the question says we should find the lower quartile. As we have learned, to find the lower quartile, we will have to find 1 divided by 4 of sigma f. Sigma f is 200, so 1 divided by 4 of 200 will give us 50. 1 divided by 4 times 200 is 50. So to get the lower quartile, we will locate 50 on the cumulative frequency axis. 50 will be between 40 and 60, so 50 is at this point. Then we will trace it to meet the curve. From the point where it meets the curve, we will trace it to meet the horizontal axis and then read the value there. When I do that, the value I'm having is 37.5. So as we can see, 50 corresponds to 37.5 on the max less than axis. So it means that the lower quartile is 37.5. Remember, the lower quartile is not 50. The lower quartile is at the 50th position. And from the curve, the 50th position gives us 37.5%. The second part of the question says we should find the upper quartile. To get the upper quartile, we have learned that we have to find 3 out of 4 of sigma f. Sigma f is 200. 3 out of 4 of 200 will give us 3 divided by 4 times 200, which is 150. Which means that the upper quartile will occur at the 150th position. So to get it, we will have to locate 150 on the cumulative frequency axis. 150 will be between 140 and 160. So it's at this point. Then from here, we will trace it to meet the curve. From the point where it meets the curve, we will trace it to meet the horizontal axis, which is the max less than axis. And then we read the value there. When I do that on my graph sheet, I'm having 70.5. So from the curve, we can see that the upper quartile, which is at the 150th position, is 70.5. So the upper quartile is 70.5%. Let's look at the next part of the question, which is we should find the 20th percentile. Remember, we learned that the nth percentile will be given by n divided by 100 times sigma f. Here we are finding the 20th percentile, so it means that n is 20. So the 20th percentile will be equal to 20 divided by 100 times sigma f. Sigma f is 200. 20 divided by 100 times 200 is 40. So the 20th percentile will occur at the 40th position. So what we have to do is to look for 40 on the cumulative frequency axis. 40 is here. We will trace it to meet the curve. Then from where it meets the curve, we will trace it to meet the horizontal axis, which is the max less than axis. And then we read the value there. I'm having 32.5. So as you can see, the 20th percentile is 32.5%. Let's look at the last part of the question. It says we should find the 7th decile. We have learned that the nth decile will be given by n divided by 10 times sigma f. So here, the 7th decile will be 7 divided by 10 times sigma f, because n will be 7. So the 7th decile will be 7 divided by 10 times sigma f, which is 200. 7 divided by 10 times 200 is 140. So to get the 7th decile, we will locate 140 on the cumulative frequency axis, which is here. We will trace it to the curve. From the point where it meets the curve, we will trace it to the horizontal axis. And then we will read the value there. I'm having 66.5. So from the curve, the 7th decile, which is at the 140th position, corresponds to 66.5. So it means that the 7th decile is 66.5%. Thank you for watching this video. Subscribe to this channel for more videos. In this video, we have learned how to find the quartiles, deciles, and percentiles from a cumulative frequency curve for a given data. In the next video, we will learn how to find the quartiles of a set of numbers. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to find the quartiles, deciles, and percentiles of a given distribution from a cumulative frequency curve. In this video, we are going to learn how to find the quartiles of a set of numbers. Quartiles of a set of numbers. To find the quartiles of a set of numbers, first arrange the numbers in ascending order of magnitude. So the numbers must be arranged in ascending order of magnitude. That is from the smallest to the highest. After that, find the middle number of the set of numbers. The middle number will give you the middle quartile or the median. After finding the middle number, you will see that the middle number divides the set of numbers into two equal parts. The first part and the second part. The middle number of the first part will give you the first or lower quartile, and the middle number of the second part will give you the third or upper quartile. Let's apply this to solve some questions. Let's consider this question. Given the set of numbers 42, 27, 28, 65, 73, 66, 87, 23, 13, 10, 12. Find the I, first quartile, II, middle quartile, and III, the third quartile. The first thing we have to do here is to arrange the numbers in ascending order of magnitude. That is from the smallest to the highest. The smallest number here is 10, followed by 12, 13, 23, 27, 28, 42, 65, 66, 73, and 87. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers in total. When we divide this set of numbers into two equal parts, we can see that we have 5 on the left and 5 on the right. And the number in the middle is 28. So the middle number is 28, which means that the middle quartile or the median is 28. As you can see, after dividing the number into two equal parts, we have the first part, which is 10, 12, 13, 23, and 27. We have learned that the middle number of the first part will give us the first or the lower quartile. The first part is 10, 12, 13, 23, 27. We have 5 in total. So you have 2 to the left and 2 to the right, and you can see that the middle number is 13. So it means that the first quartile is 13, because 13 is the middle number of the first part. The second part is 42, 65, 67, 73, 87. We have 5 of them. You have 2 to the left and 2 to the right. The middle number there is 66. The middle number of the second part will give us the third quartile. So it means that the third quartile is 66. Let's try another question. Given the set of numbers 16, 16, 3, 6, 3, 8, 10, 14, 19, 24, find the first quartile, the middle quartile, and the third quartile. The first thing we have to do is to arrange the numbers in ascending order, so from the smallest to the highest. When we do that, we are going to have 3, 3, 6, 8, 10, 14, 16, 16, 19, and then 24. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 in total. So when we divide them into two equal parts, we have 5 on the left and 5 on the right. As you can see, when we divide them into two equal parts, we don't have one number in the middle. This is because the middle is occupied 10 and 14. So the middle quartile or the median will be equal to the sum of these two numbers divided by 2. So 10 plus 14 divided by 2, and this will give us 12. So it means that the middle quartile is 12. After dividing the set of numbers into two equal parts, we can see that we have 5 to the left. That will give us the first part. 3, 3, 6, 8, 10. The middle number of the first part will give us the first quartile. The first part, we have 5 numbers in total. The middle number will be 6. So it means that the first quartile or the lower quartile is 6. The second part, we have 14, 16, 16, 19, 24. We have 5 in total. So when we divide it into two equal parts, we have 2 to the left, 2 to the right. The middle number there is 16. The middle number of the second part will give us the third or the upper quartile. So it means that the third or the upper quartile is 16. Let's consider another question. Given the set of numbers 4, 8, 5, 6, 13, 11, 15, 15, 20. Find the first quartile, the middle quartile, and the third quartile. As we've been doing all along, we will arrange the numbers in ascending order, that is from the smallest to the highest. When we do that, we are going to have 4, 5, 6, 8, 11, 13, 15, another 15, and then 20. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 in total. When we divide it into 2 equal parts, we have 4 to the left and 4 to the right. We have one number in the middle, so it means that that number will be the middle quartile or the median. So the middle quartile or the median is 11. When we divide the numbers into 2 equal parts, we can see that the first part will be 4, 5, 6, 8. The middle number of the first part will give us the first quartile. The first part is having 4 numbers. So when we divide it into 2, you can see that we have 2 to the left and 2 to the right. We don't have one number in the middle. This is because the middle is occupied by 5 and 6. So the first quartile will be the sum of 5 and 6 divided by 2. So we have 5 plus 6 divided by 2, which will give us 5.5. So it means that the first quartile or the lower quartile is 5.5. The third quartile or the upper quartile will be the middle number of the second part. The second part is 13, 15, 15, 20. We have 4 in total. So when we divide it into 2, you have 2 to the left and 2 to the right. There is no number in the middle. This is because the middle is occupied by 15 and 15. So the third quartile or the upper quartile will be the sum of 15 and 15 divided by 2. 15 plus 15 divided by 2 gives us 15. So it means that the third quartile or the upper quartile is 15. With the examples that we've considered so far, I'm sure that you can find the first or the lower quartile, the middle quartile or the median, and the third quartile or the upper quartile of a given set of numbers. In the introductory video to statistics, these are the objectives that we began with. We said that we are going to learn how to construct a grouped or an ungrouped frequency distribution table for a given data. We've done that. We said we are going to learn how to represent a given statistical data graphically. We've done that. We've learned how to draw a bar chart, pie chart, histogram, and cumulative frequency curve. We also said we are going to learn how to find measures of central tendencies for a given data. We've done that. We've learned how to find the mean, the median, and the mode. And we have also learned how to find the quartiles, the deciles, and then the percentiles. We are left with the last part, which is the measures of central tendencies. So in the subsequent videos, we are going to learn how to find the measures of central tendencies for a given data. The ones we are going to consider are the range, the interquartile range, the semi-interquartile range, the mean deviation, the standard deviation, and then the variance. In the next video, we will begin with the range, interquartile range, and the semi-interquartile range. So in the next video, we are going to learn how to find the range, the interquartile range, and the semi-interquartile range for a given data. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to find the quartiles of a set of numbers. In this video, we are going to learn how to find the range, interquartile range, and semi-interquartile range of a set of numbers. Range, interquartile range, and semi-interquartile range. The range of a set of numbers is the difference between the greatest and least number in the set of numbers. So when you have a set of numbers, to get the range, you subtract the least number, that is the smallest number, from the greatest number, that is the highest number. The interquartile range of a set of numbers is the difference between the upper and lower quartile of the set of numbers. So the upper quartile minus the lower quartile will give you the interquartile range. The semi-interquartile range of a set of numbers is given by the interquartile range divided by 2. Remember, the interquartile range is the upper quartile minus the lower quartile. So the semi-interquartile range is equal to the upper quartile minus the lower quartile, which is the interquartile range, divided by 2. Let's apply this to solve a question. The question is, the number of points scored by 15 basketball teams in a week's game are given below. So we have the numbers here. From the data above, find I, the range, II, the upper and lower quartile, III, the interquartile range, and IV, the semi-interquartile range. To do all of this, the first thing we have to do is to arrange the numbers in ascending order of magnitude. That is from the lowest to the highest. So we will begin by arranging the numbers from the lowest to the highest. The smallest number here is 29. The one after that is 35. The next one is 36. The one after that is 37. We have 38, 140, 143, 143, another 143, 145, 146, 147, 149, 156, and the last one is 158. The first thing we want to find is the range, and we have learned that the range is equal to the greatest value minus the least value. The greatest value is the highest value, and as you can see, the highest value is 158. The least value is the smallest value, and as you can see, the smallest value is 129. So the range will be equal to 158 minus 129, and that will give us 29. So it means that the range of this set of numbers is 29. Let's move on to the next part. It says that we should find the upper and lower quartiles. We have already arranged the numbers in ascending order. We have that here. To get the upper and lower quartile, we will have to divide the numbers into 2 equal parts. We have 15 in total here. So when we divide it into 2 equal parts, you see that we will have 1, 2, 3, 4, 5, 6, 7 on the left side. And on the right side too, you have 1, 2, 3, 4, 5, 6, 7. The middle number is 143, so that will give us the middle quartile. But the question did not tell us to find the middle quartile. We want the upper and then the lower quartile. The lower quartile will be the middle number of the first part. The first part is 129, 135, 136, 137, 138, 140, 143. There are 7 in total. So when we divide this into 2, you have 3 to the left and 3 to the right. The middle number is 137. When we consider the second part, we have 143, 145, 146, 147, 149, 156, and 158. We have 7 in total. When we divide it into 2, you have 3 to the left and 3 to the right. And as you can see, the middle number is 147. The middle number of the first part will give us the lower quartile or the first quartile, and that is 137. The middle number of the second part will give us the third quartile or the upper quartile, and that is 147. So the lower quartile is 137 and the upper quartile is 147. We want to find the interquartile range. Remember, we said the interquartile range is the upper quartile minus the lower quartile. The upper quartile is 147, the lower quartile is 137. So the interquartile range will be equal to 147 minus 137, and this will give us 10. The semi-interquartile range is equal to the interquartile range divided by 2. The interquartile range is 10. So the semi-interquartile range will be equal to 10 divided by 2, which is 5. So we have been able to find the range, the lower quartile, the upper quartile, the interquartile range, and the semi-interquartile range. Thank you for watching this video. Subscribe to this channel for more videos. In this video, we learned how to find the range, the interquartile range, and the semi-interquartile range. In the next video, we are going to move on to another measure of dispersion, which is the mean deviation. We will learn how to find the mean deviation of a set of numbers. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to find the range, interquartile range, and semi-interquartile range of a set of numbers. In this video, we are going to learn how to find the mean deviation of a set of numbers. Mean deviation of a set of numbers. Given that x1, x2, and x3 up to xn are a set of n numbers, the mean deviation is given by the formula the sum of, or sigma, the absolute value of x minus the mean of x divided by n, where n is the number of numbers in the set. The mean is equal to the sum of all the x values divided by n. So to get the mean deviation, we will first have to find the mean. Then we will subtract the mean from each of the x values, and after that we will find their absolute values. Then we will add all of them and divide it by n, which is the number of numbers. As we can see here, we will find the absolute values of numbers. How do we do that? The absolute value of a positive number is positive. So let's say you have a positive number a. If you find the absolute value of a, you are going to have a. The absolute value of a negative number is also positive. So let's say you have a negative number, negative a. If you find the absolute value of negative a, you are going to have a. So for example, the absolute value of 2 is 2. And the absolute value of negative 3 is 3. So if you have a positive number, when you find its absolute value, you are going to have a positive number. When you have a negative number, when you find its absolute value, it's going to be a positive number. So this is how to find the absolute value of a number. Now that we understand this, let's apply what you've learned here to solve some questions. This is the first question. Find the mean deviation of the following set of numbers: 12, 15, 19, 22, 25, and 27. The mean deviation is given by the formula sigma, the absolute value of x minus the mean of x divided by n. To get the mean deviation, we first have to find the mean of x. We will get the mean of x by adding all the x values, that is the set of numbers given to us, and then dividing it by their number. They are 1, 2, 3, 4, 5, 6. They are 6 in number, so it means that n is equal to 6. So I have my 2-column table with the x values in the first one, and in the second one, I'll have my absolute value of x minus the mean of x. To get that, I'll first have to find x minus the mean of x, and so I will need the mean of x. So the mean of x is equal to 12 plus 15 plus 19 plus 22 plus 25 plus 27 divided by 6. And this will give us 20. So the mean of x is 20. Now I need x minus the mean of x. So I will subtract the mean, which is 20, from these x values. So the first one will be 12 minus 20. 12 minus 20 is negative 8. But we have learned that if you find the absolute value of a negative number, it's going to be the positive number. So the absolute value of negative 8 is 8. We move on to the next one. The x value is 15. So we are looking for 15 minus the mean of x, which is 20. But we will find the absolute value. 15 minus 20 is negative 5. The absolute value of negative 5 is 5. The next one is 19. We want x minus the mean of x, its absolute value. X is 19 and the mean of x is 20. So we have 19 minus 20, which will give us negative 1. The absolute value of negative 1 is 1. The next one is 22. So we have 22 minus the mean, which is 20. 22 minus 20 will give us 2. The absolute value of 2 is 2. The next one is 25. 25 minus 20 will give us 5. The absolute value of 5 is 5. The last one is 27. 27 minus the mean, which is 20, is 7. The absolute value of 7 is 7. So we now have the absolute values of x minus the mean of x. We can now find the sum of the absolute values of x minus the mean of x. So we will add all the numbers here. 8 plus 5 plus 1 plus 2 plus 5 plus 7. And that will give us 28. So now we have the sum of the absolute values of x minus the mean of x as 28. We have n to be 6. So it means that the mean deviation will be equal to 28 divided by 6. And this will give us 4.67. So the mean deviation of this set of numbers is 4.67. Let's consider another question. Find the mean deviation of the following set of numbers. We have 5, 8, 10, 11, 12, 14, 15, and then 17. The mean deviation is given by the formula, the sum of the absolute values of x minus the mean of x divided by n. We have 1, 2, 3, 4, 5, 6, 7, 8 numbers in total. So it means that n is equal to 8. I'll draw my 2-column table with the x values in the first column, and then in the second column I'll have my absolute value of x minus the mean of x. So I'll first have to find the mean of x. You get the mean of x by adding all the x values and then dividing it by their number, which is 8. So I'll have 5 plus 8 plus 10 plus 11 plus 12 plus 14 plus 15 plus 17 divided by 8. And this will give us 11.5. So the mean of x is 11.5. Now I will subtract the mean from the x values here and then find its absolute value. So the first one will be 5 minus 11.5. That one will give us negative 6.5. But the absolute value of negative 6.5 is 6.5. The next one is 8. So I have 8 minus 11.5. That will give us negative 3.5. But the absolute value of negative 3.5 is 3.5. The next one is 10. So you have 10 minus 11.5. That will give us negative 1.5. The absolute value of negative 1.5 is 1.5. The next one is 11. You have 11 minus 11.5. That will give us negative 0.5. The absolute value of negative 0.5 is 0.5. The next one is 12. So you have 12 minus 11.5. That will give us 0.5. The absolute value of 0.5 is 0.5. The next one is 14 minus 11.5. That will give us 2.5. The absolute value of 2.5 is 2.5. The next one is 15. So we have 15 minus 11.5. That is 3.5. The absolute value of 3.5 is 3.5. And the last one is 17. 17 minus 11.5 will give us 5.5. The absolute value of 5.5 is 5.5. So we now have the absolute values of x minus the mean of x. We need their sum. So you add all of them. 6.5 plus 3.5 plus 1.5 plus 0.5 plus 0.5 plus 2.5 plus 3.5 plus 5.5 will give us 24. So the sum of the absolute values of x minus the mean of x is 24. We can now find the mean deviation. The mean deviation will be equal to the sum of the absolute values of x minus the mean of x, which is 24, divided by n, which is 8. 24 divided by 8 is 3. So it means that the mean deviation of this set of numbers is 3. Thank you for watching this video. Subscribe to this channel for more videos. In this video, we learned how to find the mean deviation of a set of numbers. In the next video, we are going to learn how to find the mean deviation from a frequency distribution table. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to find the mean deviation of a set of numbers. In this video, we are going to learn how to find the mean deviation from a frequency distribution table. Mean deviation from a frequency distribution table. From a frequency distribution table, the mean deviation is equal to sigma f times the absolute values of x minus the mean of x divided by sigma f. To get the mean of x, we will divide sigma fx by sigma f. So when you have a frequency distribution table and you are asked to find the mean deviation, you have to find f times the absolute values of x minus the mean of x, and then you find their sum. After that, you divide it by the sum of the f values. Let's apply this to solve a question. Let's consider this question. The marks scored by students in an examination are given in the table below. Find the mean deviation. So in the table, we have the marks and the number of students who scored each mark. We have learned that to get the mean deviation, the formula we are going to use is sigma f times the absolute values of x minus the mean of x divided by sigma f. And so we are going to draw a 5-column table. The first column will be for the marks, which will give us the x values. The second column will be for the number of students or the frequencies, which will give us the f values. We need the mean, and so we will have a column for fx, because the mean is equal to sigma fx divided by sigma f. Then we need the absolute values of x minus the mean of x, so we have a column for that. And finally, we will need f times the absolute values of x minus the mean of x. Let's fill the table up. So we have the marks here and the frequencies. The third column is fx. We'll get the fx values by multiplying the f values by the x values. So the first one will be 6 times 20, which is 120. The next one is 8 times 25, which is 200. The next one is 10 times 30, which is 300. We have 15 times 35, which is 525. 11 times 40 is 440. 4 times 45 is 180. We need sigma fx and sigma f, so we add all the f values, and that gives us 54. For sigma fx, we add all the fx values, and that will give us 1000 765. So we can find the mean. So the mean will be equal to 1765 divided by 54. And this will give us 32.69. We know that to get the mean deviation, the formula is sigma f times the absolute values of x minus the mean of x divided by sigma f. So we need to find the absolute values of x minus the mean of x. After that, we will multiply it by sigma f. And that is what we have in the fourth column, the absolute values of x minus the mean of x. To get that, we will subtract the mean, which is 32.69, from the x values. So the first one will be 20 minus 32.69. 20 minus 32.69 is negative 12.69, but the absolute value of negative 12.69 is 12.69. The next one will be 25 minus 32.69. 25 minus 32.69 is negative 7.69. The absolute value of negative 7.69 is 7.69. The next one will be the absolute value of 30 minus 32.69, and that will be 2.69. The next one is 35 minus 32.69. 35 minus 32.69 is 2.31. The absolute value of 2.31 is 2.31. The next one is 40 minus 32.69, which is 7.31. The absolute value is 7.31. And the last one is 45 minus 32.69. The absolute value of 45 minus 32.69 is 12.31. Now that we have the absolute values of x minus the mean of x, we can find f times the absolute value of x minus the mean of x. So you multiply the values in this column by the values in this column. So the first one will be 6 times 12.69. That will be 76.14. The next one is 8 times 7.69, which is 62.52. The next one is 10 times 2.69, which is 26.90. The next one is 15 times 2.31, which is 34.65. The next one is 11 times 7.31, which is 80.41. And the last one is 4 times 12.31, which is 49.24. We need the sum of these values, so we add all of them. When we add all of them, you have 328.86. So we can now find the mean deviation. The mean deviation will be equal to 328.86 divided by 54. And this will give us 6.09. So the mean deviation of the distribution is 6.09. Let's consider another question. The table below shows the distribution of marks in a mathematics test. So we have the marks and their corresponding frequencies. We are going to use this information to find the mean deviation. We know that the mean deviation is given by the formula sigma f times the absolute values of x minus the mean of x divided by sigma f. To get this, we will draw a 6-column table. The reason why we are drawing a 6-column table is that we will have to include a column for the class midpoints, because here we have been given the intervals. So our x values should be the class midpoints. So in the first column, we have the marks. In the second column, we have the frequencies. In the third column, we have the class midpoints, which will be the x values. In the third column, we have the fx values because we need the mean. In the next column, you have the absolute values of x minus the mean of x. And in the last one, we have f times the absolute values of x minus the mean of x. Let's fill it up. So we have the marks here and their corresponding frequencies. To get the class midpoints, you add the lower class limits to the upper class limit and divide the result by 2. So the first one will be 1 plus 20 divided by 2. And 1 plus 20 divided by 2 is 10.5. The next one is 21 plus 40 divided by 2, which is 30.5. The next one is 41 plus 60 divided by 2, that is 50.5. The next one is 61 plus 80 divided by 2, that is 70.5. And the last one is 81 plus 100 divided by 2, and that is 90.5. We now have the x values, so we can find fx. We will get it by multiplying the f values by the x values. So the first one will be 8 times 10.5, which is 84. The next one is 14 times 30.5, which is 427. The next one is 18 times 50.5, which is 909. The next one is 48 times 70.5, which is 3,384. And the last one is 12 times 90.5, which is 1,086. We have the fx values. We have the f values. To get the mean, we will need sigma f, which is 100, and sigma fx, which is 5,890. So you divide 5,890 by 100, and that will give us 58.9. Now we have the mean, so we can find the absolute values of x minus the mean. So you subtract 58.9 from the x values, which we have here, the class midpoints, and then we will find the absolute value. The absolute value of 10.5 minus 58.9 is 48.4. The absolute value of 30.5 minus 58.9 is 28.4. The absolute value of 50.5 minus 58.9 is 8.4. The absolute value of 70.5 minus 58.9 is 11.6. And the absolute value of 90.5 minus 58.9 is 31.6. We now have the absolute values of x minus the mean of x. So we can find f times the absolute values of x minus the mean of x. So we are going to multiply the numbers in this column by the numbers in this column. So the first one will be 8 times 48.4, and that is 387.2. The next one is 14 times 28.4, that is 397.6. The next one is 18 times 8.4, which is 151.2. The next one is 48 times 11.6, that is 556.8. And the last one is 12 times 31.6, and that is 379.2. We need the sum of these values, so we add all of them, and we'll have 1,872. We can now find the mean deviation. The mean deviation will be equal to 1,872 divided by sigma f, which is 100. And this will give us 18.72. So the mean deviation of the distribution is 18.72. Let's consider the last question. The marks obtained by 40 students in an examination are as follows. So we have the raw data here. Using the class intervals 1 to 10, 11 to 20, 21 to 30, etc., construct a frequency table for the distribution. That's the first part. And the second part is find the mean deviation of the data. Here we have the raw data. We know that the mean deviation is equal to sigma f times the absolute values of x minus the mean of x divided by sigma f. Because we have the raw data, our table is going to have 7 columns. The reason why we are having 7 columns is that we will have to introduce an additional column for the tally. So you have the class intervals in the first one, the second one will be for the tally, the third one will be for the frequency, the fourth one will be for the class midpoints, which will be the x values. We will need the mean, and so the fifth one will be for fx. The sixth one will be for the absolute values of x minus the mean of x, and the seventh one will be f times the absolute values of x minus the mean of x. Because I've already explained how to do the tally for raw data like this in the previous video, I'll assume that you know how to do the tally by now, so I'll not go through the process of doing the tally. Here's our table. We have the class intervals here, we have the tally here, and we have the frequencies. We know that the mean, you will find it by using the formula sigma fx divided by sigma f. So we need the x values, and the x values will be the class midpoints. You add the lower class limit to the upper class limit and divide the result by 2. So you have 1 plus 10 divided by 2, that is 5.5. 11 plus 20 divided by 2 is 15.5. 21 plus 30 divided by 2 is 25.5. So when you go through the same process, the next one will be 35.5, we have 45.5, 55.5, 65.5, 75.5, 85.5, and 95.5. We can now find our fx values. You multiply the f values, that is the values in this column, by the x values, the values in this column. 1 times 5.5 is 5.5. 4 times 15.5 is 62. 6 times 25.5 is 153. 6 times 35.5 is 213. 7 times 45.5 is 318.5. 6 times 55.5 is 333. 4 times 65.5 is 262. 3 times 75.5 is 226.5. 2 times 85.5 is 171. And finally, 1 times 95.5 is 95.5. We will need sigma fx to find the mean. So we add everything here together, and that gives us 1,840. So the mean will be equal to 1,840 divided by 40, and that will give us 46. So the mean of the distribution is 46. In the next column, we are going to find the absolute values of x minus the mean of x. So it will be the x values minus the mean, which is 46. Then we find the absolute value. So the first one will be the absolute value of 55.5 minus 46, and that will be 40.5. The absolute value of 15.5 minus 46 is 30.5. The absolute value of 25.5 minus 46 is 20.5. The absolute value of 35.5 minus 46 is 10.5. The absolute value of 45.5 minus 46 is 0.5. The absolute value of 55.5 minus 46 is 9.5. The absolute value of 65.5 minus 46 is 19.5. The absolute value of 75.5 minus 46 is 29.5. The absolute value of 85.5 minus 46 is 39.5. And the absolute value of 95.5 minus 46 is 49.5. Now that we have the absolute values of x minus the mean of x, we can find f times the absolute value of x minus the mean of x. So you multiply the numbers in this column by the numbers in this column. So the first one will be 1 times 40.5, which is 40.5. The next one is 4 times 30.5, which is 122. The next one is 6 times 20.5, which is 123. The next one is 6 times 10.5, which is 63. The next one is 7 times 0.5, which is 3.5. The next one is 6 times 9.5, which is 57. The next one is 4 times 19.5, which is 78. The next one is 3 times 29.5, which is 88.5. The next one is 2 times 39.5, which is 79. And the last one is 1 times 49.5, which is 49.5. We need the sum of these values, so we add everything here together, and that gives us 704. So the mean deviation will be equal to 704 divided by sigma f, which is 40, and this will give us 17.6. So the mean deviation of the data given to us is 17.6. Thank you for watching this video. Subscribe to this channel for more videos. In this video, we have learned how to find the mean deviation from a frequency distribution table. In the next video, we are going to learn how to find the standard deviation and variance of a set of numbers. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to find the mean deviation from a frequency distribution table. In this video, we are going to learn how to find the standard deviation and variance of a set of numbers. Standard deviation and variance of a set of numbers. Given that x1, x2, x3 up to xn are a set of n numbers, then the standard deviation is given by x, and x is equal to square root of sigma x minus the mean of x squared divided by n, where n is the number of numbers that you have. The variance of a distribution is equal to the standard deviation squared. So if the standard deviation is x, then the variance will be x squared. When you square both sides, the square will get rid of the square root. So x squared will be equal to sigma x minus the mean of x squared divided by n. Let's apply what we have learned here to solve some questions. Let's consider this question. Find the standard deviation and variance of the following set of numbers: 10, 11, 15, 10, 6, and 5. We have learned that the standard deviation is equal to square root of sigma x minus the mean of x squared divided by n, where n is the number of numbers. Here we have 1, 2, 3, 4, 5, 6. So we have 6 numbers, and so n is equal to 6. I'll draw a simple 3-column table here. In the first column, I'll have the x values. In the second column, I'll have the x minus the mean values. And in the last column, I'll have x minus the mean squared. To get x minus the mean of x, we first have to find the mean. We will get the mean by adding the numbers together and dividing it by their number. When we counted them, they were 6 in number. So we add all of them and we divide it by 6. We are going to have 5 plus 6 plus 10 plus 10 plus 11 plus 15. Divided by 6 will give us 9.5. So we can now find x minus the mean. The mean is 9.5. So we subtract 9.5 from each one of these values. So the first one will be 5 minus 9.5, which is negative 4.5. The next one is 6 minus 9.5, which is negative 3.5. The next one is 10 minus 9.5, which is 0.5. We have another 10 minus 9.5, which is 0.5. The next one is 11 minus 9.5, which is 1.5. And the last one is 15 minus 9.5, and that will be 5.5. We can now find x minus the mean squared. So we will square all the numbers here. The first one will be negative 4.5 squared, which will give us 20.25. The next one is negative 3.5 squared. That will give us 12.25. The next one is 0.5 squared. That is 0.25. Another 0.5 squared is 0.25. 1.5 squared is 2.25. And 5.5 squared is 30.25. We need the sum of the values here, so we add everything together. When we add everything together, sigma x minus the mean squared will be 65.5. So we can now find the standard deviation. The standard deviation will be equal to square root of 65.5 divided by 6. And this will give us 3.30. The question said we should find the standard deviation and variance. We know that the variance is equal to the standard deviation squared. The standard deviation is 3.30, and so the variance will be equal to 3.30 squared, and this will give us 10.89. So the standard deviation is 3.30 and the variance is 10.89. Let's consider the next question. Find the standard deviation and variance of the following set of numbers: 5, 6, 7, 8, 9, 10, 12, and 15. We know that the standard deviation is equal to square root of sigma x minus the mean squared divided by n. When we count the numbers, we have 1, 2, 3, 4, 5, 6, 7, 8. So it means that n is equal to 8. I'll draw my 3-column table here with the first column occupying the x values. The x values will occupy the first column. And then in the second column, you have the x minus the mean of x. And then the next column will be x minus the mean of x squared. In the second column, we need x minus the mean of x, which means that we will first have to find the mean. We will get the mean by adding all the numbers and dividing it by their number. They are 8 in number, so we add all of them and we divide it by 8. 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 12 plus 15 divided by 8 is 9. So we now have the mean to be 9. In this column, we need x minus the mean. So it will be the x values here minus the mean. The first one will be 5 minus 9, which is negative 4. The next one is 6 minus 9, which is negative 3. 7 minus 9 is negative 2. 8 minus 9 is negative 1. 9 minus 9 is 0. 10 minus 9 is 1. 12 minus 9 is 3. And 15 minus 9 is 6. In the third column, we have x minus the mean squared. And so we are going to square the values that we have here, because these are the x minus the mean values. So if you need x minus the mean squared, we have to square the values here. So you have negative 4 squared, that will be 16. Negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 3 squared is 9. And 6 squared is 36. We need the sum of these values, so you add all of them together. When we add all of them together, we are going to have 76. So sigma x minus the mean squared is 76. So we can now find the standard deviation. The standard deviation will be equal to square root of sigma x minus the mean squared, which we have found to be 76, divided by the number of numbers, which is 8. And this will give us 3.08. We have the standard deviation, and so we can find the variance. Remember, the variance is equal to the standard deviation squared. So if the standard deviation is 3.08, then the variance will be equal to 3.08 squared, which is 9.49. So the standard deviation is 3.08 and the variance is 9.49. Thank you for watching this video. Subscribe to this channel for more videos. In this video, we have learned how to find the standard deviation and variance of a set of numbers. In the next video, we are going to learn how to find the standard deviation and variance from a frequency distribution table. Bye-bye. Welcome back. We are still on the topic statistics. In the previous video, we learned how to find the standard deviation and variance of a set of numbers. In this video, we are going to learn how to find the standard deviation and variance from a frequency distribution table. Standard deviation and variance from a frequency distribution table. From a frequency distribution table, the standard deviation is given by x, and x is equal to square root of sigma f x squared divided by sigma f minus the mean squared. We have learned that the variance is equal to the square of the standard deviation. So if standard deviation is x, then variance will be x squared, and it will be equal to sigma f x squared divided by sigma f minus the mean squared. Let's apply this to solve some questions. Let's consider this question. The table below shows the distribution of goals scored by a football team. Calculate the standard deviation and variance. So in the table, we have the goals scored and their corresponding frequencies. We are going to calculate the standard deviation and variance. The variance is equal to the square of the standard deviation. So we will calculate for the standard deviation and then we will square our answer to get the variance. We have learned that the standard deviation will be equal to square root of sigma f x squared divided by sigma f minus the mean squared. So we are going to draw a 5-column table. We will have the goals scored in one column, that will be for the x values, and then the frequencies in one column, that will be for the f values. We need the mean, and so we will have a column for fx because the mean will be equal to sigma fx divided by sigma f. From the formula, we can see that we need x squared, so I'll have a column for x squared. And then we need sigma fx squared, and so I'll have a column for fx squared. Let's fill the table up. We have the x values here, that's the goals scored, and then the f values here, that's the frequencies. The next column is fx. To get fx, we will multiply the f values by the x values. So you have 4 times 1, which is 4, 2 times 2, 4, 1 times 3, 3, 2 times 4, 8, 1 times 5, 5, and 2 times 6, 12. To get the mean, we need sigma fx, which is, we will add all the values here, and that will give us 36, and sigma f, so we add all the values here, and that gives us 12. So the mean, which is given by the formula sigma fx divided by sigma f, is equal to sigma fx, which is 36, divided by sigma f, which is 12. 36 divided by 12 is 3. So we now have the mean. The next in the table is x squared. So we will take the x values and then we will square them. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36. We can now find fx squared, which is the last column. So you multiply the values in this column, that is the x squared values, by the f values, that's the values we have in this column. So the first one will be 4 times 1, which is 4. You have 2 times 4, which is 8. 1 times 9 is 9. 2 times 16 is 32. 1 times 25 is 25. And 2 times 36 is 72. We need sigma fx squared. So we add all of these values, and that gives us 150. So we can now find the standard deviation. The standard deviation will be equal to square root of sigma fx squared, which is 150, divided by sigma f, which is 12, minus the mean squared. We have found the mean to be 3, so that will be 3 squared. And this will give us 1.87. So the standard deviation of this distribution is 1.87. The variance is equal to the standard deviation squared. And so the variance will be equal to 1.87 squared. And that will give us 3.50. So the standard deviation is 1.87 and the variance is 3.50. Let's consider the next question. The table below shows the distribution of marks in a mathematics test. Calculate the standard deviation and variance. We have the marks and their corresponding frequencies. Here the marks are given to us in intervals. We know that the standard deviation is equal to square root of sigma fx squared divided by sigma f minus the mean squared. We will first calculate for the standard deviation, and after that we will square the results to get the variance. Here we will draw a 6-column table. We will add another column because we will need the class midpoints, which will be the x values, because here the marks were given to us in intervals, so the x values will be the class midpoints. So you have a 6-column table here. The first column will be for the marks, which will be the intervals. We have the frequencies, which will give us the f values, the class midpoints, which will give us the x values. We will need to find the mean, and so we will have a column for the fx values, and then we need sigma fx squared. So I'll first find x squared in one column, and then I'll multiply the values there by f in the last column to give us the fx squared values. Let's fill the table up. So we have the marks here and their corresponding frequencies. We will get the class midpoints by adding the lower class limit to the upper class limit and dividing the results by 2. So the first one will be 1 plus 20 divided by 2, that's 10.5. The next one is 21 plus 40 divided by 2, that's 30.5. 41 plus 60 divided by 2 will give us 50.5. 61 plus 80 divided by 2 is 70.5. And 81 plus 100 divided by 2 is 90.5. We have the x values, we have the f values, so we can find fx. We will multiply the f values by the x values. 8 times 10.5 is 84. 14 times 30.5 is 427. 18 times 50.5 is 909. 48 times 70.5 is 3384, and 12 times 90.5 is 1086. To get the mean, we will need sigma fx and we will need sigma f. Sigma fx is 5890 and sigma f is 100. So the mean will be equal to 5890 divided by 100, and that gives us 58.9. In the table, the next column is x squared, so we will square the x values here. 10.5 squared is 110.25. 30.5 squared is 930.25. 50.5 squared is 2550.25. 70.5 squared is 4970.25, and 90.5 squared is 8190.25. We can now find fx squared, and so we will multiply the f values by the x squared values. 8 times 110.25 is 882. 14 times 930.25 is 13023.5. 18 times 2550.25 is 45904.5. 48 times 4970.25 is 238572, and 12 times 8190.25 is 98283. We need sigma fx squared, so you add all the values here, and that gives us 39665. So we can now find the standard deviation. The standard deviation will be equal to square root of sigma fx squared, which is 39665, divided by sigma f, which is 100, minus the mean squared. We have found the mean to be 58.9. So 58.9 squared. And this gives us 22.3. So the standard deviation is 22.3. We know that the variance is equal to the standard deviation squared. So if the standard deviation is 22.3, then the variance will be 22.3 squared, which is 497.29. So the standard deviation of the distribution is 22.3, and the variance is 497.29. Let's consider the next question. The following is a record of marks obtained by a group of 50 students in a chemistry test that was scored over 100. So we have the raw data here. The first part of the question says, draw a frequency distribution table for the data using the intervals 0 to 9, 10 to 19, etc. B. Find the standard deviation and variance of the data. Here we have the raw data. We know that the standard deviation is equal to square root of sigma fx squared divided by sigma f minus the mean squared. Because we have the raw data, we are going to have a 7-column table because we will introduce another column for the tally. So we have the class intervals in the first column, we have the tally in the second, the frequencies in the third, the class midpoints, which will be the x values in the fourth. In the fifth, we will have the fx values because we will have to find the mean. In the sixth, we will have the x squared values, and in the seventh and final one, we have the fx squared values. Let's fill the table up. Because I've already explained how to do the tally for a raw data in the previous videos, I will assume that you already understand it. So I've done that here. These are the class intervals, these are the tallies, and their corresponding frequencies. We know that the standard deviation is equal to square root of sigma fx squared divided by sigma f minus the mean squared. We will have to find the class midpoints. We will get it by adding the lower class limit to the upper class limit and dividing the result by 2. So the first one will be 0 plus 9 divided by 2, that is 4.5. The next one is 10 plus 19 divided by 2, that is 14.5. The next one is 20 plus 29 divided by 2, that is 24.5. If we continue in that order, the next one will be 34.5. The one after that is 44.5. You have 54.5, 64.5, 74.5, 84.5, and 94.5. We can now find the fx values. So you multiply the f values by the x values. 4 times 4.5 is 18. 4 times 14.5 is 58. 6 times 24.5 is 147. 6 times 34.5 is 207. 8 times 44.5 is 356. 5 times 54.5 is 272.5. 6 times 64.5 is 387. 4 times 74.5 is 298. 4 times 84.5 is 338. And 3 times 94.5 is 283.5. We can now find the mean. To get the mean, we need sigma fx. So we add all the values here, and that gives us 2,365. And we will also need sigma f. So we add all the values here, and that gives us 50. So the mean will be equal to sigma fx, which is 2365, divided by sigma f, which is 50, and that will give us 47.3. In the table, the next thing that we need to find is x squared. So we will square all the x values here. 4.5 squared is 20.25. 14.5 squared is 210.25. 24.5 squared is 600.25. 34.5 squared is 1190.25. 44.5 squared is 1980.25. 84.5 squared is 2970.25. 64.5 squared is 4160.25. 74.5 squared is 5550.25. 84.5 squared is 7140.25. and 94.5 squared is 8930.25. Now that we have the x squared values, we can find fx squared. So you multiply the f values, that is the values we have in this column, by the x squared values, that is the values we have in this column. So 4 times 20.25 is 81. 4 times 210.25 is 841. 6 times 600.25 is 3601.5. 6 times 1190.25 is 7141.5. 8 times 1980.25 is 15842. 5 times 2970.25 is 14851.25. 6 times 4160.25 is 24961.5. 4 times 5550.25 is 22201. 4 times 7140.25 is 28561. And 3 times 8930.25 is 26790.75. We need sigma fx squared, so you add all the values here, and that gives us 144,872.5. So we can now find the standard deviation. The standard deviation will be equal to square root of sigma fx squared, which is 144,872.5, divided by sigma f, which is 50, minus the mean squared. We have found the mean to be 47.3, so 47.3 squared. And this will give us 25.7. So it means that the standard deviation of the distribution is 25.7. The variance is equal to the standard deviation squared. So if the standard deviation is 25.7, then the variance will be 25.7 squared, and that will be equal to 660.49. So the standard deviation of the distribution is 25.7 and the variance is 660.49. Thank you for watching this video. Subscribe to this channel for more videos. This is the end of the videos on statistics. Bye bye.